Hi there, welcome to Simplilearn's YouTube channel. Today we bring you the Power BI full course. Power BI is a powerful business intelligence and data visualization tool that helps you turn raw data into actionable insights. Whether you're a business analyst, data professional, or aspiring Power BI developer, mastering Power BI allows you to create interactive dashboards, reports, and analytic solutions that drive decision making. In this course, you will learn everything from importing and transforming data to creating advanced visualizations, applying DAX calculations, and designing insightful dashboards. By the end, you will be able to analyze, visualize, and share data efficiently to support business decisions. This course covers introduction to Power BI and data concepts, where you'll have overview of Power BI interface and types of data sources. Next, we will dive into data import and transformation, where you will explore Power BI, cleaning, data shaping, and data modeling. Followed by that, we have data modeling and relationships. Here we'll be creating tables, keys, and relationships for analytics. Then we have visualizations and reports, where we will cover charts, tables, slicers, and interactive dashboards. Next, we have DAX or Data Analytics Expressions Fundamentals and Calculations, where we will explore measures, calculated columns, and common aggregate functions. Followed by that, we have Advanced Analytics and Insights. Here, we will learn time intelligence, KPIs, and advanced visualization techniques. After that, we have Power BI Service and Sharing Reports. Here, we will understand how to publish, collaborate, and understand app workspaces. Followed by that, we have hands-on project and practice. Here, we will build end-to-end dashboards for real-time business scenarios. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons along with the bell to get notified whenever we host. And also, without further delay, let's get started. So I hope I made myself clear with the agenda. Before we dive into the course, I want to have a small quiz for you. So here's the question. Which feature of Power BI is primarily used to clean and transform raw data before loading it onto your data model? Your options are A. DAX, B. Power Query, C. Visualizations, and the last one, Power BI Service. Please do let us know your answers in the comment section below.
This is Ben. Ben started a store that sells automobile parts like brakes, exhausts, tires, lubricants, and car interiors. He made a good start with his business and achieved profits. However, as days passed by, along with his growing business, he faced some business challenges. He received orders from a variety of customers with different needs and requirements. For example, the northern states had higher demand for performance parts than others, and the eastern states demanded farm truck parts and lubricants more. And apart from this, a few products weren't performing well in the market and remained unsold. With the unbalanced requirements and economy variations, Ben had a tough time helping his customers with products on demand. He slowly realized he needed something new that can help him tackle the store's problems. What if Ben had a tool that could keep track of his store's inventory and sales? A geographical map that can recognize the demand for various types of products from different regions. A forecast feature that could predict the economic fluctuations in the market and help Ben visualize every single detail visually on one single dashboard. This software could practically solve many business problems and also could identify new opportunities to improvise and grow the business. Such types of software tools are called business intelligence tools, and one such tool, Power BI, capable of learning the store's business patterns and running queries against the data to help visualize the flaws and resolve them quickly. Now, let us understand how Ben used Power BI and solve the issues related to his business. Ben collected his store's entire sales data from the previous quarter and ingested it into Power BI. Now Ben was able to categorize the data based on monthly sales. It took the daily sales and considered it as the x-axis. And then Power BI computed the sales in the store. Now, Ben clearly understood the products that outperformed the sales charts and the products that did not have much demand. Let us elaborate a little. Ben found that the performance parts like sports exhausts, turbochargers, and engine management systems were selling well. With the Power BI Power View forecast feature, Ben identified the demand for performance products in the next quarter. So he raised the prices on a few products that had the peak demand and earned higher profits. In the second forecast report, Ben found no significant elevation, nor a drop in the demand for the tractor parts and lubricants. Apart from this, Ben saw the sales graphs of electronics encountered a drop in the current quarter. Compared to the previous quarter, the sales of electronics, like the music and infotainment systems, were low. To improvise and stabilize the fluctuating sales of electronics, Ben came up with some exciting clearance sell offers on electronic products. Using Power BI's Map Visual feature, Ben understood the product demand at a regional level. He found the northern regions were interested in performance kits for their imported sports cars. The eastern regions had good demand for truck parts and lubricants. Using Power BI, Ben could generate various visualizations based on his data and come up with business-oriented decisions. Last but not least, Ben could also monitor his decisions and was able to make some necessary modifications to his business model on the go. Ben is now delighted as working with Power BI is a smooth and efficient process. Today, Power BI is being recognized as one of the best-in-class business intelligence tools because of its powerful and dependable features. Power BI can support and connect to a wide variety of data sources like the cloud, DBMS, Excel sheets, and even get connected to real-time data from websites. And Ben keeps his customers happy using Power BI to solve his business problems. On that note, here's a quiz for you. How did Ben realize that the performance parts will find huge demand in the next quarter? 1. Power View Forecast Feature. 2. Map View feature of Power BI. 3. Customer Reviews. 4. Sales Reports. Let us know your answer in the comments below, and 3 lucky winners will get a chance to win an Amazon voucher. Today, more and more leading business organizations are leaning towards business intelligence tools, intending to improve their business. Upon quite a success in his business, Ben decided to get a detailed understanding of Power BI by enrolling in Simplilearn's Power BI Certification Training Program, which is led by industry experts who can train him according to the current business and IT standards to make his business even more successful.
So let's get started with Chapter 1 or Module 1. So our Chapter 1 will be about a quick introduction to Power BI. Welcome to Module 1 of our Power BI full course. In this first session, we are going to build a strong foundation. Before we even touch the tool, we need to understand why Power BI exists, what problem it solves, and why companies in the current and in the future simply cannot operate efficiently without a strong analytics capability. Let me start with a simple but yet powerful observation. Every organization today is drowning in data. We have data coming from websites, CRMs, ERPs, IoT sensors, social media, finance systems, HR tools, literally hundreds of touch points. But the value of data doesn't come from the volume. It comes how quickly and intelligently teams extract insights from it. This is where Power BI becomes essential. Think of Power BI as the modern equivalent of a digital microscope. You point it at a raw, unorganized, messy data, and suddenly patterns start to appear. Trends become visible, anomalies stand out, and performance issues are revealed. Just like successful learners who improve rapidly by analyzing their mistakes and strengths, companies go faster when they analyze their data systematically. Power BI is not just a charting tool, it is a decision engine. And by the end of this course, you will understand how it allows individuals and businesses to transform raw data into insights that drive strategy, innovation, and growth. Now, let's go with the section 2 of Chapter 1. What is Power BI? So let's go deeper. What exactly is Power BI? At its core, Power BI is Microsoft's business analytics platform, but that simple definition doesn't fully capture its capabilities. Power BI performs 4 major functions. First one, data connection. It can connect hundreds of data sources like Excel, SQL Server, APIs, cloud storage, Azure, CRM systems, Google Analytics, SharePoint, and much more. Next, we have data transformation. It includes a powerful engine called Power Query that can clean, merge, shape, and prepare data through a user-friendly interface. Next is data modeling. Power BI allows you to define relationships, create DAX or data analytics expression measures, build hierarchies, and design semantic models. Data visualization and insight sharing is our next point. Finally, it enables you to present the insights using interactive visuals, dashboards, and reports. Now, here's why it matters. In traditional workflows, people often work in silos. Marketing teams prepare Excel files, finance teams use SAP or Tally exports, operations teams work on CSVs or various tools. Everyone creates dashboards independently. This leads to confusion, conflicting numbers, and zero alignment. Power BI solves this fragmentation. It creates a single version of truth. Everyone, from interns to CEOs, sees the same numbers updated in real time using the same datasets. This eliminates the guesswork, the back and forth emails, and typical who updated this file chaos. Let me give you an analogy. Think of Power BI as a GPS for business decisions. Think of Power BI as the GPS for business decisions. You provide the destination, revenue growth, and cost reduction, customer retention, and Power BI gives you the perfect route. It adapts to real-time changes, helping you make informed decisions faster. This is why companies worldwide, from startups to Fortune 500 organizations, rely on Power BI for entire decision-making ecosystem. Now, let's dive into the section 3 of module 1. Why Power BI matters in 2025, 2026, and beyond. Now, let's take a forward-looking perspective. Why is Power BI even more important in 2026 than it was in a few years ago? Three major trends explain this. Trend number 1, rise of AI-driven analytics. Power BI today integrates directly with AI tools such as Microsoft Copilot, Azure Machine Learning, and AutoML. This means users don't have to manually write formulas or DAX expressions for advanced analysis. Power BI can do a lot of things. Let's discuss a few as mentioned below. First one is suggest visuals. Copilot analyzes your dataset structure and relationships, then recommends the most effective visual formats, bar graphs, line graphs, KPI cards, based on analytical best practices. This reduces guesswork and accelerates report generation. Next is summarize pages. It automatically reads all visuals on a report page and generates a narrative summary highlighting key patterns, anomalies, and correlations. This helps stakeholders grab insights without manually interpreting each chart. Then we have creating entire dashboards. By understanding your dataset and business context, Copilot can fully generate multi-page, fully formatted dashboards. It handles layouts, visuals, interactions, and defaults, making it ideal for rapid prototyping and stakeholder previews. Up next, we have explain trends. Copilot interprets real-time series data to identify rising or falling trends, seasonal patterns, and sudden spikes. It explains the why behind the changes using natural language insights grounded in statistical signals. Next ahead, we have generate DAX calculations. Instead of writing complex formulas manually, you can describe the logic in simple English, and Copilot converts it to optimized DAX expressions or measures. This is especially useful for advanced calculations like running totals, cohort analysis, and dynamic time intelligence. This shift automatically increases productivity. Non-technical users can now perform tasks that were previously the domain of data scientists. Now let's go into the trend 2. The trend 2 is all about shift to unified data architecture, which is Microsoft Fabric. So, Microsoft Fabric is becoming the core of modern analytics architecture. Power BI now integrates seamlessly with Fabric components like Lakehouse, and Power BI can directly connect to Lakehouse tables stored in one lake, enabling unified access to structured and unstructured data without complex ETL. This improves performance, governance, and cross-team collaboration. Next is data engineering. Data engineers can prepare, clean, and transform large datasets using Fabric notebooks and pipelines, and Power BI consumes these curated datasets instantly, ensuring analysts always work with high-quality, production-ready data. Followed by that, we have Data Factory with Fabric. Data Factory scheduled pipelines move data from multiple sources into centralized storage. Power BI then reads these refreshed datasets automatically, enabling consistent automated reporting without manual intervention. Now, the next one is real-time analytics. Power BI dashboards can stream live data from Fabric real-time analytics, or also known as custom engine, supporting instant insights for IoT, transactions, monitoring systems, or operational dashboards where every second counts. After that, we have machine learning. Fabric's machine learning models can score data and write predictions back into tables, which Power BI reads in real time. This enables AI-driven dashboards such as churn prediction, demand forecasting, and anomaly detection without leaving the Fabric ecosystem. This means Power BI is no longer just a visualization tool. It's a part of an end-to-end data pipeline. Now comes the trend number 3, real-time decision making. Companies want insights as they happen, not after a month and a report. Power BI supports real-time streaming data. Power BI can ingest live event streams like IoT signal, transactions, or sensor logs and update visuals within seconds. This enables operational teams to monitor activity as it happens and respond almost instantly. Next, we have direct lake connectivity. Power BI reads data directly from Fabric's One Lake in its native format, and it can bypass imports and refresh cycles. It delivers near direct query freshness with import level performance for large scale analytics. Next is auto refresh dashboards. Power BI supports scheduled and automatic refreshes, ensuring dashboards always display the latest available data. This eliminates manual updates and maintains data consistency across teams and stakeholders. For example, a logistics company can monitor vehicle movement on live. A retail chain can adjust pricing based on real-time sales. A marketing team can track live performance of campaigns. Final thoughts? Power BI's importance in 2026 is not due to its charts. It's due to its speed and intelligence of insights. A business that operates with fast, consistent data insights outperforms competitors significantly. This is similar to how high-performance learners constantly analyze feedback and optimize their approach. Businesses that behave similarly using Power BI achieve superior outcomes. Now comes the section 4 of Module 1, Real-World Business Applications. Understanding theory is great, but what matters is real-world application. Let's look into how Power BI is used across industries, and I'll break it down by functional domains. The first one, marketing and sales analytics. Marketing teams rely heavily on Power BI for the following reasons. First one, lead generation funnel analysis, campaign return on investments, customer segmentation, revenue attribution, website and social media performance. Imagine you're running a YouTube ads campaign. Instead of manually downloading performance data, Power BI connects directly to YouTube Analytics or Google Analytics and creates a real-time dashboard showing the following visuals. So you will have a direct access to views, watch time, CTR, conversions, revenue. This allows marketing teams to optimize budgets immediately instead of losing money due to delays. The second one, finance. Finance departments use Power BI for P&L statements, expense forecasting, cash flow modeling, financial consolidation, aging analysis. The benefit is consistency. Instead of multiple Excel sheets floating around the organization, Power BI integrates everything into a single version of truth. Think of it like having an automated auditor that keeps all your numbers synchronized. Third one is HR analytics. HR uses Power BI for workforce planning, attrition dashboards, skill mapping, recruitment pipelines, diversity metrics. This helps HR leaders identify trends like which teams experience higher attrition or which skill gap can affect future growth. Now, the fourth one, operations and supply chain. For operations, Power BI acts as an operational command center. Companies track inventory analysis, manufacturing defects, supplier performance, order fulfillment times. This offers visibility from end to end, reducing bottlenecks and improving process efficiency. Now the fifth one, retail and e-commerce. In retail, Power BI is used to analyze daily sales, regional performance, product profitability, customer loyalty patterns, promotions impact, and Power BI helps these companies strategize inventory pricing and promotions. Conclusion: for this section, real-world value is what defines Power BI's credibility. Just like a learner becomes credible by consistently applying knowledge, Power BI becomes a credibility engine for organizations by delivering accurate, reliable, and timely insights. Now, the section 5 of Module 1, installing and setting up Power BI Desktop. Now let's walk through how to install and set up Power BI Desktop. Even though the process is simply straightforward, I want to explain each step, and it matters because understanding the environment makes learning advanced concepts easier later. Step 1, which is about downloading Power BI Desktop. Navigate to powerbi.microsoft.com, like the link I've shown on the web page. Go to the download section and you can download it. The second option, however, is the Microsoft Store itself. You can go to the Microsoft Store, go to the search bar, type Power BI, and then you'll get the app. You can download it from there and install in your local system. Both the steps are valid. The Microsoft Store version updates automatically, which is convenient for beginners. But if you are the person who is looking forward to continuing with the same version for a longer duration, then the first step would be better. Now, going into this step, second, installation. Choose the 64-bit version unless your system specifically requires otherwise. Once installed, launch Power BI Desktop and wait for the interface to load. Now comes the step number 3, understanding the interface. Power BI Desktop is divided into 3 major views. First view, report view. This is where you design dashboards. Second one is the data view. This is where you inspect raw data tables. And the last one is the model view, where you build relationships, define your data model. Each view plays a critical role. In the later modules, you will notice how frequently you shift between these views as you build complex solutions. Now comes the step 4, connecting to the data sources. Power BI supports over 160 plus data connectors, including Excel, CSV, SQL Server, SharePoint APIs, web data, cloud storage, Dataverse. Even IoT data can be streamed directly into Power BI. During the installation training, we typically load from a simple Excel file like financial sample or employee data or sales data to understand how columns and data types can be detected by Power BI. Now we go into step 5. The step 5 will be about configuring settings. Key configurations include regional settings, which is important for date formats, auto recovery settings, which is important for preview features like on object interaction. Next step is about enabling Copilot if available for your tenant. These small details significantly influence your user experience. Now, the conclusion. By the end of installation and setup, learners should be comfortable navigating Power BI Desktop. This foundation is essential because starting from the next module, we will dive deep into importing, Power Query, transformations, and data modeling. Now that was the end of Module 1. Now we will dive into Module 2, which is about understanding the Power BI workflow. Welcome to Module 2 of our Power BI Fill course. In Module 1, we got a complete understanding of Power BI as a tool, why it matters in 2026, and how organizations across industries depend on it. Today, now, we're going to dive deeper. This module is all about understanding the Power BI workflow, the exact step-by-step process that transforms raw, unstructured business data into meaningful dashboard that executives rely on decision-making. Think of this workflow as the operating system behind the Power BI. Just as successful learners follow a structured learning path to reach mastery, successful analysts follow a structured BI workflow to create credible, reliable business insights. Now the section 1 of Module 2, understanding the Power BI workflow. Now the part 1, what is Power BI workflow? Let's start by the core idea. A Power BI workflow is the complete life cycle of your data inside the Power BI ecosystem from the moment you import the data. Here's a sharper, insight-driven version of your end-to-end analytics workflow structure, like a value chain rather than a simple sequence. This keeps it analytical, avoids marketing fluff, and clearly highlights how each stage contributes to business decisions from raw data to decisions. The complete analytics lifecycle data import, you start by pulling information from multiple sources like CRM exports, SQL databases, API or cloud storage, ensuring the dataset represents the business data reality accurately. Next is the data cleaning. Next comes the eliminating noise step. Fixing missing values, correcting inconsistencies, normalizing formats, and validating data quality. Clean data increases reliability and reduces downstream errors. Data modeling is the next step. You then define the relationships, apply business logic, and structure the dataset into meaningful views or star schemas. This step shapes how metrics like revenue, retention, or conversion rate will behave. Visualization and insight generation is the next one. With a structured model, you build dashboards, KPIs, and trend analysis that highlight patterns, anomalies, and performance drivers. This is how you transform raw metrics into intelligence. Next, we have report deployment. Reports are then published into platforms like Power BI Service, Tableau Server, or cloud dashboards, ensuring role-based access, refresh schedules, and governance. Followed by that, we have decision enablement. Ultimately, these insights support strategic actions, optimizing campaigns, improving customer journeys, allocating budgets, and forecasting outcomes with data-driven clarity. Everything fits into workflow. This workflow is important because it ensures consistency, just like manufacturing industries follow a standard operation process. Data analytics team follow the Power BI workflow to maintain accuracy and speed across the reports. Now, the part 2. Why understanding the workflow is critical. Most beginners jump into visuals immediately. They drag a field, create a chart, and think that Power BI is just about visuals. But in real business scenarios, visuals represent only 20% of the work. The remaining 80% comes from data preparation. This is where raw inputs become analysis ready. It includes profiling data, handling missing values, correcting inconsistencies, standardizing formats, and shaping the data into usable structures. Good preparation reduces noise and ensures that upstream modeling remains stable. Modeling. The key goal here is to translate business logic into logical data structure. Fact and dimension tables are organized using schemas, hierarchies, calculated tables, and metric definitions mirror how the business measures revenue, performance, or customer behavior. A strong model determines the accuracy of every insight downstream. Followed by that, we have DAX. DAX is the analytical engine behind meaningful metrics. It enables time intelligence, filter, context manipulation, rolling calculations, and KPIs that behave dynamically. When models reflect structure, DAX inject intelligence, turning static data into performance-driven measures. Engineering proper relations is the next step. Correct relationship ensures context flows accurately across the tables. Cardinality, direction, and granularity must align with the business process. Proper relationship engineering prevents ambiguity, avoids circular dependencies, and ensures metrics aggregate exactly as intended. Understanding the workflow helps you avoid broken dashboards. A clear workflow ensures every step, data ingestion, transformation, modeling, and visualization follows a predictable structure. This minimizes mismatched fields, broken visuals, and errors that surface when datasets change. Next is all about understanding how filter contexts go through your model prevents inflated or deflated numbers. Proper modeling plus DAX discipline ensures totals, subtotals, and KPIs reflect real business logic instead of accidental aggregations. Next, we have an important step, which is about fixing performance issues. A structured workflow highlights where bottlenecks originate, heavy queries, poor relationships, unnecessary calculated columns, or non-optimized DAX. It helps you diagnose and fix slow dashboards where they impact the users. Build scalable reports is our next step. When the workflow is consistent, your reports scale gracefully with new data sources, additional KPIs, or even larger datasets. A clean pipeline reduces redesign effort when businesses need to grow. Reduce refresh failures is our next step. Clear preparation and proper modeling reduce schema, mismatches, query timeouts, and dependency problems. Your data pipelines remain stable even as refresh volumes increase. Next, after that, we have create data that business teams can trust. A disciplined workflow results in consistent, predictable metrics. Team sees the same numbers everywhere, which strengthens confidence, supports decision making, and ensures your dashboard becomes the single source of truth. Basically, it helps you protect data credibility, which is the foundation of analytics. Now we enter the part 3 of module number 2, the 5 pillars of Power BI workflow. The first one, data collection. This is the starting point. Power BI connects to more than 120 plus data sources including Excel, SQL, SharePoint, Web APIs, SAP, Oracle, Snowflake, and so on. Data usually comes in different formats: flat files like .csv, operational databases, analytical warehouses, cloud platforms, streaming data sources, and a lot more. In real-world companies, data is scattered. One team keeps Excel files, another has SQL databases, marketing uses a CRM, sales uses a different system. Power BI becomes a centralized platform where all these data sources converge. Now, the second one: data transformation, Power Query. This stage is one of the most important one. Think of Power Query as the data cleaning refinery. Just like crude oil cannot be used directly, it needs to be refined. Raw business data needs cleaning before it is usable. Power Query handles many important stages like removing duplicates, fixing headers, splitting and merging columns, converting formats, handling null values, replacing errors, joining tables, cleaning inconsistency, category naming, creating calculated columns, and a lot more. This stage ensures the data is trustworthy, and without trust, no dashboard is valuable. Now comes the third pillar: data modeling. This stage is where Power BI becomes the most powerful. More than Excel, data modeling is the process of structuring your data for analysis. This is the blueprint that decides how Power BI calculates numbers. Key elements include fact tables. These hold numerical, event-based data such as sales, transactions, or clicks. They represent what happened in the business and typically contain high volumes of rows. Facts drive aggregation and they are the backbone of KPI calculations. Dimension tables are the next ones. Dimension tables describe the business context like customers, products, states, regions, or employees. They enrich fact tables with attributes that help slice, filter, and segment the insights. Dimensions make reports interactive and meaningful. Star schema. A star schema places a central fact table at its core connected to multiple dimension tables. This structure improves performance, simplifies DAX, and ensures clean filter propagation. It is the recommended modeling standard in Power BI. Relationships. Relationships define how tables connect and how filters move between them. They determine the analytical behavior of visuals and calculations. Strong, properly configured relationships eliminate ambiguity and guarantee accurate results. Cardinality. Cardinality is described as the type of relationship. There are many types of relationships: one-to-one, one-to-many, many-to-many, and many-to-one are the basic examples. The correct cardinality ensures that data aggregates properly and prevents unexpected duplication or mismatches when calculating KPIs. Cardinality. Cardinality describes the type of relation. So the types of relation can be of different ones: one-to-many, many-to-one, one-to-one, and many-to-many. The correct cardinality ensures the data aggregates properly and prevents unexpected duplication and mismatches when calculating KPIs. Now let's go through cross-filter directions. Cross-filter directions determine how filters flow: single direction, which is the most common one, or the bidirectional one. Single direction keeps the model stable, while bidirectional is used carefully for specific scenarios like many-to-many relationships. Now let's go through DAX measures. Measures convert raw data into meaningful business metrics such as revenue, retention, or year-on-year growth. DAX leverages filter content, time intelligence, and aggregates to produce accurate dynamic calculations across reports. A strong model ensures reports run faster, numbers aggregate correctly, filters work properly. You can slice and drill down insights. Companies heavily invest in modeling because it reduces conflicts such as wrong totals, duplicate counts, slow performance, and confusing visuals. Now, let's deal with visualization and storytelling. Most people think dashboards are equal to visuals, but visuals without a narrative are incomplete. Visualizations include the following: building charts, choosing the right visual type, using slicers, adding filters, highlighting KPIs, and structuring pages. Good dashboards answer business questions such as what happened, This focuses on descriptive analytics. Dashboards summarize historical performance, sales, traffic conversions, production output, or customer activity. The goal is to provide a clear, immediate snapshot of business performance without any ambiguity. Now, the next one is, why did it happen? This moves into diagnostic analytics. Power BI allows teams to drill down, segment data, compare cohorts, and analyze patterns that explain the drivers behind the results. It helps identify root causes, pricing changes, seasonal shifts, operational issues, or marketing impacts. Now, followed by this, we have what will happen next. This represents predictive analytics with features like forecasting, machine learning models, to fabric and trend analysis. Power BI helps anticipate future behavior, expected sales, customer churn, demand spikes, or risk exposure. What action should we take is the next question. This question supports the prescriptive analytics. Dashboards guide decision making by highlighting opportunities, risks, and required adjustments. Whether it is reallocating budgets, optimizing workflows, targeting profitable segments, or improving supply chain operations, insights translate directly into actions. Your goal as an analyst is to convert the data to insight and insight to action. Now comes the fifth point, publishing and sharing governance. Once the report is ready, it must be delivered to the right audience. So the right audience could be managers, sales leaders, finance heads, marketing teams, or operation teams. Power BI service enables cloud-based sharing, row-level security, data refresh scheduling, collaboration with teams, integrations with teams, Excel, SharePoint, etc. This final stage ensures business users get reliable, updated dashboards without manual effort. Now let's go to the section 2, which is about overview of Power BI desktop, service, and mobile. So the part 1 in this is about Power BI desktop. So Power BI desktop is where 90% of the analytical work happens. This is your development environment, the workshop for building analytics. Now let's go with the key functions. The key functions are data import. This is the entry point of the Power BI workflow. You pull data from files, databases, cloud systems, APIs, or enterprise warehouses. The objective is to bring raw data into the environment efficiently while preserving the structure, precision, and metadata. Next is data transformation. Using Power Query, the raw inputs are cleaned, structured, and standardized. This stage fixes errors, handles missing values, merges tables, applies business rules, and reshapes datasets. Clean transformations reduce downstream complexity and ensure consistent analytics. Now, let's go with model design. Here, data is structured into logical schema, typically fact and dimension tables. Proper relationships, cardinality, IRR, and data granularity are engineered to support accurate slicing, filtering, and aggregation. A strong model is the backbone of reliable dashboards. Now, let's go with DAX calculations. DAX converts the model into intelligence. Measures define KPIs like revenue growth, conversion rates, year-on-year performance, and operational efficiency. Good DAX respects filter context, enables time intelligence, and enforces business logics across visuals. Report creation visuals are built to communicate insights clearly. Charts, maps, tables, KPIs, slicers, and storytelling elements. Reports aim to answer business questions, highlight performance trends, reveal drivers, and support decision-making through clean, intuitive design. It has a very structured interface. Now, let's go with that. The first one is the report view. This is the canvas where the insights come to life. You build visuals, arrange layouts, apply themes, and craft the storytelling layer of your dashboard. It's designed for rapid experimentation, letting you iterate on charts, KPIs, and interactions that answer business questions. Now, the second one, the data view. This view lets you inspect the transform table outputs row by row. It's used to validate common values, check data types, and verify the results of Power Query transformations. Analysts rely on it to ensure data quality before modeling and DAX creation. The last one is the model view. Here, you design the logical structure of your dataset. Tables, relationships, cardinality, filter directions are managed visually. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across dimensions. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across all the dimensions. Now let's discuss about the visualization pane. This pane provides full library of charts, maps, KPIs, matrices, and custom visuals. Each visual has configurable properties, formatting, interactions, data roles, conditional formatting that help turn raw data numbers into strong analytical narratives. Now, let's go into the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. Now, let's go with the data fields pane. This lists all tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates reporting efficiency. Analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2, Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedding reports into websites, row-level security, and collaboration in Workspace. In 2026, Power BI Service is deeply integrated with Microsoft Fabric and Microsoft Copilot. Microsoft Fabric brings data engineering, data science, real-time analytics, warehouse workloads, and lakehouse architecture, all inside the same environment. This makes Power BI a front end for entire modern data stack. Now let's go through the part 3, Power BI Mobile. The third component is the Power BI Mobile. This is crucial for decision makers who are always on the go. Executives want quick snapshots, alerts, sales performance, market trends, and operational bottlenecks on the go. Power BI Mobile allows them to monitor business performance in real time. Many companies rely on mobile dashboards during morning sales stand-ups, weekly reviews, executive board meetings, and many more. Together, the desktop, service, and mobile form a complete ecosystem. Now, let's dive into the section 3. Typical workflow explained with some examples. So let's consider an example. Retail chain with 50 stores. Let's look at a practical example. You're a business analyst for a retail company that has 50 stores across the country. Now the management wants a dashboard showing daily sales, category-wise performance, store revenue, and top-selling products. Now let's walk step by step through how you build it. Step 1. Connect to data. You connect to Excel for daily sales, SQL Server for inventory, CSV export from POS. Power BI combines all these 3 data sources seamlessly. Step 2. Clean the data. In Power Query, you fix the category mismatches, remove duplicates, correct date formats, merge store metadata, handle missing values. You ensure that the data satisfies real-world business logic. Now comes the step 3. Build the data model. You create a star schema, fact sales, dimension product, dimension store, dimension date. You establish relationships. Then you write DAX measures like total sales, profit margin, average basket, size, year-on-year growth. Now, the model can answer the business questions almost instantly. Now comes the step 4. Build the report. Your dashboard includes a line chart for monthly sales, a bar chart showing category contribution, a geographical map showing store performance, KPIs highlighting revenue tables, listing top products, filter for store, category, and date. Users can now drill down from total sales to city to store to product. Now, let's dive into the step number 5. Publish the report. Power BI Service is your option. You can publish the report, then you set frequency, define permissions, create dashboards, distribute to leadership teams. Now, the entire organization uses your dashboard. Now, with that, let's dive into the section 4. Key components of Power BI interface. The first one, ribbon. This includes home, insert, modeling, view, and help tabs. Each controls a different part of the workflow. The second one is the views pane. This includes report view, data view, and model view. Each view offers different angle of analysis. The third one is the fields pane. This shows tables and fields. A well-structured field pane improves efficiency. The fourth one is the visualization pane. This is where you select charts, customize visuals, change colors, enable analytics lines, and format your visuals. Now, the fifth one is the filters pane. Filters allow control over what data appears on the report page or a visual. Then comes the sixth one, which is canvas area. This is where visuals come together and form a meaningful story. And with that, we have finished the module 2, and now we make a transition to the module 3, which is based on connecting to data sources. Next comes the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. The data fields pane is the next one. This pane lists all the tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates report efficiency, and analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2. Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are pulled and published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedded reports into websites, row-level security, collaboration in Workspace. In 2026, databases, cloud services, real-time streaming systems, APIs, big data engines, enterprise solutions, Microsoft Fabric and Azure resources, and a lot more. Data connectivity is the backbone of every Power BI solution. And in this module, you'll understand not only how to import data, but also why certain methods are chosen in real-world business environments. Now, the section number 2 is about importing data from Excel. Let's begin with the most common and beginner-friendly data source, which is Excel. Excel is still one of the most used analytics tool in the world, making the perfect start point. How to import Excel data? You can open the Power BI dashboard, go to Home, Get Data. So browse and select your file. Power BI displays the Navigator window showing available sheets and tables. Don't worry, this is just a quick theoretical approach. Once this is done, we will be directly diving into the demonstration mode where we'll practically explore all these. Now, once you see the available sheets and tables, select the required items and click Load or Transform Data based on your request. Repeat. And click on Load or Transform based on your requirement. Then comes the important concepts. If your Excel file uses names, tables, Power BI treats them as clean structured objects. If your Excel file uses plain ranges or messy layouts, Power BI still imports them, but you will need Power Query to clean them later. Now, business relevance. Excel is widely used for monthly sales reports, budget, financial transactions, campaign tracking, ad hoc department level reports. This means data analysts frequently integrate Excel with larger systems like SQL Server, CRM data, and a lot more. Now let's also discuss some common issues and best practices. Ensure the first row contains column names. Avoid merged cells. Power Query struggles with them. Keep date formats consistent. Try to use tables instead of raw ranges. Now let's go through an analogy. Think of Excel data as manually entered or department. Now, let's go through an analogy. Think of Excel data as manually entered or department level data, like a student's personal note. They help with context, but they often require polishing before being shared. Now, let's go through the section 3, which is about importing CSV data. CSV files are often another common data source, especially for exports from applications, websites, or tools. Now, how to import CSV? The same. Go to Home, Get Data, then you choose Text or CSV option. Select your CSV file. Power BI automatically detects column delimiters and data types. It also shows you a preview. Click on Load or Transform Data based on your requirement. Why CSV is important? CSV is a universal format used across marketing platforms like Facebook ads, Google ads, e-commerce reports, CRM systems, ERP exports, social media analytics, automation tools, payment gateway logs. CSV files are lightweight, system-friendly, and easy to automate. Now, let's go through some key differences between Excel and CSV. CSV does not support formulas. no formatting, no multiple sheets, faster for automation and ETL pipelines. So basically, every CSV cannot be Excel, but Excel can be turned into a CSV. Now, let's go through some best practices. Treat CSV files as raw system output. They usually require data cleaning, but ensure more consistency because they don't contain any formatting errors. Now, let's dive into section 4, which is about connecting to web sources. So, next we explore one of the most powerful features, which is web data sources. Power BI can connect directly to websites or APIs and fetch structured data. Go to the Get Data option, enter the URL by choosing the web option. Power BI loads the HTML or JSON content, select the required table or hierarchy, transform it and load it. For example, extracting stock market data or pulling cryptocurrency prices or getting live COVID-19 data, weather statistics, reading product listings, import government datasets, and a lot more. You can also go with API-based data like YouTube Analytics or Google Maps data and a lot more. Now let's also discuss a small use case. Imagine a company that wants daily currency conversion rates. Instead of manual downloads, Power BI can fetch real-time rates through a web API and keep dashboards always current. Now a small keynote, when using APIs, authentication may be required. API keys, tokens, OAuth, etc. Now let's also go through an analogy. Web data is like tapping into a live knowledge source. Similar to how learners use online platforms to stay updated instead of static files. You get dynamic, evolving information. Now let's go through the section 5, which is about connecting to databases. This section covers the enterprise grade side of Power BI, which is about connecting to databases. In professional environments, the most critical data lives in SQL servers, Azure, SQL, MySQL, Postgres Server, Oracle, Snowflake, Databricks, Azure Synapse, data warehouses, or lakehouses. Basically, anything which is a database online or on a data server. Power BI connects seamlessly to all of them. SQL Server connectivity steps are as follows. Same, you need to go to Home, select the Get Data option, and select SQL Server or any of the database where your data is existing. Enter the server name, database name, which is completely optional. Choose the import query option, dual mode, provide credentials, select the tables that you need on your Power BI window, and then based on your requirement, either transform the data or load. SQL Server is extremely common for storing sales transactions, customer data payment, information, inventory, employees, employee data, ERP data, CRM data, and a lot more. Why it matters is the next question. Database connections allow you to integrate large, structured, professionally maintained datasets. This gives your report enterprise credibility, similar to how a researcher gains credibility by referencing authoritative resources. Now, Azure Cloud Database Connections, Azure SQL Database, fully cloud-hosted SQL database used by modern businesses for scalability and low maintenance. Azure Synapse Analytics. So Azure Synapse Analytics is an enterprise warehouse for big data and analytics. Azure Databricks for AI and ML and large-scale data processing. Azure Data Lake for massive unstructured and semi-structured data storage, business-relevant insight, cloud database support, real-time dashboards, large data volumes, global reporting, multi-department analytics, and a lot more. Companies adopting cloud architectures rely heavily on Power BI to interpret their cloud data ecosystem. Now we enter the section 6. Data load versus data import versus data query. This is one of the most important concepts in Power BI. How to load your data determines the performance of your report, the freshness of your insights, size of your dataset, the speed of processing. So now let's break down the 3 modes the Power BI offers. The first one, import mode, and how it works. Data is copied from the source into Power BI's internal storage, and it is through VertiPack engine. Fast performance, best for dashboards that don't require second-by-second updates. Now, where is this ideal? It is ideal for small to medium datasets, analytics dashboards, visualizations, monthly or weekly reporting, and it deals with Excel plus CSV plus SQL tables. Now, let's also discuss the benefits. It is extremely fast in queries, full Power BI functionality, compression can be done up to 10 to 20 times, and there are also some limitations. Let's go through them. Data size is limited, not suitable for real-time systems, and let's also discuss some of the real-time examples. So one of them is monthly sales report where data refreshes every morning. Now the second type is direct query mode. Now let's discuss how it works. Data stays in a database. Power BI queries the source in real time. No data is stored in the Power BI itself. It is in the database. Now where it is ideal? It is ideal for real-time dashboards, very large databases, enterprise level systems like SAP, Oracle or Synapse. Now let's also discuss the benefits. Always fresh data, no dataset size limitations. And apart from these, we have some disadvantages. Let's go through them. It is slower in performance. Many DAX features are unavailable. Load depends entirely on the database and visuals refresh very slower. Let's also discuss one of the real world examples. A logistic company monitoring real-time vehicle movement is a perfect example for this one. Now comes the third one, which is about the live connection. It is mainly used with analysis services, Azure analysis services, Power BI dashboards, Microsoft Fabric semantic models, and a lot more. It behaves similar to direct query but optimized for enterprise models. Now, what's the key decision rule here? Choose import mode unless you need real-time insights, your dataset is too large to import, your company mandates live connection for governance. This decision is strategic choice similar to selecting the right learning strategy. This decision is strategic choice similar to selecting the right learning strategy, which is like memorizing versus understanding versus applying. Each has strengths and constraints, and choosing the right method enhances efficiency. And with that, we have come to the end of module 3 and we transition into the module 4. So the module 4, which is all about data transformation with Power Query Editor. So welcome to module 4 of our Power BI course. In this module, we will explore Power BI's Power Query Editor and one of the most essential tools in Power BI for preparing and transforming data. Think of Power Query as the foundation of your analytics workflow. Without a strong foundation, even the best dashboards can give misleading insights. Cleaning and transforming data ensures that reports are accurate, reliable, and actionable. In this real world, most datasets are messy. They contain nulls, errors, duplicate rows, inconsistent formats, or unnecessary columns. Power Query gives you the tools to handle all of these in one go. Power Query helps you with repeatable automated way where you can once define these steps and Power Query will take care of them in the flow. Now, the section 1, Introduction to Power Query Interface. When you open Power Query, you will see a structured workspace designed to make transformation easy and intuitive. At the top, we have the ribbon. It contains tabs like Home, Transform, Add Column, and View. Each tab provides key commands for shaping your data. And on the left, you see the Queries pane, which lists all the tables and queries in your project. You can select Rename or Reference queries from here. The center of the screen shows the Data Preview grid, where you can see your data table and apply transformations. On the right side is the Applied Steps pane, where every change you make to your data is recorded as a step. And this step-by-step process is extremely powerful. It allows you to track, edit, or remove any transformation without starting over. Finally, at the top, there's a formula bar where the displays. Finally, at the top, there is a formula bar which displays the underlying M code for each transformation. Even if you never write the M code manually, understanding that it exists helps you appreciate how Power Query automates and records your steps. Now comes the section 2, Cleaning the data, removing nulls and handling errors. Data cleaning is often the most time-consuming part of any analytics project, but it is also most critical. Let's start by null values. Null values appear when the information is missing in a dataset. For example, a customer record might not have an email address, or a sales transaction may be a missing discount, or a lot more. In Power Query, you can choose to remove these null values. Replacing nulls is usually better than removing them completely, especially when the missing value has a business meaning. For example, a null discount might simply mean the product was sold for a full price. You can replace nulls with zero, average values, or even label them as unknown depending on the context. Next, we have handling errors. Errors occur when data is incorrectly formatted, calculations fail, or conversions don't work as expected. Power Query lets you remove errors, replace them, or investigate them. For instance, if 50 rows of date values fail to convert, you can check why. Perhaps the format was inconsistent or the data was entered incorrectly. Lastly, let's talk about the duplicates. Duplicates can inflate metrics and distort insights. Power Query allows you to remove duplicates either across entire rows or selected columns. But be careful. Sometimes repeated entries are legitimate, such as multiple orders from the same name or the same customer. Always analyze before removing any duplicates. Now, with that, we enter the section number 3, which is about the column transformations. Once your data is clean, the next step is about transforming columns to prepare them for analysis. Changing data types, every column has a data type, such as text, number, date, or Boolean. The correct data type is critical because calculations and visuals rely on them. For example, if your sales column is text instead of a number, sums and average will fail. Splitting columns. Splitting columns is useful when a single column contains multiple pieces of information. For example, a full name. A full name column can be split into first name and last name. Similarly, a product code like PRD123USA, which can be split into category, ID, and country. Extracting values from Power BI allows you to extract specific parts of the column. First characters, last characters, ranges, or patterns. You can also extract years from dates, domains from emails, or UTM parameters from marketing URLs, conditional columns, or UTM parameters from marketing URLs. Next is conditional columns. Conditional columns let you create logic directly in Power BI query. For example, if revenue is greater than 50,000, mark the row as high value customer. This ensures that business logic is applied before the data reaches your visuals. Next is group by. Grouping helps you summarize granular data. You can calculate total sales by region, average orders value by product, or counts by the customer. This is particularly useful when preparing large datasets or dashboards. Now we enter the section 4, merging queries. Merging queries in Power BI is equivalent of SQL joins. You can combine multiple tables to enrich your dataset. For example, you might have a sales table and a customer table. By merging them on customer ID, you can add customer names, regions, and other attributes to the sales table. Types of joins include left join, right join, inner join, full outer join, and anti-joins. Merging is essential in real-world analytics because data often resides in different systems. By merging correctly, you can create a unified dataset that drives reliable insights. Now we enter section number 5, pivot columns. Pivoting converts row values into column headers. For example, if you have monthly sales in rows, pivoting months turns them into separate columns for easy comparison. Pivoting is often used when creating matrix-style dashboards. Unpivot columns. Unpivoting does the opposite. It converts columns into rows. This is particularly useful when you receive wide format data such as budgets or survey results because Power BI works best with long format tables. Now let's move into advanced splitting. Beyond simple splits, you can handle complex cases. Splitting product codes into multiple dimensions, extracting UTM parameters from URLs for marketing analysis, separating full names or addressing into components. Mastering pivot, unpivot, and splitting gives you full control over how data is structured, ensuring that your models are both clean and analysis ready. Now, the conclusion to the Module 4. To summarize Module 4, Power Query Editor is the backbone of Power BI. It allows you to clean, transform, and reshape the data in a repeatable and efficient way. By mastering these skills, cleaning nulls and errors, transforming columns, merging queries, and pivoting and unpivoting data, you ensure that the data feeding your reports is accurate, reliable, and structured for analysis. In the next section of this module, we will dive deeper into demonstration of data connections on Power Query, where we will use these clean and transformed datasets to build relationships, create measures, and enable advanced analytics. So now we are in the part B of Power Query. So part B of Power Query is all about importing data from multiple variety of sources. So your data can be in a cloud storage, in a database, in an Excel file, in some folders, in PDF, in WebPreet, which can be analyzed is your data for your Power BI. That's the source for you. So Power Query helps you with that. It can extract the data from any source you get to it, and it will make the data ready for exploration, insights, and analytics. Now we will be exploring that particular tool in our session for today. So let's go with the dataset that we are dealing with today. So in this particular demonstration, we will be using Excel files, folders, and we'll also using web scraping for our data set. And these are the wide variety of data sets that we will be dealing with today. And we'll also be performing some merging and joining operations as well. So let's get started with the simple data set for now, for learning purposes. So this is our employee data set. So we have the first column, which is name column. The second column is the gender column, the department column, salary location, and the start date as well. So in the first column, we have unique names, and in the second column, we have gender. So this particular data set has some elements missing, right? You can see in the gender column, we have some blank cells as well. And in the department column, we have a lot of options: business development, training, engineering, research and development, product management, support, human resources, etc. But along with that, we also have few departments named as nulls, right? So remember this. In a few situations, you might recruit an employee, right? Here you can see this particular employee was recruited in the year of 2025. So maybe he's on bench period. So maybe he's an intern, or maybe the company just hired him based on the company's requirement. He might be moved into a dedicated team. So there was a little misunderstanding or something going on in process to dedicatedly appoint that employee to a specific domain, right? And apart from that, if you see the salary section, you also tend to see some blank columns or blank rows or blank cells, right? So no blank columns, it's blank rows actually. So you can see another blank here. So these are a few inconsistencies that we have in our data set. And apart from that, if you see the location details, in the first row, you can see 3 Redmond Bay Bellevue and Washington, USA, right? So the problem is, let's say you wanted to extract the country, but you might feel we have this particular data in a comma separated, format. So you can quickly go to data validation and separate the columns based on delimiter. But is it the same? No. If you expand this particular cell, you can see this particular data is entered in a new line, but not comma separated. So that's the problem, right? And how would you apply split or delimiter based data validation here? That's difficult. But Power Query has a good tool for yourself. So the thing is, you can explain Power BI what your intention is. Like, let's say you just extracted the first or last few words of your particular location. Let's say, since this is USA, I want to extract the last 3 letters in this particular location. You can extract it. But down the line, if you have different countries, maybe Australia, then what it does is it will separate only the last 3 letters of Australia and the rest will be left out. So this is not the way you want to work with your data set, right? So for this, you might have to work in detail with your formula. You might have to struggle writing the formulas for that, but don't worry. If you're not so strong with the formulas and if you're facing tough time to recognize the text character based functions, you can just write few cells. It's like flash fill in Excel. You can explain your intent to your Power Query tool and it will understand what you're trying to extract, and based on that, it will extract the data for you. As simple as that. We will be also working on that. And lastly, we have the start date column. So this is the rough overview of our data set. Now let's go to Power Query. So for that, you might have to go to a new blank workbook. So we can continue with Excel here, but you can also continue with Power BI as well. Why Excel? Because the Power Query interface will be completely same compared to Excel as well as Power BI. So both are Microsoft products. So on Power BI as well as Excel, you will have the same interface for Power Query. So for learning purposes, let's also explore Power BI as well. Now let's create a blank report. And here you can see the get data option, same like Excel. So if you go to data, here you have the get data option, and you have a wide variety of sources you can choose from. Excel, you can choose from text or CSV, you can choose from XML, you can choose from JSON, you can choose from .pdf, or you can also provide a folder. So we'll also deal with the folder option. So in the future use case, we will be creating a sales dashboard. where we will be having year-on-year data set. So we'll be having a data set from 2020, 2021, 2, 3, 4, 5, and 6. So you will have a wide variety of sales files, and that particular folder will be saving all these files. Let's say tomorrow you'll have 2026 data or 2027 data on future data sets. What you can do is just drag and drop the file in that particular folder, and Power Query and Power BI Desktop will automatically understand new data has been added to the file, and it will run all the steps we have made Power BI or Power Query to learn and get the data ready for analytics. So you'll also be exploring that. And apart from files, you also have a database. So here you can get connected to SQL Server database, Microsoft Access database, analysis services, SQL Server analysis. And apart from that, you have Azure. So we also have Azure, as we discussed in the part 1 of this particular module, the 4th module. We also can connect to Azure as well as Azure Data Explorer. So you need to have some credentials for that, but don't worry. So for the basic understanding purposes, we'll be dealing with the website data, we'll be web scraping the data, we'll be loading data from files and Excel documents, etc. And you also get some other sources as well. You can, as we discussed, the web and ODBC, OL, EDB from picture. You can also post a single picture, just like AI does today. You just post a picture, it will build websites for you, it will extract the data for you. So the same feature is also integrated into Microsoft Power Query as well. You can combine queries where you can append the data or merge the data. Similar to SQL join operations, you can also Power Query editor, you can launch it, and a few more query options. Let's say you wanted to edit a particular step. Okay, when we dive into the Power Query editor, you will see the steps on the right-hand side and the queries on the left-hand side. So based on that, if you wanted to edit a particular step, you can also do that. So this was the option from Excel. Apart from this, if you go back to your Power BI window, you can see a similar interface. You can go to Get Data, and you can also go to More here. And you have you have File, a database, Microsoft Fabric. So remember Microsoft Fabric, it's the new integration into Microsoft Power BI for data. So it's like a data lake, and you have Power Platform, Azure Online Services, others, right? So I think you already know the detailed differentiation between a data warehouse and a data lake. So roughly, a data lake is where you don't have organized rows and columns. It's like you'll have a wide variety of resources. You have images, multimedia, and all of those, and you can choose. This particular data lakes are very essential for machine learning purposes. You can choose what type of data you want to deal with, and you can directly access it. You don't have to modify and forcefully store the data in dedicated columns and rows. So those are data lakes. You can also explore that further in the data lakes tutorial on our channel. So apart from this, these are the data sources. You can also connect to a SQL Server, Access database, and a lot more. So let's go back to the basics. So we are on the new Excel spreadsheet here. Now all we need to do is quickly import the data from the Excel file. So I'll go with the Excel dataset, and the first dataset that we will be exploring is Excel workbook. So I'll be selecting the Excel workbook here. Now we need to navigate. Let's give it a little time to open the browser window. So my data is in downloads. So Power Query examples, datasets, and here is the employee dataset that we were discussing previously. So click on import, and it will take a little bit of time to load the data. It's establishing a connection. Now, any moment you can see a Power Query window. So there you go. So here you have just one file that's showing you the preview directly. In some situations where you have multiple files, just like we discussed before, sales data from 2020, 1, 2, 3, 4, 5, 6, and beyond. In those scenarios, you might just have one file available for you on the preview. But in case if you wanted to see all the files, you have a little option here, the checkbox, which says select multiple items. So if you just click on it, it will give you all the datasets available in that particular file. Now, I just have one, so you can just click on that particular data and you have a quick preview. So when you click on the dataset here, when you uncheck this, you cannot see the load options, right? But if you click on this, you can unlock or activate the load, transform data, and cancel options. So what these does is, let's say you're completely happy with the data you have. We know that your particular data set is completely clean and ready for analytics. what you can do is you can directly load the dataset onto your analytics platform. But now it is Power BI, right? You can directly load the data into Power BI and get started with your analytics like building charts, graphs, even dashboards, interactivity. You can add filters, slices, etc. But in case your data is completely raw and you need to manually filter it, then you need to go to the transform data option. So now, since we know that our data set needs some cleaning, we will click on the option that says transform the data. So click on transform data, and soon you have a quick Power Query window. So as we discussed, the right hand side will be the steps, applied steps will be recorded. And on the left hand side, the queries that we are applying on our data set. So in case if you wanted to edit any query, you can quickly come to this section and choose to edit the options. And on the right hand side, we can see already Power Query window has took the liberty to make some changes to your dataset, right? So the first one is it chose the source, then it navigated the source, and it promoted the headers. So what has promoted the headers? If you go back to the dataset, here you can see the first row is name, gender, department, salary, location, and start date. So Power BI's Power Query or Excel's Power Query was intelligent enough to understand that the first row entry is the metadata or column header, or you can call it the name of the column in most layman's terms. So it understood that this is the row header, so I need to push this as the column header or the row header, and it took the liberty to do that. And apart from that, it also took the liberty to change the data type. So if you come back to the original data set, you can see it understood the format. So we have the dollar symbol, right? It automatically understood that this particular number should be a whole number because this is a salary number. And the location details are automatically set to character. You can see the ABC logo here, and you can see the 1.2 symbol, which means the whole number with decimal points. And you can also see the ABC character data type for department, gender, and name, right? So these are the few steps which Power BI took the liberty to help with us. And now let's go with the first requirement that we were talking about. In the original dataset, we had some errors, right? So we had some null entries. So we need to change that. So here you have the option. But before we begin with any operations, let's have a quick overview on the ribbons we have. So here you have the close and load option. This is the most important one. Whenever you apply all the steps you need and you're happy with the dataset transformations, then you come here and choose the option to close and load. What this basically does is it saves all the transformations that you apply to your dataset and saves them, and then loads the data to your Power BI platform or any platform you choose. So you have two options here: load, right? Close and load directly. Or if you choose a different one, let's say you wanted to load to the Power BI platform, you can choose that. So the default close and load will load this particular data to the Excel because we're working currently on Excel. So that's how it works. And next comes the refresh preview option. Now, what is refresh preview option? As we discussed, in a file, there could be chances that you might add new data eventually. So whenever new data is added eventually, you just need to click on the refresh preview and Power BI will automatically understand there is new entry for the data, and what it does is magical. It takes its navigation directly to the applied steps. So here it changed or applied a few steps here. So it again changes the data type. It changes the promoted header step. It will remove the first row and it will automatically think this is the column header and it will promote it to the column header. And apart from that, if we are going to perform some operations here, like adding others to the gender column and changing the null value to engineering or any dedicated department, and then in salary section, if you remove the null values and then if you separate the country from this particular location column, it will record all those steps and it will automatically implement these new steps. These particular steps onto the new data. And you don't have to do this repeatedly. The most important aspect of using Power Query is automation. So the entire part of your data transformation will be automated. And whenever you load new data, you don't have to, worry about anything. Power Query will handle all the transformations and gets your data ready for your next step, which is data visualization. That's the magical part of Power Query. And apart from that, you have properties, manage, and choose columns. If you go to choose columns, let's say I just want name and department here. Now what I can do is I can choose the columns and then it will give me a window. So let me go ahead with that. So it will give me a window where I have the liberty to choose whatever columns I want. Let's say I want to go with name and department. It will give me only name and department and any other things which you want to go ahead with. So that's the best one. And remove columns. So here you can see promoted to headers, right? But in case if let's imagine that our data set had some misconceptions, like the first column or the first row was completely empty. In those scenarios, Power Query will consider that empty row or an empty column as a null value. And we don't want that null value. In those scenarios, you can choose to remove that particular column or that particular row completely. And you can see a similar option here, keep rows and remove rows. And the similar options like Excel, where you can sort the data in increasing order or decreasing order. And remember the column splitting that we spoke about, the data validation option that we used to have in regular Excel, where it identifies the delimiter and splits the data into columns, right? So that option is here, and you can also go ahead with group by options and use first row as headers. So this was the step I was talking about. Power Query automatically did that for you. You don't have to worry about it. And replace values, we'll be using this replace values. So the first place where we have to use these is replace the null values with a dedicated value you want to add in. And apart from that, you have merge queries option, append queries option, and manage parameters, data settings, and a few others. And here you have the transformation option where you can transpose the data, reverse the rows, count the number of rows, use first row headers. You can fill some data sets, and you have pivot and unpivot columns option here. We'll also be exploring that. And you have extract the data, parse the data, statistics, standard deviation, and scientific columns. And you also have a date option here because we have date column here, right? And you can also choose to add some customized columns as well. Remember the column I told about where you don't have to worry about the formula. You just have to explain Power Query what is your intention and it will extract the data for you. That's the one here. So you can choose to have a custom column, or you can also choose this particular one. Our requirement is column from example. So you will add a new column. You will provide few examples from the location. You'll just write USA, and in the next one you'll write the next country, which is New Zealand, NZ, and so on. So based on your requirements, based on what you're applying, it will think like you. It will understand your thought process, and based on that, it will help you extract the countries. That's magical, right? So no worry, we'll also go through that in a moment. And the last one is conditional column, duplicate column, all those. And the last one is the view one here. So you have formula bar. Okay, remember the formula bar. For now, you have this particular formula bar. Let me highlight that, right? So I've done this a few times, so I have this particular column option available. So in few scenarios, if you're new to Power Query, in very rare scenarios, the formula bar is not visible. In such scenarios, what you can do is you can go back to the view option and enable the formula bar so that you can see this particular formula bar and see what is the operation being run on your particular data set. So this was the quick overview of your ribbons on Power Query window. Now let's go back to the home ribbon, and here the first operation, department. So we will be replacing the null values with some dedicated value that you are interested in adding, right? So yeah, I think we missed out the second column. This was the gender column. We need to work on this first. So you just need to select the column, and there are multiple ways to do this. You can, go to the add column or transform option and choose the replace values from here, or simply right click and then you have the option which says replace values, right? So for now, I think we have null, the empty value. So there are two meanings for it. If it is lowercase null, it means the columns or that particular cell is blank. But in case if it is capital null, then it means it is character data type and it was dedicatedly written as null, right? So you need to understand the basic difference between nulls. So this is the null value we're dealing with. And in place of any blank cell where the value is null, let's write it as others. So others will be the gender in place of a null value. And this will be your first transformation step. And take a look on the right hand side. So whenever I click OK, a new step will be registered. So that was the replaced value and a new step has been successfully registered. So if we scroll down the data, we should be finding some others. So here you can see the others entry. And now the first column, or in our case, the first transformation is successful. Now comes the department part. Similarly, you can go ahead with the replace values option here. And in this particular option, we need to write down uppercase null. And let's imagine any new employee, let's say our requirement is in engineering. So any new employee which has been recruited will be provided to engineering department. So I'll write it as engineering, or it could be product management based on the requirement, right? And I will click OK. And the next replace value function is also successfully done. And this is simple, right? This is our imagination. But in case if it is a little complicated, let's say any employee that was recruited in the month of March 2025 should be for marketing, and any employee which was recruited in the month of May in 2024 should be for business development, right? You can also do that. You have the operation called add column based on a condition, and you can provide the conditional column and then move these employees to a dedicated team. And that's a lesson for the next session. Now we have another column, so let's quickly go ahead with that. In here, you have null values as well. So instead of just replacing these null values with some random data and making it complex, since it automatically took it to a float value, here you can see the fourth step, right? So let's not do that complication, but instead what you can do is just quickly apply a filter and unselect null, so that all the employee details which are no longer working with this particular organization are erased. Not erased totally, just filtered out basically. So now this was the thing. Apart from that, if you wanted to, the next operation is about extracting the country. So now the fun part. So go to add column and here column from examples. Now here it will ask you two options, from all columns and the second one from selection. So we want to go with the selected column. So we'll go with the second option from selection. Now it's your duty to train Microsoft Power BI, your thought process, the way you're thinking. So if I go into this particular cell and I write USA, it understands, okay, he's trying to extract the country USA. Automatically, wherever it finds USA, it has extracted USA. It's still in process. Now I come to the row number 3 and I'll write NZ for New Zealand. It understood NZ, and here you can see the highlighted row number 6. It has written some ELS, but ELS is not my expectation. So what I'll do is I'll quickly rewrite this as USA. It might take a few iterations, but not more than 6 or 7. It should, like, normally 2 to 3 iterations will make Power Query understand your requirement. So you can just eyeball everything, and once you're happy, I think we have about 1,000 entries here. So 1,000 entries are good enough, and all the entries have successfully extracted the country. And you can just click on OK, and your new column has been successfully added. You can also rename this particular column as country PRY. There you go. So your new country is successfully added. And in case if you don't want this, you can eliminate it. But in case if you want to continue having this address, you can keep it. So for me, I don't want it right now. I'll feel free to eliminate it. And you have a good amount of data. And in case if you wanted to go ahead with, the separated column for year, you can also do that. So you just need to go the first column, which is start date column. You can select the column, and here you have the date option. So what you can do is year. Select the year, and a new column which is dedicated for year has been successfully added for you. So your data is almost ready for analysis. So what you can do here is you can just go back to the home option, and here you can choose to close and load the data. So there you go. You have a completely filtered and purified data ready for analysis. In the same way, your data will be loaded to Power BI as well, and you can go ahead with visualizations part. So on the flow, in these next upcoming sections, we will also go to it, where we will load the data directly to Power BI, and we will start with explorations as well. And we will also create a wide variety of charts, column charts, bar graphs, pie charts, donut charts, and a lot of options which are available. And apart from that, we will also create a highly interactive dashboard. As discussed before, we will be having sales data sets, and we will be working on the first current 5 years of data sets. And then we will also add a new data set of the upcoming year or the current year, and then we will just refresh the dashboard, and automatically it recognizes the changes, and it will load the data, and you'll have a fresh data set or dashboard which is completely interactive. So there are a lot of things which can be done. And here on the right hand side, you can see the query options. If you click on that, you can see you will be back on the Power Query window, and you can see all the steps that you have applied. And in case if you want to change anything or if you want to remove anything, you can feel free to just click on that cross icon there, and it will remove that. So that's how it works. Now you can close this particular query settings and go back to the dataset. And in case if you have any connections with other datasets as well, you can establish that connection with your datasets, and it will be good to go. And you can also include this particular data for creating a pivot table as well, which looks something like this. So let's select all the data, which is completely clean and ready for execution. You can go into the option which says pivot table, and here you can choose a new sheet. This is how it looks like. So you can choose to go with a new sheet, and you have a pivot panel ready for you. So what you can do is maybe drag and drop department into rows, and then you can also include the salary, and now you have how much salary are you paying to each department. And apart from that, if you wanted some a little more detail, you can also drag and drop the name row to values. So you have the count of employees in each department. So you can see product management has almost highest kind of number of employees, and you can also choose to kind of sort this just like you do in regular Excel. You can choose this particular table, and then you can sort based on increasing or decreasing order as provided here. And apart from that, you can also choose to add a date or year here. So year to columns. So you have a side-by-side approach of 2024 data and 2025 data, and all the details of the employees and the salaries, everything, right? So this was the first approach, and you can name this as pivot table, right? So this was the first approach of loading data from an Excel file. Now let's go with the second approach, where we wanted to get the data from a web page. So I'll close this Excel file. You can choose to save, and let's also save the previous one. This can also be saved as a reference file. I think I saved it previously already. Yeah, there you go. Now we have opened one of the web pages, and I think Power BI is also open. Not a problem. You can close this. Don't save anything. Yeah. So we can choose any of the open source datasets. So before you go ahead with web scraping, understand this fundamental rule. So there are many websites out there. It can be based on cryptocurrency websites. You can also know where the current value of a Bitcoin or any crypto coin, right? So such websites, they have some security concerns. That particular data is not available for open source, right? So most of the times when it comes to data analytics or business analytics perspective, web scraping is very rarely done. But from organizational level, web scraping can have a little bit of room for it. So there will be websites which have a dedicated log for them. So they don't open source their data for public users. And there are some websites which are open for everyone. So based on your choice or based on your requirement, you can go ahead with the web scraping option. So in my case, I'd like to go with some open source learning pages like Wikipedia, something like that. So I'll type Wikipedia, American population or Indian population demographics, such datasets. So let's go with this one. United States territories by population, or the first one, demographics of United States, right? So here we have some data tables. So here we have median males, females, total population, country, and yeah, this is year-wise data. And here we have rank, name, side-by-side approach. Yeah, this one is also good. Year-wise, average population, live births, deaths, and all those. So you can choose any of the web page that you feel comfortable to work with, or based on the requirement, if if you receive any of the dedicated link, you can go ahead with that. So the approach is simple. So I think this particular data looks good. So here we have state, and then census population, and largest cities, etc. So I'll go ahead with this particular web page. So I'll copy the URL. This is the first step, and go to Excel. Once you reach to Excel, you can create a new workbook, or you can choose to go with the reference workbook as well that we created previously. I chose to go with the new workbook, and here we go to the data option. So it is completely similar in Power BI as well. So we are doing this for learning purposes on Excel, and once we're comfortable, we can go to Power BI. So since Power Query has the same interface on both Excel and Power BI, it's comfortable to go with Excel as well. I think I closed Power BI. Yeah. So blank. And here you have the get data option. So here you can choose the option which says web. You just need to simply, cancel. You just need to simply drop the URL and it will load the dataset for you. This is the one. You can simply place the URL and click on OK. And it will open the Power Query window for you. Similarly, while that happens, you can choose the get data option, and here you can provide from database, Azure, others. Here you have the web option from web. So if you are applying this for the first time, you might get a few options where you have to choose basic or advanced, or based on the requirements. I've done this a couple of times. So it will just directly take the request and load the data for me from Power BI or Power Query window. So this is the one I was talking about. So access web content. So here is it asking for anonymous, Windows, or basic. So you can choose anything based on your requirement. If it is basic, you need to provide some credentials. If it is Windows, and you need to provide the current credentials of your Microsoft account. I would like to go with anonymous for learning purposes, and connect. And slowly the Power Query will be starting for you. So meanwhile, let's also check on the Power BI platform. So here you have the preview. So it's completely similar on Excel as well as Microsoft Power BI. So you can just go to the view option. So this is the first table. So here we have columns and rows. So here you can see some values. So if you go back to the dataset on web page, here you can see some aggregations of, not aggregations, combination of the first two rows. So the first two rows were combined and named as state or territory. In the same way, here you can see the preview. Null value is placed in the first entry, right? And some naming conventions are gone wrong based on the web engine here. So here you can see some links, right? So some links are attached to this particular table. So what Power Query did is it considered this as a data entry, and this particular elements are also visible on the Power Query window. So you have the complete authority, and you have the complete options to rename the columns and eliminate the first row, right? You can do some changes on that. So let me close this here and go back to Excel. Let's see if that got loaded. Yeah. So here you have the select multiple items. So you can choose to select multiple tables you want to go ahead with, or if you want to go ahead with only one, like we discussed. So we can also go ahead with only one table. So you can quickly have a preview. So if this is the one you're looking for, since we had a lot of tables in the original web page, right? You have a table over here. You have furthermore, if you scroll down, you have one other table here, another population states table here, right? A lot of tables. So you can go through all the tables, preview, and select the one which you're looking for. So this is the one I'm looking for. So what I'll do is go to the transform option, and now it will open me the query window. So just like we had before, left hand side will be for queries and right hand side will be for applied steps. And similarly, it shows the liberty to do some changes for us. It promoted headers, changed data types. So I want to take the control for myself. So I'll remove the change data types and also promoted headers. So far so good, not a big problem with the headers, but we always have the option of renaming, right? So now let's rename this particular column header as census population _1, and this one as well. So we can go with rename. So this could be census population _2. Largest cities is good enough. Largest cities 2 is good enough. House seats B. Okay, why don't we name it as A? Or I think since house seats is good. Now this will be B by default. So we remove this. There you go. You can also vote. So rename votes to population percent votes in 2020. And this can also be renamed. So this is simple, but we are doing it for multiple times so that you have a quick understanding. You have a grasp of how to continue when you're on your own. So here you have percentage of US in 2020, percentage of EC in 2020. And now so far so good. Now, remember the option that we were discussing about removing rows and columns? So here you can see some irregularities in the first column or first row, right? So here you can see largest cities. Okay, I think this can be named as city name, right? So rename it as city name and city population so that it is a lot more easy to understand, right? And seats could be good. Our seats percentage null, right? So far so good. So what you can do is choose the remove rows option and it will ask you the options, top rows and bottom rows. Based on your requirement, you can go ahead with that. So I'll go with the top rows, and what I will do is it will ask me how many number of top rows you want to delete. Let's say I have problem with the top 2 or 3 rows. I can directly specify the number as 2 or 3, but now I have only problem with the first row, so I'll provide the number as 1, and automatically the first row will be eliminated. Again, when dealing with such web extracted data or web scraped data, you need to be very careful about the steps you're applying, right? Now, for this scenario, we have changed some column names and all of those things, but tomorrow the columns might be rearranged. For example, here you can see state and territory. Next one is census populations, right? Instead of state and territory, you might have city name, right? The columns might be swapped, or maybe for the next time, the hyperlinking on the data table may not be done, right? And also there is a good chance where the dates, right, July 2024, April 2020, city names, city population, there might be slight changes to these, right? So this type of operations, when you're dealing with web scraping, you need to be at most careful with what are the steps you're applying. Mostly these are not preferred in real time in business perspective or data analytics perspective, but on the organizational level, very rarely this will be done, but it can be a long time consuming process. But make sure that you're applying all the steps that you are considering. Now, if I see all the data set ready for me. Now, what I want to do is I'd like to select few columns and run my analytics. So we have the choose columns option over here. So I'd like to choose the columns of city name, city population, and maybe population percentile of vote, and okay. So out of 3 million people, only 720 or 732,000 people chose to vote, or maybe some miscalculations in the voting terms, right? So let's go with the analysis part of it. I'd like to go with the population city. And if you're comfortable with the data set that you have, you can choose to close and load. There you go. So the queries, connections, extremely similar to what the process we made previously. And you have the option of forecasting, right? So in the current year, this is the population and what could be the future population. You can add a quick, forecast data for your data set. And apart from this, you can select this particular data set and you can choose to go ahead to Power Pivot, and here you can insert a pivot chart. So you can go ahead with any of the charts available and you can have a demograph of all the charts. And that was part 2 of loading the datasets. You can quickly choose to save this file, and let me save it as reference 2. And now will be our next part. Now, so far we are done with the web import of data. Now let's go with another part. Cancel. We don't want to close Power BI yet. So the other part will be where we will be processing some appending and merging operations, which are completely similar to SQL joins. So this has been saved. So I'll close this, save and close. So I think we have a lot of states there. That's the reason bar chart was not showing any data. Not a big deal. So just for learning purposes of web scraping, we did that. So now I'll start a new workbook altogether for the third reference part. So the third part, initially we did Excel, then we did web scraping. Now we will be doing the appending and merging operations. So this is the fresh workbook. So again, we need to go back to the data option. So we will be loading the data from file and again, cell workbook. So this workbook has multiple files in it. So that's the overall approach where we will be performing the appending operations. So we'll be in data sets. And this is the one, students and courses, right? We will load it. It might take a little time, but not to worry. Yes, there you go. So you remember the select multiple option we discussed before? That's the one. So we have courses, so we have years as well. So now we will be transforming the data. So now we are on the Power BI's or Power Queries window. Now, so this particular table is the courses table. So we have some random courses here, the respective teachers, lesson type is a practical theory or internship. Then we also have credit score like 1, 2, 3, so 4, so on. And we also have assessment type. Which type of assessment did they face? Was it a quiz type assessment, continuous assessment, return or project work, or was it oral assessment, right? Just something like that. And then we have year 11 and year 12. So these are the students in year 11 and these are the students in year 2. So what is the main purpose of this particular attempt? So in this particular attempt, as you can see, we have students, their gender, their course, and we also have courses. Now I want to know which particular student has taken what course and who was the dedicated professor or teacher and what type of lesson are they receiving. Is it practical theory, internship, anything like that? And then what are their scores when they write an exam or when they have an oral exam? Then what is the number of marks that they have achieved in what format? I want to know that. But here all I can find is student name, gender and course, their marks or the grades that they have received, what type of lesson did they receive or what type of assessment did they face, who was the teacher. These details are not available in any of these tables. And again, we have two different tables here. One is year 11, another is year 12. Now, how do we do that? That's the question, right? That's where the home ribbon has two options, merge and append functions come into the picture. So automatically it changed some data types. So here you can see only applied steps, and here as well it has changed a few things. And when it comes to courses, so credits, it took the changed data type, it automatically made it to a whole number. That's great. Now we need to combine both year 11 and 12. So for that, I'll choose year 11 and go to merge queries. And after that, I think we were supposed to go with append queries, not merge. Merge is the next step. So two tables. So you can choose two tables or more than two as well, three or more. For now, we have just two. So we'll go with the two tables option, which is default one. So here you can see we have year 11 as current. So that means we are currently in year 11 table. So I want to connect or append the data of year 11 with year 12. Then press OK. And now you have all the data of year 11 and year 12. But there is a small bottleneck. How do I identify which student belongs to which year? Okay, and also I think we missed out on the column headers. So in such scenarios can be reverted, not a big deal. So what you need to do is just click on the cross sign here to remove that function. And now what we will do is we will do some changes. So select the dataset and then click this particular option which says use first row as headers. So this is the fundamental thing which you need to remember. Always check the column headers. Once you're satisfied with the column headers, then you can go ahead with the rest of the process. Now this was step one. Now what I want to do is add a dedicated column which says this particular column is data related to year 2012. So I'll add a custom column. I'll name this as year, and within I want to add a text based input here. So within the double quotes, I'll add year 12 and press OK. So this is automatically, okay, we need to change the data type. You can change type to decimal, whole number, percentage, text. I want to keep it as text. So again, let's try that again. Okay, there you go. Now, similar approach should be followed in this particular table as well. So we will go to a custom column. So the custom column will be named as year, and within the double quotes, we should write year as year 11. So that now we have a quick identifier which student belongs to which year, right? And again, we will change the data type from number to text. There you go. Everything is good to go. Now, if we append, we can identify which student belongs to which year, right? Now we'll go back to home option and here choose the append queries. So append means we are attaching, here you can see the logo, you are attaching one dataset under the other dataset, right? So click that. You have two tables, so go with the default option. But in case if you have multiple, then you can go with three or more tables. So let's go with two here. So we are in current 11. So I want to append the 11 with 12. So click the option table 12. And now you have appended the data. So if you scroll down, you can see until row number 175, we have 11 years. And after that, we have year 12, right? So far, so good. Now the next task is map these with courses. So for that, we might have to go to the option of merge queries option, right? So here we have course table. So if you go back here, you can see in year 11 and 12, each and every student has a course. So what is course? If you go back to SQL, there if you are merging or joining two tables, you will merge or join them based on one key, and it is called as primary key, right? So you need to have one common column or one common entry on both the tables based on which you can attach or join both tables. So in this particular scenario, course column acts as that one primary key for our merging option, right? So I want to merge year 11. So that's the one where we have all the data sets, right? So you can even rename it. So year 11. Okay, before we do this, it's better we rename this. So I'll rename this as, okay, before we rename, let's make it, make a small confirmation. So we have both, okay. Now, we will rename this as students. Okay, we have students data table and courses data table. So again, go back to courses, use the merge queries option, and the table I want to merge with is students data table, and based on what parameter. So I would like to go with the course parameter or the course column as my primary key. So far so good, you can continue merging, but in case if you want to merge with referencing more than one column, that is also possible. So what you have to do is just hold control key and then click on the column which you want to refer. So here in case of this data set, I'm just randomly selecting gender and teacher. But for our data set, just one column is enough, which is course, and we have selected that successfully. Now, if you scroll a little lower, you have join kind, right? If you open the drop down, you have left out the join, which says all from first matching from second. And second one is right, all from second matching from first. Next, we have full outer join, all rows from both the tables. Inner join, only matching rows. Left anti-join is about only the first join. Right anti-join is about only the second one. So the best one to be safe side, right? Even if it is a replica, you can go with full outer join. But the default one chosen by Power Query is left outer join. So I want to go with the default option here. So the selection matches 19 out of 19 rows from the first table, so it's good to go. If there is any error, you could have found it over here. And you also have some option called fuzzy matching options. So if you know what is fuzzy match, you can also proceed with this one over here. But now we don't want to work with fuzzy match. We are good with left join. So you can simply click on OK and the data will be merged. But right now on your screen on Power Query window, what you can see is just table entry. So where are the rest of the entries, right? You don't have to worry here. So all you need to do is go to the top right corner where you can see two arrow marks, one going to the left and one going to the right. So that is kind of an option which says you need to expand this particular column. So if you click on that button, the data will be expanded. Okay, now you have the respective course, the teacher, the lesson they are giving, and what is the credit score or the number of marks they have achieved, what type of assessment did they give, and who is the student and their gender, the course they took, and which year do they belong to. Everything in one shot. Now you can go to the option which says close and load. So click on close and load. So yeah, there you go. It has established connections, queries, and everything in one shot. So now you have three different tables on the right. You can see courses, students, and year, right? So the latest merge option which we did is currently in courses. So click that particular one and you have everything in one shot. So you have the course they have taken, teacher, lesson type, credit score, assessment, and everything. So now let's consider a small use case. Let's say we want to award people who have taken practical lesson and have scored more than 2 or 3 credit scores. So for that, how do you do it? So we have a simple filter operation right here. So you just need to click on the filter operation. It is taking a moment. So you can go to home and apply a filter. There you go. Now you can click on the filter, close this. Or I'll do one thing. I'll create a fresh new sheet and then paste it over here. Courses. And here I'll be pasting it. There you go. Now we have a shortcut, if you remember, Control Alt HOI. Undo that. Alt HOI. For adjusting the row width, and you have successfully adjusted the row width. Now these are your columns and rows. What you can do is quickly apply a filter, and you can segregate your data. So I want to choose practical. The filters are not loading for some reason, but basically that's how you do it, right? So you quickly apply a filter. Okay, let me delete this. For some connections, I think it is unable to load properly. So let's try that again. If the filter is functional, I can see the filter getting loaded, but for some reason it is not staying on the screen. Yeah, so basically what you can do is, let's try to create a new sheet altogether without any data connections. Now we will select all the columns, Alt HOI to adjust the width, apply a filter. I think this should help. Yeah. Yeah, basically what you can do is apply a quick filter, select the filter option, and in which you will select practical. And here you will apply a condition where filter condition will be credit score should be greater than or equal to 3 or 2, right? Based on that, the data will be filtered. So for some reason, I can see the filter, but it is not staying long enough on the screen so that we can apply it. Could be a small technical error, but that's how you basically do it. And that brings us to the end of module 4, where we have learned the basics of Power Query, how to clean the data, how to split into columns, and how to do some basic functionalities like creating an additional column which extracts the data from a logic based on your thought process. And we have also done web scraping. We have considered the Wikipedia open source data sets to do that. And now we have a comfortable understanding of Power Query in both Power BI and in Excel. Both the domains are one and the same. So in the upcoming modules, we will be learning data modeling, DAX calculations, data visualizations, and creating a completely interactive dashboard, which includes slicers, filters, and a lot more. Now let's proceed to the next module. Welcome to the module 5 of this Power BI full course. So module 5 will be about the data modeling in Power BI. So what exactly is data modeling? Imagine you had a store or some online website where you sell some products. So you have shipment data, product data, geographical data, and the sales team data. And apart from that, you might also have calendar data, which is really vital in business analytics. So all the tables are interconnected. So one, which is the shipments table, will be connected to the product table, also to the orders table, sales team table, and the calendar as well, and also to the geographical location, right? It's like the shipment data table is in the middle of all the other tables. It's forming a schema. It's forming a shape, right? So this is data modeling. It might be a little confusing, but don't worry. To have a better clarity, we will go to an Excel dataset so that we have some detailed understanding of what exactly I'm talking about. We'll also deal with the fact tables, dimension tables, relationship between all the tables, and how exactly a data schema is made. And then we will also do some sample visualizations using that particular data model. Now, let's go back to the Excel dataset. So now we are on Excel dataset. So we have a shipments table. So we have dimension data and also the calendar. Now, when we come into the shipment table, we have shipment ID, SPID, PID, GID, ship date, amount, the number of items, and order status. So we will look into each of these columns. So the shipment ID is a unique ID for each and every shipment that you made from your website or your inventory. And SPID is the sales team's ID on which this particular sale was made. Who was the person who was the one who is authorizing this particular sale and who took care of the rest of the process. Then we have PID, which is product ID, which product was sold. and the GID is about the geographical ID, based on which geographical location was the order placed from or delivered to. Then we have ship date, based on which date was the shipment made, what's the amount and the number of units sold, and what's the status of the order. Is it delivered, or is it in transit, or is it shipped, right? Some details of that. Now, what are SPID, PID, GID, and ship date? How are they related to shipment data table? That's our next approach. So here we have the dimension data. So in dimension data, we have three tables. The first table is the product table. What products are in our inventory, what category they fall into, what is the cost per unit, and what is the PID. So basically this particular table, the entire table has to deal with one item, which is about the products item, right? Now here you can see the fourth column, which is stated as PID. Now PID is the primary key which can be used to connect the product table to the shipment table. There is one connection established successfully. Now let's go into the second table. So the second table is nothing but the geographical location table. So here we have a geographical location: India, US, Canada, New Zealand, Australia, and UK, and also the regions: APAC, Americans, APAC, Europe, etc. And here we have the third column, which says GID. Now this particular GID acts as the primary key, which combines the shipment data with the geographical data. So here we have the GID and the shipment ID. So this particular table deals with the geographical location. Now going forward, we have another table which says about the salesperson or the sales team, right? So here we have salesperson who is responsible for the sale, and here the team to which they belong to. And third column is the SPID, which combines the shipment data table with the salesperson data table. So this is the SPID we were talking about. Now, apart from these three or four tables, including the fact table, we have another table which is called as the calendar table. So this particular calendar table is nothing different to your regular calendar. It has all the dates, all the months, all the weekdays, and the year table, right? So this is like a calendar. So whenever there is an order or shipment made to that particular date, we will have a registry here. So that is how the calendar table works. Now, here in the shipment data, you have the ship date. So this particular ship date is connected to the calendar table here, right? Now we have all the five tables as per the discussion. Now we enter into the schema, the star schema, which is one of the most popular schema used in the current world of business analytics and data analytics. So here you can see this particular table is the fact table. Why is it called the fact table? Because rest are the dimension tables which deal about the people. So it might be the customer data or it might be the salesperson data. So basically any table which has the details related to customers or the salesperson is one dimension table. And the other table is the product table, which solely deals with the product details. And the other one is the calendar detail. So this particular table wholly deals with only the calendars. And the last one is the location table, which only deals with the location details. So all these people, product, calendar, and people data tables, which uniquely work on one single aspect, are connected to the fact table, which maintains the details of all these tables. Let's say I want to find out, if we go back to shipments table, I want to find out the details on this particular shipment ID, which is 058. So what is in 058? Who was the person who made this sale? What product was sold? To what particular location? And how many orders were placed? What is the status, right? All these details are not available here, but instead of that, we have the SPID. So if I explore the SPID, I will get this particular entry. So this person was responsible for that particular sale and he belongs to this team. And if I go back, here I see P01. So what is the product? If I enter P01, I have this particular product and this particular category, and this was the cost per unit, right? And again, if I go through the GID, this is geographical data. So GID 3 is Canada and the region was Americans, and this is the location where the shipment was sent. And now on what date? it was 28th of June 2024. So here I have that details as well, June 28th, right? And at last we have the total amount paid, the total units sold, and the status was delivered, right? So this is how each and every table is connected to one another, right? So shipment table falls in the center location, and all the rest of the details, which is calendar, people, product, geographical location, all are connected to the shipments table, which is the fact table, and rest of the tables which surround the shipment table are called as the dimension table. Now this might be a little confusing still, but don't worry. Now we will close this particular dataset and head back to Power BI so that we have a comfortable understanding of what exactly I was talking about. So now we are on Power BI. Let's create a blank report and let's load the data from Excel. And here I have the sample sales data. So I'll open this. It might take a little while, but don't worry. So there you go. So this was the sheet 2 where we created the diagram. Don't worry about that. Now we need calendars table, locations table, people's table, products table, and the shipments table. So shipments is the fact table, calendar, locations, people, and products are the dimension tables. Now this particular data that we have is fine. We don't have to do any data cleaning. This was previously cleaned and processed data. So we can directly load the data from this stage. So let's click on the load button and it will take a little time to load all these data models to Power BI. So there you go. You can see calendar, locations, people, products, and shipments are loading. And you can also read creating connection in model. So data modeling is already happening. So detecting relations, 670 rows loaded successfully. So on the right hand side, you can see the data, right? If you scroll down, you can see calendar, you can see locations, people, products, and shipments, right? So these are the basic entries that we are having. Now, what are we talking about data model since so long? So here you can see the report view, data view, or the table view, and this is the model view. So if you click this, you will now understand why we made that diagram on Excel spreadsheet. So here, let me close this as well. So here you can see how the products table is related to shipments table and how locations table is also connected to shipments table and how the people's table is also connected to the shipments table, right? They create a star pattern, almost a star pattern, right? Now, you can see a star logo here, right? If I expand, and you can see one number here. So what this specifically means, this is many to one relationship, right? Many entries of shipments table are related to one element of this particular people's table, which is SPIT. Remember the analogy we discussed? That's what it is. So here, many entries of shipment table are related to one entry of locations table, which is GID. Similarly, we have the many to one relationship here as well, where many entries of shipment table are related to one entry in products table, which is PID. Now, the only data which is not connected still is the calendar data, but not to worry, we can connect that as well. So here we have calendar date and here we have shipment date. All you need to do is click and drag this particular element to calendar date and you can establish a connection. Now, here you have a new relationship. So Power BI is showing you this kind of relationship can be established between the two tables. Now you need to cross verify of the elements you're choosing, ship date and calendar date. Once you're satisfied, you can proceed. And here you have by default many to one because Power BI's model was able to identify which kind of relationship can be established here. But in case if you're not satisfied, if you want a different approach, you can also move the cardinality from one to many, and many to many. By default, it is many to one. Let's keep it that way. And you can also go with cross filter direction, which can be single or both. For now, single is enough and single is the one recommended. So let's keep it that way and save this. And you'll have a relationship with this particular element as well. So multiple elements of shipments table is related to one entry, which is calendar date in this particular module. Now let me lesser the size. Let's zoom out and zoom in. So that's how the relationship looks like. Now, apart from this, you also have properties, which helps you understand what kind of relationship has been established between any two tables here, the cardinality, and you can also manage relationships here. So here the shipments GID has got many to one relationship with locations, and shipments has many to one relationship with PID, and shipment ship date has many to one relationship with the calendar, and shipments SPID is collected to SPID in many to one format as well. Now you can close this, or you can also add a new relationship or edit an existing relationship or filter any of the relationships present here. Let's close this for now. And apart from this, you can also create a new calculated measure, new column, new table, calculation groups, and you can also manage the roles, view as, right? Basic functionalities. Now you also have the data details here, data model. So you can go and take a tour. Now let's close the model view and go to the report view, where you can create sample charts. For example, I want to know the geographical location, or we can also go with the Q&A visuals. If you double click, the Q&A will start here, and you can just simply type, what are you looking for? I want to know category wise sales in region, geographical region. Category, sales, region, and the type of chart could be bar. Now you just wrote simple English language, and the Q&A is trying to understand what are you looking for, and it will try to generate a visual for you. Or you can give it a moment and try to do it all by yourself. So I would like to go with bar graph, or you can go with the pie chart as well. And now what you can do is add geographical location. Since we're dealing with geo, why should we not go with map? You can also go with map, but that's not nothing to worry about. So what you can add is you can add this here, and we want values. So I want to go with the summation of amount, order status, monthly status, total sales. So I want to go with summation of amount, and it will be added in values. So here we have a readily available visual. So we sold about 23% to UK. So you can also add tooltips. So I'll add geo to tooltips. And in India, we sold about 23% of the sale. And in USA, we had 17% sale. And in Australia, 17.47, something similar. And in New Zealand, we had 12% of sale. And in Canada, we had about 5% of sale, right? So apart from this, you have a wide variety of other visualizations as well, like slicers, funnel charts, cards, and a lot more, which we will be exploring in the upcoming modules. And with that, we have come to an end of this module on data modeling. In the upcoming modules, we will deal with DAX calculations, basic visualizations, and building an interactive dashboard. So now we enter our next module, where we will learn the DAX expressions. So DAX stands for Data Analytics Expressions, but for some reason, instead of taking DAE, they took DAX. And simply, the same DAX is also as complicated as the naming convention. So we will have a lot of, let me cancel this. Yeah. So we will have a lot of naming conventions in DAX, and also we'll have one common misconception if you're a total beginner, or if you have transferred from Excel to Power BI or any other platform to Power BI, then obviously you'll definitely have a small misconception that DAX is all about some basic aggregate functions like sum, average, mean, median, standard deviation. But it is, a part of that, apart from just being an aggregate function, DAX has a lot of other things to deal with. So in simple terms, DAX provides you a lot of freedom when it comes to deep diving into data analytics. You can kind of write your own mathematical logic. If you understand your business requirement, to be honest, before you dive into DAX, you need to understand what is the business perspective of your business owner. If you are the business owner, or if you're working for an organization, then your organization's business perspective, you need to have a good stand on that. You need to be able to understand what your business owner or you as a business owner is expecting from your data, right? Once you have that particular clear vision, you need to extract the data and clean the data. Unless you have a clean and perfect data, writing DAX would always end up in miscalculations. Let's say for a simple example, if you wanted to divide a certain column with another one, if you had zeros in it or null values in it, obviously if you're directly dividing column A by column B using a slash, and definitely you'll end up into zero errors, right? The error that you get divide by zero, correct? If you change few things in the same division function, instead of writing a slash, if you write divide and the column main, comma, column 2, then you might not end up with that zero error, right? Divide by zero error. So few minute things you need to keep into consideration when you're dealing with DAX. That's one thing. And apart from the regular average or sum or aggregate functions, there is a lot to deep dive in measures and all the DAX functions. So with that basic understanding, let's dive into the DAX functions. Now let's create a blank report. And here we will be working with the same dataset that we worked on the previous section. That is the sales example dataset. So we will be having the calendar, location, people, products, and shipments. Let's give it a moment while the data loads. And apart from just the datasets, I would also highlight or some important things about the data modeling here. So when you're always working, whenever, just keep always this thing in your mind. When you're working with DAX, you need to have a good organization of your schema or the data model. Yes, previously we discussed that star schema is one of the most frequently used or one of the most important schemas out there when it comes to data analytics. But when you're especially working with DAX, then make sure that you are using star schema, but along with star schema, the arrangement of data sets or the data models is also important. It plays a very critical role. It kind of gives you a skeleton how the data is flowing and what it is happening in the background. So to understand this better, let's actually dive into the data model. So I've selected my tables, which is calendar, location, people, products, and shipments. So we want to go into transformation, or you can directly load. You don't have to worry about any kind of data errors in this. This is actually a cleaned data set. Since you're working with DAX, I made the cleaning and everything is good to go. So I'll directly press the load option here. And let's give it a moment while all the 5 tables load. So you can see creating a data connection in model and loading the data to model, relationships established, and all the rows are loaded successfully. Now, before we go into actual DAX, we should have a quick look on the model. So here, let me close data, let me close properties. So here you can see our fact table has been located in the center position. So let me reduce the screen size a little bit so that we have a quick overview. So whenever you're working with DAX, make sure your tables are arranged in this way. So for example, this is a dimension table, right? So dimension table should be all arranged in the top position. So we'll just give it a moment. So this is our calendars table and this is our products table. And this particular fact table will be arranged here, right? So now why did we do that? You will understand which of these data tables or data models is a fact table and which is a dimension table if you go ahead with this type of arrangement. So this type of arrangement, just by a visual glance, you can understand which table is what and which data model is meant for what purpose. So make some quick arrangements so that you'll have a quick overview of what exactly you're dealing with when you're working in real time. So here we don't have an established connection with the shipments fact table with calendar. That can be done in a moment. Just go to that one element which can relate to your calendar. So we should be having ship date. Yeah. So just like we did before, drag and drop ship date with the calendar date here. You'll be having the new relationship, and Power BI will identify which are the columns which can be related here. So you can see it automatically selected ship date and the calendar date. And you can also see the cardinality. So let's go with the same cardinality by default provided by Power BI. So we have many to one, one to many, many to many, and one to many. So whichever cardinality suits best, you can choose that and go ahead with it. By default, Power BI has the caliber to select the best one for you. So I'd like to go with the Power BI's choice of cardinality here. And anyways, this is the one which we're looking for as well. So you can quickly save and you will have a well-established relationship between the calendar as well as the shipments table. So all the tables, let me expand this. So all the tables located up top are your dimension tables, and the table which is located here is your fact table. And here you can see the relationships processed. So here it is many to one, and all the other are also many to one. And if you expand this a little bit more, you can see the flow diagram here. It is flowing from the dimension table to the fact table. It means it acts like a filter. Let's say you wanted to filter out something from the locations table. So we have about 5 to 6 geographical locations and 5 to 6 geographical IDs. Let's say you wanted to know the information for a specific geolocation and you wanted to identify all the shipment track records for that particular location. So what this majorly does is it acts like a filter and it filters out the details for that particular geolocation. And similarly, the facts table will also change. It will only show the rows related to that particular geo ID only, not all. So similarly, here you have salesperson details. If you specifically provide a dedicated salesperson, the same filter applies and the data will be filtered. Let me drag this. So data will be filtered and accordingly the changes will be done on the fact table as well. Now that's how, or that's the reason why we need to arrange the data models in this particular module or this particular style, so that you can identify which table is a fact table and which table is a dimension table. So I hope you had a great understanding of that. Now let's go back to the report view here and you can get started with DAX. So there are multiple ways, since DAX is very critical and an important aspect of data visualization with Power BI. Microsoft has chosen to add multiple ways to select a DAX operation in Power BI. So here we have one option, which is DAX query view. You can directly access DAX from here as well, or you can choose to dive into modeling. And here also you have the calculations aspect or calculation style here. You can choose to create a new measure or create a quick measure. So nothing major difference between new measure and quick measure. So quick measure is the easiest way to create DAX or a measure which happens to be an aggregate. So if you wanted to create an aggregate function like sum of all the sales happened or the average of sales happened, you can choose those quick measures or quick aggregate measures through quick measure here. And if you wanted to dedicatedly write a DAX, then you can choose the new measure from here and write your dedicated DAX function. Apart from this, if you go back to home, you have another calculation tile right on the ribbon, right? You can choose to go ahead with new measure or the quick measure from here as well. Apart from this, there is a quick shortcut as well. If I go into shipments and wanted to write a measure, I can also do this from here by right clicking on amount, and you can see we have a new measure on new column option here as well. So which is also one of the options to create a DAX. So with that, we have a basic understanding of how exactly DAX works or how exactly you can navigate to DAX. Now, whenever you're dealing with the DAX, you better if you're new to DAX, then I'd recommend you better go with a table visual so that you'll have raw numbers and you can understand what exactly is happening on the go. Now, to understand DAX better, let's start with the picture which we already have in our mind. DAX is just aggregate purchase. So let's get started from there. So on the go, you'll understand how it actually differs from our picture that we have in our mind. So if you're coming from an Excel background, then definitely you might think DAX is just another aggregate function, but it's not. So it's a lot bigger and different from that. So for having a comfortable understanding, let's anyway start from that particular aspect. So let's try to create a DAX here, which will be this one, and we will have a formula bar there. So to have a better visuality, I'll expand this particular thing. So you can just hold control and scroll up and down on your trackpad, or you can also use your mouse scroller to increase or decrease the size. So if you are proceeding with DAX, then you also need to understand the syntax of DAX. And by the way, on the flow, when you're already when you've already created some DAX for yourself, then those DAX will act as your primary asset. And when you're reusing that particular DAX, the syntax might change a little bit, not too much. But anyways, let's start with the fundamental syntax. So any DAX will have three particular parts. So the first part will be actual name of the DAX, which is total amount that we have added here. The second part is nothing but this particular small logo or symbol, which is equals to symbol. And the third part is nothing but the mathematical logic that we are about to write. So let's start with that simple aggregate function. I want to use sum of, I want to go with shipments table. So I have shipments. And here I have a shipment amount. So I want to go ahead with that particular point here. So you can either choose to write the entire name, or you can also use the tab operation on the keypad. So just click on tab and it will be selected for you. Make sure you close the last bracket and enter. So you have now successfully created a new measure. Now you might be asking me, why did I do this when I have the option of directly dragging and dropping this particular amount column from the data table? So let's also go ahead with that. Now let me add the product ID to the table. So we have added the ID rows and the total amount to this particular one. So there you go. Let me expand this. Yeah. So we have So we have the total amount here. And apart from that, we have sum of amount, which we created using an aggregate function. Now, if I drag and drop the total amount DAX, which we created just now, we will have the total amount as well. Now, you might be wondering, why did we even create this? Why did we even have DAX when we already have aggregate functions available on Power BI? So this is where the point comes into picture. DAX give us a lot of freedom rather than the aggregate functions give us, right? Now, if you see, there is no difference between sum of amount and total amount here. But if you look into this particular aspect, which says formatting option, so you can go ahead with formatting. So instead of general, you can go ahead with currency. And instead of the decimal values of auto size, you can just decrease the decimal values and choose, I don't want any decimal values. And then the decimal values will be eliminated as well. So I want to remove the zeros here. And I can remove those. So now you can see a clear difference between the total amount which we got from the aggregate method and the total amount that we got from our DAX method. So clearly, when anyone sees this particular number, they will automatically feel that this is currency related or sales related or revenue related or anything which is basically related to business. So it gives you a clear business point of view if you're using DAX. Now, apart from that, you can also go ahead with a lot more functionality to this, just apart from creating a total measure. Let's inspect that as well. So let me resize it. So apart from looking at this particular DAX as a similar looking language like aggregate functions on Excel, there is a lot more differences. So you might think the same sum function is also available on Excel or any other data analytics platform that you have already been on. So the difference is, for the purpose of creating similarity between DAX and the previous functions that you've already used, they are using the similar syntax, which is sum, bracket, and the shipment table name and the amount column. But deep down, it is like alphabet, right? You might have the same alphabet on your language that you're using, but the way it is being used is a lot different. So it's like you're having the template of English language to write the terms of other language. Let's say you wanted to write something in a different language like Japanese, but you don't know the script of Japanese. So instead of writing the term in Japanese script, you're writing the same term using the words of the English language, which might sound same, but the script used is different. So that's the difference between the DAX and the aggregate functions that you've already used to from the other platforms like Excel and everything else. Now, you might wonder, let's now create a new DAX and see if that particular DAX is already available in Excel or not to have a clear picture. Now, let me create a new DAX function which says count of rows. Let me create a new measure and we will name it as count rows on OWS equals to, or you can also name it as shipment count to have a better picture. Equals to count rows was the function. Yeah. So if you select this particular function, now you will be a little confused. I have never used count of rows in any of the data analytics platforms like Google Sheets or Excel, right? This particular function or a few other functions, as you can see on the set drop down here, add missing items, all except, all, no blank row, right? These are a few additional functions that you were never used to work on Excel, or they were never available on Excel. But these are some additional functions or capabilities programmed into Power BI. So we are going to use one of those. So we will be now tracking shipments. So I'll drop down shipments, and this is the measure I want to add, and enter. Now we have a new measure, and this you can see. So the major difference between any of the dimensions and fact tables here and the DAX table is you can see a small calculator logo in front of the DAX that we have created, right? So whenever you find that logo right in front of one of the data models or the columns here or the data items present here, then you should be identifying that particular entry or that particular measure is a DAX measure. Now you also might be wondering if this particular DAX measure is available in the data model or not. So, or the table or not. So if you go into data model or the table view here, if you look at the shipment table that we just created, this particular shipment table, you have all the original values, the shipment ID, shipment as salesperson ID, PID, graph or geographical ID, ship date, amount, boxes, and order status. But the measures that we created right now, we created two new measures. One was total amount and the other was shipment count. So you cannot see those items here, right? You cannot see those two DAX columns here. So it's like an added layer on top of your existing table. This particular layer can twist and turn the data. It can, kind of stress your data to extract the insights, but it will never be a part of your data table. So that's the functionality of DAX. Now, let's go back to the visualization page or the report page, as you like to call it. and try to do some evaluations on this. Now, if I drag and drop the shipment count to the data column here, I can see what are the number of shipments made by each and every employee from a person level or a product level. I think we have added PID. So from a product level, so for better clarity, I'd like to also drag and drop the product name here. So I'll drop product name. So based on this product name, I have so many sales, right? If I directly click on this particular aspect, I can reorder or we can sort this particular table. So you can see product 4 was one of the highest selling products. So we have highest selling shipment counts in this particular product. So this is the independence that gives you. Now, if I close all these things and reduce the size of my table, or okay, here we have it. Let's try to make some space for a visualization. So you will clearly understand why DAX is so important for us and what's the freedom we are getting from using DAX. That's the one. Let us include one of the visualizations here. I'd like to go with bar graph or a column chart, whichever is functional. Let's go with this particular one, column chart, and I'll have this column chart on the okay, not this one. Let me unselect this and have an additional, yeah, this is the one. Now, if I select the geographical location and add it to x-axis and then add the shipment count to y-axis, you will have a visualization, right? Now, how is it different, or how is it making so much amount of difference? But let me uncheck this. So now you will have geographical location wise data for the total amount of sale done and the total amount of shipments done. But would you have, just imagine if you had used a regular aggregate functions and if you wanted to find out the details for a specific product from a specific location, was that available for you? Unless you had a filter. Yeah, you might be telling me that if we add a filter or if we had a slicer inserted into this particular visualization, maybe we could have done it. Yes, but could you hard code it to a slicer? No, right? Slicers doesn't work that way. You cannot hard code slices to one particular aspect. It's like a switch on and switch off kind of a tool. If you click on one particular product from a slicer, it will show you the data related to that particular one. And if you automatically switch to a different one, you cannot keep that data anymore on your visualization. But in terms of DAX, you don't have to implement any type of slicers for your visualization. It is directly hard coded into your visualization. Let's imagine I wanted to find out the total sales happening for UK region. So if I just click on UK region, I have that particular sale value. And let's say I wanted to go ahead with a specific product. Let's say I wanted to go ahead with product 4, then automatically I'll have the details related to that particular fourth product ID and the sales happening in geolocation UK. So that's the power of using DAX in data visualizations in Power BI. Now, let's explore a few more DAX functionalities in Power BI. So this particular change or this particular interactivity that you find in DAX is called as, or it can be termed as, evaluation context in technical terms. So the evaluation context here is the background process, what's happening when you're trying to filter out data without using any type of slicers or filters. Now, let's go with another type of DAX here. Let's say I want to calculate total boxes. So let's leave this page and create a new page so that we have a cleaner looking data. Now, what I'd like to do is I'd like to add a DAX function. So you can go ahead with adding new measure. So this is easier for me. You can also go ahead with clicking the right click option here and writing a DAX function, whichever suits you better. So we have multiple options to create a new measure. So I'd like to go with this particular option, create new measure. And here, my new measure will be total boxes equals to, I'll use an aggregate function, sum of shipment table and shipment box. So here you already have the table and the column name. I'll just click on the tab button, close the function and enter. Now I have created a new measure which says total boxes. I think it went into the calendar table, but we don't want it to be here in this model. We want the total boxes model to be present in the shipments table. So let's collapse all these. And now I want a new measure to be created here. To create quick measure, create new measure. And the formula will be same, total boxes equals to summation of shipments table, and the column will be boxes, close the. So the column name will be boxes and close the ampersand, hit enter, and your new measure has been successfully created, which is total boxes. Now, why did we create this particular measure of total boxes? We are trying to find out how many boxes did each product consume to pack. Sometimes you might be having a very big product, right? And for that very big product, you might have to, parcel it in terms of assembly, right? A part of the product in a box, a different part in a different box. Let's assume that you have a very big inventory, and in that very big inventory, you have one product which is bigger or the biggest of all. And to courier that particular product, you might need multiple boxes. Let's say our biggest product will need 3 to 4 boxes to courier it, right? And there is another product which is equally or a little bit smaller than that, but it is foldable or it is in a way retractable and it needs only one box. Now, we are trying to identify that one particular product which is consuming a lot of your inventory just for packaging, right? In that particular aspect, if you find out that particular product, you might be looking for an alternate so that it saves you on packaging. So that's the business point that we are trying to deal with here. So for that, let's drag and drop, or let's create the same table vision for us. So we'll have a table here and we will drag and drop product ID or product name into the table, and then the recently created DAX, which is total boxes. Now you can identify, you can see, or if you rearrange it, we can see product 4 is that one particular product which is consuming a lot of boxes to courier, right? And let's also see the total amount it is getting us. So let's have total amount here. Now you can see it is earning us about $33.2 million with such amount of boxes consumed. And let's rearrange this. So if you can see, we also have product 22, which has, okay, let me expand this a little so that we have a clear picture. So here you can see, earlier we shows product 4, which was giving us 32 or $3.2 million with using the highest number of boxes. But here, comparatively, 1/4 of total packaging, we have the most highest profit from product number 22. Now here, what we achieved is, we need to identify which is product 4, and we need to look for alternatives so that we can save a little bit of money on packaging and couriering the product, right? So this gives you a clear picture of business aspect that you must be looking into, right? DAX is the one which gives you this freedom or this level of freedom to identify and execute some business decisions. Now that we have understood the reason for this particular freedom, let's dive into the next aspect of today's DAX, which is DAX reusability. So this will take us back to the point 1 where we discussed about the syntax of DAX, right? So we initially thought the syntax would be different, right? So we will be having a DAX name, the second part will be equals, and the third part will be the table name and the column name. Now comes the part where we discuss the differences, right? There will be a little difference in this particular approach where we will be reusing the already built DAX. Now, you can also go ahead with the standard procedure of using the table name and column name But the reason for not going with the standard way is different. So this gives you an advantage, an edge to identify which is, so we have two types of functions basically. Whenever you use an aggregate function or the function that Power BI provides you, that particular function is called as the implicit method, and the one you specifically write is called as the explicit method. So when you are using a calculated DAX for recreating a new DAX, then you will identify this particular method is already an existing DAX and it is a measure. And in case if you're using a table name, that means you're using a specific hard-coded table name. That helps you differentiate between these two approaches. That's the reason why we don't go ahead with the standard approach of using table name and column name when you're trying to reuse the existing DAX measures. For example, let's go ahead with identifying which box had more boxes per shipment. So here we had created right total boxes and total amount. So for identifying boxes per shipment, we will create a new DAX. So let me expand this. So let's create a new measure. And we will call this particular measure as boxes per shipment. So it's similar to the previous approach or previous calculation we did. So boxes per shipment can also be calculated by using total boxes. We created a total boxes thing here, right? You can drag and drop this particular thing here, or you can total boxes. So the key identifier that if you are reusing a DAX or if you are reusing or using a column name is this. If a formula starts with box bracket, then or square bracket, that means you're using a DAX. And if you are using the normal parenthesis, then it means that you're using an existing column. So total boxes divided by shipment count. So shipment count. So this is the one. Press tab to enter. Now you can close the parenthesis. I think we did not create a parenthesis in the end. Okay, that's fine. So press enter and your new DAX or the DAX which has been created by reusing the existing DAX is created here. Now what you can do is you can drag and drop boxes per shipment and identify maximum boxes per shipment. So if we rearrange this, just click on this particular aspect and you can reorder. Now you can see the product number 18 actually used a lot of boxes per shipment, right? And the initial aspect where we identified total number of boxes. So yeah, I think now we have a clear picture. Previously, we misunderstood that the total number of boxes used by product 4 were highest. But when the final packaging comes, there is a possibility where the exact number of boxes could be a little different, right? One huge box might have smaller boxes inside it, right? It's like an abstracting process where you package every minute item into a small box and all those small boxes will be packaged into a large box. Now this particular thing, what we have here, gives us a better advantage. Now you can see obviously 4,80,000 or 480,000 boxes were used to package product number 4, but at the final count, it is using 753, which is a lot closer or a lot similar to product number 18, right? So here you can see a minute difference between the two packaging. So that is the level of detail we can get into by using a little bit of DAX for business purposes. Now, if you proceed a little bit into details, then the next thing we can calculate is amount per box or amount per shipment. So let's create a new measure, and I want to identify amount that we are spending per every single shipment. So amount per shipment is equals to, now remember the divide function we previously discussed about. If you might have, maybe there is a possibility that you might end up having 0 value in the second column, right? The column which goes under the denominator section. And if you divide such particular numbers, you might end up with divide by 0 errors. To avoid that, you can simply call a divide function here and mention the columns that you want to divide. So here we will send out two particular columns or DAX calculations. So total amount is the DAX calculation that we previously created. And the second value is people. So we'll be using people table here. Or I can write down salesperson. We have a people table, right? So why am I not able to identify people of salesperson? Okay, let us try that differently. Anyways, we have the amount spent per packaging here, but we just wanted to explore a little bit of DAX reusability. Let's try to hard code that. So under people's column, we have PID. Salesperson. Okay, let me try this particular approach. Salesperson. Still unable to identify. Let me create an parenthesis and type the table name. No news. But anyways, we have the shipment per box here. Let's close this. Let's deny this or cancel that particular DAX. But anyways, now we enter into one of the important functions of DAX. Now, this could be a game changer for you in perspective of business analytics. So that function is nothing but calculate. So let's create a new page and enter into the new page and try to create some functions, DAX functions using the calculate method. Now, let's say I want to identify the amount of sale did or done by each person. So for that, I'll write a calculated or calculated field or new measure. So I'll go with this particular aspect. I'll create a new measure in the people's table, and the measure will be named as employee amount equals to calculate total amount, comma, people and salesperson. So previously we did not find this, but now Power BI was able to find salespersons. Some unexpected error, not a big deal. So apart from this, I want to find out for a specific person. So if we go into the tabular view, and here we have Emily Davis. Let's say I want to calculate the total sale done by Emily Davis. So rehearse that or copy this particular name and go back to report view. And where is our, this is the one. So we need to edit this particular DAX function, and salesperson is equals to, we copied, okay, I think we have everyone here. So let's erase all those. So I want to keep just Emily Davis here. So you can again come up with a new idea, or you can again come up with a new doubt where you can say, why use a filter in DAX if we already have a slicer, right? So you can do with this using a slicer, but as we discussed, when you use slicers, the slicers behave like an on and off switch. So when you switch from a different person, automatically the the control will also switch from an existing person to a different person. Now let's compare that side by side. Now this is my DAX and I'll enter, and we have the DAX. Now what we can do is we can drag and drop product. So let's create a new visualization. So we can drag and drop product and sales done by Emily Davis, and also we can have a salesperson as well. And if I drag and drop the amount once again, so here you can see the difference, right? In the first section, we selectively filter Emily Davis and the number is as is. And when it comes to the second filter, you don't have a filter here. You have all the data excluding Emily Davis and everything is normal, right? So this is the main difference that we are dealing with. So apart from this, if you wanted to identify the specific number of sales done by a dedicated employee, then you can create this calculate filter for a dedicated person in a many number of ways. Now, let's head into one last approach for DAX, where let's say we have a target and every employee has some target, and we want to find out if that particular employee has achieved the targets or not. So let's go and add a new measure, and the measure will be named as sales target. And sales target is equals to, let's say, 1.5 million. So hit enter and we have sales target here. Now let's create a new measure. It's like an if condition. So if the sales target is achieved, then fine. If not, you mark it as not achieved or something like that. So we will create a new measure and we will write the measure as follows, as performance is equals to if condition total amount. So total amount is greater than sales target measure. We're reusing the measures again. Then you can write it as target achieved else not achieved. So this will be my DAX and hit enter. So I've created a new DAX here. Now what we will do is we will drag and drop, we'll create a new table and we will drag and drop salesperson onto the table and total amount that we have done. And we will also add that performance DAX calculation that we created. And now we have a clear picture how many number of employees have already achieved their target and how many did not. For example, here you can see Carter did not achieve his target and Ava Lewis did not achieve her target and so on. So the minimum bare number that we wanted to keep in order to find out if a target is given target is achieved or not was 1.5 million. So there are people who already kind of overachieved, and there are a few people who did not achieve their target. So there are multiple ways that you can include and try to work on with using DAX. It gives you a lot of freedom than the basic implicit functions that you already get from Power BI, like the aggregate functions like sum, average, mean, and median, right? Now let's consider a small use case for you. Now let's also find out, consider this as your homework. Now, just like we had the target for salespersons, let's have target for product as well. Or you can just simply write the DAX commands that you're going to perform on your Power BI in the comment section below. So write down a DAX function to find out the product's target. Let's say the minimum the minimum sales for a product is about 500, and find me out the products which achieved their target and which did not, so that we can find out the performance of product visually and identify which products needs a little bit of marketing and which are the products which are highly performing, and we can slightly increase the rates so that we can get a little bit of profit out of them. So this brings us to the end of module 7 on DAX basics. So let's continue with the next module, where we will find out interactivity and drill downs, or basically creating a fully functional dashboard. So now we enter the next module, where we will be understanding how to build charts and add slicers, filters, and basically create an interactive dashboard combining all the learnings that we have learned so far and create a completely business-oriented dashboard for interactivity and insights. So let's go with the Excel files for this particular data set. Now we have this particular Excel file here. Before we get started with the data set, let me bring back our learnings, where I used to tell you once you use, let's go back to Power Query once, where I said you there is this particular feature in Power Query where you just provide the location of the file once, right? Whether it is on a database or a server or a cloud, or if it is just a file location on your local system or anywhere, we just provide the location of the source and create some queries or create some steps for data cleaning. And after that, if you load the data to the platform like Power BI, the modeling or the data visualization becomes easier for you. And whenever you add new data to it, Power Query will automatically learn or use the learnings from the previous transformations and changes to the data set, and it will implement all those for you, makes the data clean, and you can just focus on data visualization without wasting any time on data cleaning or data transformation part. So we will be bringing that back in this particular demo. So here on my screen, you can see I'm providing a file name as location prior learning. So this location will have 1 year's data, which is very old, 2021's data. Let's assume that we have a brisk business statement here, and we are comparing year on year performance wise. And here, if we come out of the location, here we have sales data for 2022, 25, 24, and so on, 23, right? They are ordered a little different, but not a problem. What majorly our concern is, we are having 5 years of data, right? So we'll start our process of data visualization with one particular file, and then we will build an entire dashboard with just one file. And the magic happens at the last stage, where we add all the new data, what I'm talking about is, let me highlight them, all this new data into this file location. And once we add it, the dashboard, what happens in the background is Power Query will check all the data sets that we have recently added into the location, and it will reanalyze, rerun all the numbers and update the dashboard on the fly within a couple of seconds. So that's our approach. Now, the data that we are dealing with is here. This is the data set. We have sales data, so it is order ID, order date, on which date was the order placed, the delivery date, right? What was the delivery date, order status, if it is delivered or not. We have customer ID, we have customer name and last name, the state in which that particular product was delivered. We have this region, is it east or west, north, south, and central regions of the location, and what was the product, and what product or what category does the product belong to, if there is any subcategory for that as well, and the number of quantity, and what was the initial traffic to the website, and how many number of traffics converted into leads, and how many of those leads converted into orders, and what was the quantity, right? And we have cost to company and also revenue and profit. So profit is nothing but the difference between the cost to company and the revenue, right? You might create a product for 10 rupees and sell it for 12 rupees. Then your profit is 2 rupees. That's how revenue and profit and cost to company matter. So this is the overall basic agenda for our dataset. And this particular dataset is already cleaned. So we have split customer, first name, last name, and to reduce the length of this particular demo section, we have used the clean data, and you already have a good understanding of data cleaning, modeling, and DAX functionality so far. So we will be directly ingesting this data into Power BI platform. So I hope you have a good understanding of what kind of data set are we dealing with. We are dealing with sales data. We have order details, customer details, location details, and the traffic, lead, orders, revenue, profit, and quantity details all in one shot. You don't have to, kind of create joins or merges. We also dealt with joining data tables, merges, and how to append the data. And we don't have to work on all those complicated things. We can just understand basic functionality of how to create data visualization on Power BI platform, how to have a good background, a user interface. So coming back to user interface, let me show you one of the interfaces that I created. So this particular image that you're seeing is created for user interface purpose only, user experience purpose only. So when you directly go into Power BI, you don't have such a beautiful, a good, decent, if not beautiful, a decent background. All you get is a plain white background, but it doesn't end there. Power BI gives you an opportunity to add or customize your own background to elevate the user experience for business leaders. So you need to understand what is the business purpose of your organization. So the purpose of this particular example is the business leaders wants to identify what is the traffic they are dealing with on monthly basis or year basis or provided date basis, and what are the leads. So here you can see we have state, year, and month. We can drill down. So we'll also go through drill down and drill through options. So we can drill down the sales date into years, into months, and dates as well. So here you can see month and year. So we can have that as well. So the business leaders wants to identify in a dedicated state, in a dedicated year, in a dedicated month, how was the traffic, how were the leads, how many number of orders did we receive, what was the revenue, and what is the quantity of orders did we receive. And if you scroll down a little bit, you can see region-wise sales, North region, South region, West region, East region, and Central region, and category-wise sales. What category of products sold most in what region, segment-wise sales. So if you go through this, you can see how detailed this particular approach is. You can find a product level data, you can find subcategory level data, you can find category level data. Apart from this, you can also find out location-wise data, which state had particular product sales high or low, which region of that particular state had a dedicated product high or low, right? And also you can see geographical location here, which is the biggest box. So in this biggest box, we will have one of the visualizations, which is geographical visualization, or also called as map chart. And here at the last, you have month-wise sales performance. So one thing to remember, whenever you're dealing with date-related data, if you have one of the measures or one of the dimensions as date, then it is by default, you should be going with a line graph, because line graph is the one which shows you the performance. If it is growing, if it is spiking, or if it is dipping, right? That's the purpose of using a line graph whenever you have date. So remember that. And rest of the ones, when it comes to the first row, state, year, and month, you can go ahead with filter or slicer. We'll also be customizing slicer. So the best part of this section is you can see the minute details, how, the slicer level things, the background for a slicer, the color for a slicer, the drop down choice, right? For a slicer, you'll be having a vertical box. You can customize that to a drop down. You can also ingest a feature where you can have a search bar logo on that, so that when you click on search, you can simply type which date you're looking for, and it pops out, filters out for you. And the same can be implemented for year and month. And you can also add KPIs, right? Cards are used for KPIs, key performance indicators, right? When to use cards, when to use a donut chart, when to use pie chart, when to use a bar graph, or when to use a column graph. Or apart from that, you'll also have a few more other alternatives like, a stacked bar graph, etc., and map chart. So you cannot use map chart for a bar graph, right? So the experience of using a dashboard matters a lot. So you can use, let's say, traffic by you can use a donut chart for indicating traffic. But will the purpose of indicating KPI be satisfied? No, right? So that's the basic sense you need to have. What kind of chart is created for what kind of indicator on a dashboard? When you're going ahead with KPIs, then cards are the best indicators. And when you're going with region wise state, like when you have less than 5 dimensions or measures, it's better to go with the pie chart or a donut chart because it gives you the accurate amount of division of sales between the regions. So in regions, we have about 5. So we have north, south, east, west, and central. So this type of chart or this type of measure can be depicted using a pie chart, which has better visuals. And same goes with category. We have a couple of categories like 5 to 6. Then you can go ahead with a donut chart and segment-wise sales as well, right? You need to have that simple understanding of what kind of chart is best suitable for what kind of representation of data. So this comes to the user experience and interface section. So you're free to use any tool for creating better backgrounds. I've used PowerPoint for creating this particular picture. You can use Canva or any online tools. You can also write a prompt to your ChatGPT and share the data with it and share your business request or the business owner's requirements so that it creates a good user experience or user visual for you, and you can download that and replace that with the background. So that's about it. So apart from this, we also have a few other visuals. So here I have a social media dashboard. So you have follows, views, likes, shares, comments, right? If you're dealing with social media platforms, then you can go ahead with this one. So here we have buttons as well. X for Twitter, Meta for Facebook, Instagram, Snapchat, and YouTube. And you can also select the platform, state, region, resource. So we have this entire end-to-end tutorial on our channel. So you can also go through that. If you require this particularly, you can also comment us and we'll share the dashboard with you and the tutorial with you. So we have a lot of different varieties of approaches for building a dashboard. So this was the one which we will be using today. So this is also one of the dashboards for creating sales one, and this is the one which we will be using today. So now with that, let's go to the Power BI platform. So let's give it a moment to load. So there you go. And we will be using a blank report for this one. Let's open a blank report. And to get data, we have a lot of options. Let me cancel this out. So to get data in the Power Query section, we have understood what are the different variety of sources available to get the data from. So here, I will not use Excel directly. What I'll do is I'll go to more options. And from here, I will have an option which says folder, right? When you select folder, it will ask you for the location of the folder, for the path of the folder, right? So you can open on browse window. Then your data is in downloads. My data is in downloads. You might have a different location as well. So here, or what I can do is I can cancel this. I can directly go to the window where I have my data. So it's easier for me to navigate. So it's in PBI and in location. So just copy this location. This is my location. Go back to Power BI platform and just paste the location over here and press OK. Now, what happens is Power BI will automatically understand which data is supposed to be loaded. So here I have the data set. Click on it. So there has been a small error. So let's try that once again. I think it took 2 sections or 2 rows. Must be a smaller, don't worry. Let's give it another try. Yeah. There is a small error here. Let's try that. Yeah, we need to drill down. Just click on that expand button and it will expand the data for you. And now select the sheet. This is the preview that we were looking for. And I think everything is good to go, as this data was considered the best one. I mean, it was already cleaned. So let's anyways have a quick preview. So we have order ID, order date, delivery date, order status, customer ID, customer name, and state, region, product, category, subcategory, quantity, traffic, leads, orders, cost to company, revenue, and profit. So as we discussed during the DAX module, unless you have a clean data fully functional for analysis, you cannot proceed with analytics and it will not make any sense at the end of the dashboard. So I'm satisfied with my data. I want to click on OK for loading the data. So we have almost everything that we were looking for. So if we go back to data table view, I want to delete this particular one and go back to home. And I would quickly refresh the data. Now to the visualization train, and everything is now good to go. Now we will start with applying the canvas settings or canvas background. I would like to browse the picture. Can I keep it? So this was the one. Click open, and image fit will be fit, and transparency will be down, so that we have a good visual. Discard the changes, and we are almost good to go. Now that we have a good background, we will start with making the visualizations. So first we will come from top to bottom. So the top section is about including a state level slicer. So what I'll do is I'll go to the visualization screen. So here we have a wide variety of charts. We have stacked bar chart, we have stacked column chart, we have clustered bar chart, we have clustered column chart, and then we have a 100% stack chart. This is the column chart again. So this is the line graph which I was talking about. This is the area chart and the stacked area chart. Next is 100% stacked area. This is a combination of both column chart as well as a line chart, and there is a different purpose for this as well. So each and every chart available here has a different purpose. So this is the ribbon chart. This is one of the waterfall chart which we most commonly use. And then here we have a funnel chart. Then the scatter chart. So scatter chart is really helpful when you have the comparison performance, right? So if you have, let's say, employees performing date to date, then you can go ahead with scatter plot. So it shows you an indication of growth as well as a performance on a dedicated spot. So the performance is spread in dots in the graph. Yeah, so you can go ahead with that. And the pie chart, donor charts that we discussed before. And we also have a tree map chart, which is similar to similar to pie chart and the donor chart. But the only difference is the representation will be in the form of blocks. And here we have the map chart, the geographical locations, and we have the filled map chart as well. So both stand same, but if you use map, the fill will be indicated in terms of a dot. But if you go to the filled map, you'll have fully filled geographical locations. And you have Azure map, you have a gauge here, and these are the cards. And next is multi-row card. Then this is the KPI indicator, the slicer, the regular table that we use, and this is the one, the matrix chart. We have R script visual, Python script visual, and we have key influencers and decomposition tree, Q&A questions as well. You can include this in the dashboard, and you can try to ask questions. Like, let's say I want to find out which product sold best in provided state in a provided year. Then you can quickly get that particular visual. This acts like a chatbot for your dashboard. That's a very good feature in Power BI. And then we have narrative, which explains or which gives out the narratives on the performance of dashboard. Then we have metrics preview, then we have paginated report, then the card and new slicers and all the other things, which is AGIs match for Power BI, Power Apps for Power BI, and this is Power Automate for Power BI. So Power Automate is a whole new segment of learning. So we have a completely dedicated tutorial on Power Automate. So you can drop us a message in the comment section below so that we can share you the Power Automate tutorial for Power BI. So, and apart from that, if you see here, we have drill through and cross report options here. Now, let's get back to the dashboard and try to add the slices that we were discussing about. So we will just click on the slicer and we have a slicer option right here. And let me drag and drop somewhere else. Now, here we will go into the visualizations format of this particular slicer. So let me drop the state location. So here we have now we have visuals. So we'll go into general and I think we don't need a title for this one. So I'll keep it off. And we'll also go with the background. I don't want any background for this since we've already set it. And we don't want a visual border as well. And shadow, I think we don't need a shadow. Header icons, I don't need header icons. And background is also turned off. Transparency is 100% complete. Title is done. And properties. And I think I'm almost satisfied with what I have. Now, apart from that, if we come into slicer visuals, I don't want the slicer header. And if we come into slicer settings, remember the drop-down setting we spoke about? I don't want the vertical list. I want a quick drop-down. So now I'll try to make it fit in the section where I, created the state. So this would be it. So I'll try to rearrange it to fit into this particular space. Oh, there you go. Now what I can do is I can also include the search icon. So whenever I click on the drop down, I have a search bar over there. Let's say I want to find out maybe Madhya Pradesh. I can just type down Madhya Pradesh and I'll get it. So now that the slicer is fit and done, now what I can do is to save time, I can just copy and paste it, right? I have a new slicer altogether. I'll just drag and drop this particular slicer to here. And similarly, I will copy this again and paste. Now I'll drag and drop this to let me select it to month. So the only thing that we will be changing for this particular slicer is, so instead of state, we will be selecting year. So we have order date hierarchy here. So if you open the hierarchy, you can select year in place of state. So we'll unselect state. Now we here have all the years. So for now, we just have 2021. So remember, we just selected one year per this particular visualization. So we will unselect state and we will open data hierarchy. So for date hierarchy, and then we will select month. So now we have all the states, all the years, just 2021 for now, but it will increase to 22, 3, 4, 5, and 6 later on. And we have all the months for the month section. Now the first slicer section is done. The next one is the cards. So what you can do is select a card, and this particular card will have the number of traffic. So you can see Power BI was able to calculate, the summation. So it automatically aggregated the total traffic happened. So now we will go into visuals for this one. So general, and we want header icons. We don't want effects, so background will be turned off. And apart from that, we don't want shadows and everything. So if you go into visuals, so here we will be having the category label. So we don't want category label because we already have a category labeled implemented into the dashboard itself. So we will drag and drop it somewhere here. And once you're happy with the location, the same thing what we did for slicer can be replicated here. So you can just copy and paste it. And now what you'll do is drag and drop to the leads section. You can also auto align that, and you can do the copy paste once again, and you can auto align to number of orders, copy and paste for revenue. So you can auto align for revenue as well. And one last copy paste for quantity. So copy and paste, auto align, and you have the quantity. Now what changes is in leads, you need to unselect traffic and you need to select leads section. So here we have the summation of leads, and in the orders section, you need to unselect traffic and select the total automation, which is the aggregation for orders. Similarly, you can go to revenue, select the revenue summation and unselect traffic. And last is the quantity one. So you need to unselect traffic and go to total orders or total quantity of orders. So far so good. The first two rows are resolved. Now we have the region wise sales. Remember we discussed if we have 4 to 5 elements and not more than that, you can definitely go with a pie chart. So we'll go with a pie chart here. Okay, let me quickly undo that. Okay, now select or click anywhere on the dashboard and now click on the pie chart so that you have a fresh pie chart there. Now what you need to do is we have legends, right? So you need to add region data into legend and values of orders to values. So there you go. Now you can go to the visualization. I don't want legend. I don't want you can have detailed labels, however, and when it comes to title, I don't want title for this. I don't want header icons, and tooltips you can include, or if you don't want, you can also remove them. But I want detailed labels and any effects, visuals, background, and yeah, everything looks good to me. You don't have any background. Now you can slightly increase the size of the dashboard and make sure to fit it into the dedicated location provided for this particular visual. There you go. Now comes the category wise sale. So click anywhere on the dashboard, use a donut chart, and for this particular one, category. So where do we have the category? We have subcategory, and should be somewhere here. So we have the category here, and you can drop category to legends, and then you can order to values. There you have the category wise sales. Go to visuals, the same steps we did. We'll just have detailed labels, and title, we don't want the title. We don't want tooltips. Now you can close this, and just like we did for the previous one, you need to fit it into the space provided for this particular visualization. Now we have segment wise sales. So for segment wise sales, we have a lot of segments. So when you have a lot of segments, it's better you go with column charts. So I'll go with this particular column chart, and we have a column chart there. And now we will have segment in the X axis somewhere here. Look for segment. Okay, subcategory. I think subcategory, yeah, we do have a subcategory. I think we don't have a segment, but we do have a product. So I think it's better we go with the product category wise, subcategory wise. So we have a lot of products, however, I think we missed out on the segment part. Or let's go to the table view quickly so that if we can find out we have any segments or not. This is the location, and here is the data customer. I think we don't have a segment, but that's okay, not a big deal. So in place of segment, we can include product, but we have a lot of products here. But anyways, in case if we apply a filter, let's say we apply a filter for a dedicated category, then we might drill down the products into a little bit. So let's have products there. Anyways, so drag and drop product to x-axis, and we will have orders in y-axis. It might be a little segregated, or it could be a little compact for this particular space. So we don't want header icons, don't want tooltips. We can keep tooltips, but for now it's okay. And yeah, everything is plot area background. So do we have a plot area background? No. So this is good to go. And same as before, we need to size this to the location provided. Yeah, similarly, we have a subcategory as well. So you can click anywhere on the dashboard and then go to visualizations. You can include a bar graph, and then what you can do is simply drag and drop subcategory to columns. And you can add orders, total orders to x-axis, and you'll identify how many number of orders were placed by how many number of products based on products. So you can click the visual, and just like we did before, we can make some general changes to it. We don't want title, we don't want header icons, and we don't want tooltips and visuals. So we don't want any plot area background. So far so good. So let's select all. Just like we did before, we need to fill in the area allocated for the subcategory. There you go. Now, grid lines, we don't want grid lines. Slicer. Just check for each and every aspect so that your slicer or your, visual stands out. And ribbons, data labels, all the plot area. So the overall intention of creating a better visual experience for your end user is having a good representation of all the insights or visuals you build. So unless you take care of all these things, then you might end up in just another dashboard which doesn't look or feel good for the end user. So that now you have everything sorted out in one place. Now comes the next visual. So click anywhere on the dashboard, and then you need to click on the map, build map, or any map that you want. And then you need to open the data, and we will add state to the legend. And then what we will do is total orders, so that we will identify how many number of orders are being bought or are being received from entire location. So if you want roads, you can keep the roads. And general settings, we don't want title. We have already given the geographical location and tooltips. There you go. Now, or what you can do is you can quickly fill in this particular area dedicated for the map region. There you go. Now the last one is the sales month on month. Remember, whenever we are dealing with date to date, year to date, month to month, or last date today, remember the time functions that we discussed in time intelligence section. That's the one. So whenever you have time related data, repeat. So whenever you have time related data, go with line graph. So click anywhere on the dashboard, then go with a line graph, and your line graph will be created. Now on the x-axis, you need to drag and drop month. Inside the date hierarchy, you have month, right? So drag and drop that to x-axis so that you have month on month. And now drag and drop orders value to the y-axis so that you can see month on month performance. Similarly, go to the visual section, and here check all the aspects, and general section, And here we don't want title, header icons, and tooltips. So everything will be provided by just one click. So just close this one as well. Now extend this particular graph to fill in the area dedicated to that. And here you have the tooltips. So I think we need the tooltips. So go to the visualization section and here go to, So if you add tooltips, then you'll have the values which are happening in that particular location, right? So now you have a completely interactive dashboard. Now is the best part. So let's say I want to identify for a dedicated location, right? So here I will select Delhi and I'll have the sales performance happening in Delhi right now. So we have about 17,000 traffic, and out of which we have 1800 leads, 19 orders, and so much revenue. So we need to expand this a little so that we have an actual number. So we have about 647 revenue, which can be in millions or something like that. And this is the total number of orders we received, 207. And provided if you want to drill down a little bit, you can provide the dedicated month. So in the August month, so many leads were there, but no orders. So depends on the seasonal value also as well, right? So if you have April, then you might have, when you go into some other month, maybe June. So maybe due to some seasonality, like any festive seasonality, you have some orders. So based on that, you can achieve some orders as well. So apart from that, so if you unselect Delhi, and you'll have the overall countrywide sales, revenue, orders, leads, and quantity details. Now comes the best part. Now, let's go to the data location once again. So I have my data in PBI, and this is the location. Now what I'll do is select all these data sets. And what I'll do is simply drag and drop inside the location. I did not do anything yet. Now I'll close this and go to the dashboard. Nothing changed as of now. What I simply do is refresh the data. Once I click on the refresh data, new data is being loaded. Just click on close. Now you have the data for all the years. So if I click on year, so you can see automatically we have 2021, 22, 23, 24, and 25. Initially, we just had 1 year, which was 2021. So all the data cleaning that we did, like a quick review of what the data is looking like or what columns and rows we have, right? All that part has been done automatically or implicitly inside Power Query, and we have all the data ready for publishing or sharing with our business owners or your clients, basically. So now, the next point is all about publishing this particular report or sharing this particular link to the business owner. And in the next section, we will be learning this. And that brings us to the end of this particular module on data visualization, charts, and adding interactivity, drill down, and all the aspects of a data analysis dashboard using Power BI. Welcome to module number 9. In this session, we will move beyond Power BI desktop and into the Power BI service, the cloud platform where you publish, manage, refresh, share, and embed reports at a scale. By the end of this module, you will be able to publish a .pbix file from Power BI desktop to the Power BI service and understand what is being published, which are reports, dataset, or model, etc. You can manage workspaces, roles, and the lifecycle of content and datasets. Configure dataset, which is refresh, including gateways, credentials, incremental refresh, and troubleshooting. You can also share reports and dashboards with users and teams effectively while maintaining security and governance. You can also embed reports into applications and web portals and understand the difference between embedded models and permissioning approaches. We will balance step by step, which is how-to instructions, with architectural reasons and governance best practices. So you know both what to click and why that choice matters in real business. So let's get started with part A of module 9. So the part A will be basically about how publishing works. So you need to navigate to desktop, then choose the service option. So let's start publishing. Publishing is the act of taking Power BI file, which is .pbix file you built in Power BI desktop, and uploading it into the Power BI service, which is app.powerbi.com, where it becomes a dataset, a report, and optionally a data flow or paginated report, depending upon how you build it and what you build, what you publish, when you publish from desktop, and how effectively you upload the three things: the report definition, the collection of page visuals, bookmarks, and layout; the dataset or semantic model, which is the second one, which is about the tables, relationships, DAX measures, metadata, and the connection strategy, which is basically how to import data query or a live connection. Then comes any query logic, the Power Query steps that you made, the produce data, the service stores, and the query logic in the dataset, so future refreshers can rerun the extract or transform steps carefully. Put simply, the report is the front end, the dataset is the engine, and the query logic is the recipe that builds the engine from source systems. How to publish step by step. So from Power BI desktop, you can either select the file to publish the Power BI option, or directly you can choose to click on the publish button from the home ribbon. You'll be asked to pick a workspace destination, select the workspace you own or have publish permissions to. The desktop app then uploads the .pbix file to the selected workspace. After a successful publish, you can open the report in the Power BI service and the dataset will appear under the workspace dataset section. Now, let's go through the key considerations when publishing. So firstly, the workspace choice matters. Don't publish into My Workspace, which is the default location for production reports. Use dedicated workspaces that you create for your teams, projects, or production apps. Workspaces map to content lifecycle and permission boundaries. A workspace should be the unit of collaboration and governance. We will dive into workspace roles shortly. So connection mode influences refresh and performance. If your dataset uses import mode, then Power BI stores a copy of the data and you must schedule refreshes. If it uses direct query or a live connection, the service queries at the source at runtime or caches limited resources or results, changing how refresh is handled and affecting concurrency and latency. So for this reason, it is better that you always choose the mode that matches your SLA and data size. Next is size limits and licensing. Large datasets and high refresh frequency may require premium or PPU capabilities. Check the organization's license and workspace capacity. If you run into file size limits, consider optimizing the model, where you can remove unused columns or use aggregations or move to a premium capacity. What to expect after publishing? Once published, your colleagues can view the report in the workspace if they have access, provided if they have access to it. The dataset can be refreshed on schedule and you can package the workspace content into an app to distribute to a larger audience. You can also download the report back as .pbix if permissions allow you. The service stores publication history and basic lineage. That's the publishing core. Next, we will look into workspace architecture and how to manage datasets after they are in the service. So let's go into the part B, which deals with workspace management. So roles, apps, and the best practices. Workspaces are the organized container in Power BI service. They hold reports, dashboards, datasets, data flows, and paginated reports. Workspaces are where teams collaborate, prepare apps, and manage lifecycle between development, test, and production. Now let's also take a look through types of workspaces. Microsoft has new modern workspaces which replace classic work pages. They provide better role control, governance features, and app publishing options. They create a workspace for each logical area or project rather than using a single workspace for everything. Now let's go with roles within a workspace. There are distinct roles you can assign to people and security groups. For example, we have admin. So admin has full control. He can manage workspace settings. He can add or remove members and delete workspaces as well. Then comes the member, who has the permissions to edit content, publish reports, and create apps. Followed by that, we have contributor, who has the right to publish and update the content, but has limited management rights. Then we have the viewer, who has only read-only access to the content inside the workspace. They can't edit or do anything with the report. Now, assign the least privileged role necessary. For production workspaces, use to publish apps, keep these sets of admins small, and use members or contributors for content authors. Viewer role is ideal for users who only need to consume reports without editing. Now, let's discuss the difference between apps versus the direct workspace consumption. An app is a packaged, curated distribution of selected workspace content intended for broader audience. It provides a stable URL, consistent navigation, and controlled access. Use apps when you want to distribute read-only content to a larger user base. Use workspace access when the audience needs collaborative editing or testing. Now let's discuss about the workspace lifecycle and governance best practices. So it comes from developer to QA, QA to production. Maintain separate workspaces for development, testing, and production. You need to encourage authors to publish to dev, QA, or validation, and then promote the production where you can republish or deploy the apps. Now let's go through the naming conventions. Name workspaces and datasets clearly. Include environment tag. For example, sales production, sales development, right? These are the tags you can use. And next comes the content endorsement. Use endorsement, for example, certified or promoted or trusted datasets to guide users towards single resources of truth. Certified datasets indicate governance vetting. Now, let's go through metadata and documentation. Add descriptions to datasets and reports and keep a README page in Workspace with intended use. Data sources and owners contact as well. This will be helpful. Now let's go through monitor lineage and usage. Use Workspace and tenant usage metrics to track adoption and performance. Remove stale content and archive older versions. So let's go through an example. Imagine a company BI team supports sales reporting. You need to create 3 workspaces. First one, which is sales developer, which has only authors who build the reports. Next is sales QA, which has analysts to validate the report. And lastly, we have sales app, which is production app published to all sales managers in one go. Now, only a small set of admins and members exist in developer or QA teams, while the app is distributed to hundreds of viewers. Proper workspace management reduces confusion, enforces governance, and controls cost, which is capacity of usage. Now, let's dive into the part C, data refresh. The concept, setup, and troubleshooting will be dealt here. One of the most important operations after publishing is keeping your dataset current. Dataset refresh is how Power BI updates the imported data in the cloud so reports show recent information. So now let's discuss the refresh modes and triggers. There are multiple refresh mechanisms. So the first one is scheduled refresh. The most common one is this one. You can configure frequency in the dataset settings, which is based on hourly, daily, or even weekly. Power BI will run the stored Power Query steps and reload data from import mode datasets. Next is on-demand or manual refresh. You can run a refresh immediately after the dataset UI. Useful for ad hoc updates. Now let's go through push and streaming datasets. It is used in real-time scenarios where external services push the data into the Power BI. Followed by that, we have Power Automate or API. So this is actually a trigger refresh which happens through automation flows or API calls for event-based updates. This is useful when data source systems signal the data changes. Now comes the gateways and on-premise data. If your data source are on-premise like SQL Server, analysis services, files on network share, etc., you need an on-premise data gateway, which is a lightweight service that securely facilitates connections between Power BI in the cloud and your internal data. Install the gateway on a reliable server, register it to your tenant, and assign it to the workspace or the dataset. The gateway supports clustered mode for high availability. Don't run the gateway on a laptop. Use a server class machine and put it behind appropriate monitoring. Next, let's discuss about the credentials and privacy levels. In the dataset settings, you will set the data source credentials. Make sure credentials are valid and use service accounts when possible rather than personal accounts. Review privacy levels if used for proper data handling of joint data. When credentials fail, your refreshes will error out. The refresh history gives you the failure message to diagnose. Now let's move into incremental refresh to scale large datasets. For large tables, use incremental refresh to avoid reloading entire tables every time. Incremental refresh allows you to partition time-based data, refreshing only recent partitions and keeping historical partitions static. A huge performance win. To use it, you typically define range start and range end parameters in Power Query and enable incremental policies on the dataset in the service. This feature is essential on large datasets and often paired with premium or PPU capabilities for higher limits. Now let's discuss the refresh limits and quotas. Be aware of refresh limits related to license type. Free workspaces have limited refresh options. Pro and PPU have larger quotas, and Premium provides the most frequent and larger model support. If you need many hourly refreshes across many datasets, Premium capacity is usually required. Now, let's go through troubleshooting refresh failures, which is a practical flow. So, check refresh history. The dataset settings page contains the refresh history and no error messages. Note timestamps, error types, and affected tables. Next, we have verify credentials. Test data source connections in dataset settings, update passwords or service account tokens as needed. Then we have gateway status. Confirm the gateway is online and on the latest version. If the gateway is offline, refreshes will fail. Check gateway logs and network connectivity. Timeout and query issues. If refreshes timeout, look at query complexity, break down running transformations, or push transformations to the source. Consider aggregations or move heavy transformations upstream. Next ahead, we have concurrency and capacity. If many datasets refresh simultaneously, the queue can delay refreshes, stagger refresh schedules, or scale capacity. Use the Premium Capacity Metrics app to monitor the saturation. Followed by that, we have data schema changes. If the source changes column names or data types, Power Query steps can break. Maintain communication channels with data owners before source updates. Now let's go to some advanced options. Refresh templates and cascading refresh, which is from Fabric. So for complex pipelines with semantic models and data pipelines, you can orchestrate refresh templates or chain refreshes so upstream data flows refresh before downstream datasets. This gives more reliable end-to-end data refresh in advanced architectures. Now let's go through an example scenario. Let's imagine a retail company imports daily sales. They use the incremental refresh policy to update only the last 14 days each night and a smaller hourly refresh during business hours for the previous day's rolling window. The gateway connects to their on-premise POS database and the admin monitors refresh failures via the refresh history and capacity metrics. The design reduces load, improves freshness, and keeps costs predictable. Now let's dive into the part D, which is about sharing reports and dashboards with teams and people. So publishing is one thing, sharing is where insights drive action. Power BI provides multiple sharing patterns. Choose the pattern that matches your audience, governance, and licensing. Now let's go through the sharing options overview. Workspace access. You can grant user roles inside a workspace based on viewer, contributor, or member, or even admin. Use this for collaboration where users may edit or test the content. Next is publish an app. Best for distributing polished, read-only content to many users in one go. Apps are versioned and provide a stable entry point for consumers. Next is the share option. The share button lets you send a direct link to the specific people or groups. This respects dataset RLS and requires recipients to have appropriate license or access. Use this for ad hoc distribution. Followed by that, we have embed in Teams. Add reports as tabs inside Teams, channels, or chats, so users access analytics where they work. Embedding in Teams keeps collaboration seamless and can include comment and chat integrations. Next, we have secured embed or public embed or publish to web options. Secure embed option is for internal portals with authentication. Publish to web produces an anonymous public link. Use with extreme caution. It is used rarely for internal data only. Secure embed respects permissions with row-level security. Public embed is not. Now, let's dive into embedding in Microsoft Teams. So let's go through the practical flow. To add a report to a team channel, open the channel, click the plus icon, select the Power BI tab, then pick the Power BI report or dashboard you want to embed. The Teams tab gives users direct access to the report without leaving Teams, and you can pin it for quick visibility. This is a strong pattern for operational teams that already use Teams for daily communications. Next comes the row-level security and sharing. When sharing, ensure RLS is configured if recipient should only view a subset of the data. RLS is defined on the dataset and enforced by the service. It travels with the dataset and applies to all sharing mechanisms, including apps and team tabs. Use RLS carefully and test via view as a rule to confirm behavior before wide distribution. Now, let's go through external sharing and B2B. You can share with external users via Azure AD B2B. Tenant admin must enable external guest settings. For customer-facing scenarios, consider Power BI Embedded, which is app owns data, to avoid provisioning licenses for external users. Always follow your organization's tenant settings policies and consult compliance teams for external data sharing. Now, let's go through best practices when sharing. Use apps for broad audiences, package reports and dashboards into apps with controlled permissions, and publish app updates rather than republishing workspace content. Next is document expectations. Every app report should include data refresh schedule, owner contacts, and intended use. Protect sensitive data. Use sensitivity labels and tenant settings to restrict export printing or sharing where needed. Training and adoption is the next step. Create short walkthroughs inside Teams or pin documents so business users know how to navigate reports and filter correctly. Next comes an example. The HR analytics team publishes a headcount and attrition app. They deploy it to the HR app workspace, run RLS so managers see only their teams, and add the app as a tab in each manager's team channel with a pinned frequently asked questions tab. Managers receive an email when the app updates, and the HR team monitors usage metrics to iterate. Now, let's dive into the part E, where we will discuss about embedding reports, approaches, authentication, and permissions. Now, let's go into part E, where we have embedding reports, approaches, authentication, and permissions. Embedding is where Power BI becomes a part of product experience and workflows. There are two main embedding models, and each has different security and licensing implications. Embedding for your organization where users own the data. This is internal embedding where the end user needs to authenticate with their Power BI credentials. The report respects their permissions and row-level security. Now, let's go through some use cases. Intranet portals and internal web apps where only authenticated employees access the analytics. Authentication typically uses OAuth with delegated permissions only. Now let's go for another one, which is embed for your customers, where the app owns the data. This is an external model where the application authenticates using a service principal or master account and renders reports to the end users who don't have Power BI accounts. This is the recommended approach for ISVs and SaaS apps. It requires Azure setup, which is Power BI embedded capacity, and careful security design. Use the REST APIs with a service principal to acquire embedded tokens for the client app. Next comes authentication options for embedding. User authentication, which is delegated. Users sign in with Azure AD. The embed respects their direct permissions. Use this when users already have Power BI licenses. Next is service principal, where we have only the app. It is recommended for app owns data scenarios. You can create an Entra app, grant Power BI API permissions, and use the client ID plus secret to authenticate server to server. Generate embed tokens with the REST API and pass them to the front end. This approach lets you control which reports a user can see without giving them the Power BI account. Now, let's go through embedding methods and security trade-offs. So the first one, secure embed code or iframe. It is good for internal portals. It respects Power BI permission, but still requires users to sign in. It's the simplest path when you have basic embedding needs and internal authentication. Now, the next one is Power BI Embedded, which is dealing with Azure. It provides an Azure-based hosting capacity for external embedding with higher scale and performance guarantees. You manage capacity, scale units, and the costs at Azure level. This is the correct choice for commercial products. Now let's go through publish to web. This one creates a public anonymous embedded URL. You need to avoid this for internal or sensitive data. It is effectively public. Use only for fully public or non-sensitive visuals. Next is about permissions and row-level security in embedding. When using user owns data, RLS continues to work as usual. Each user sees the data according to their role. When app owns data, you often need to implement row-level filters at the embed token generation step to ensure each customer or tenant sees only their data. Use the REST API's embedded token generation and specify effective identities or RLS filters to restrict data. Test extensively. Now, let's go through practical architecture for ISV where app owns the data. Provision Power BI embedded capacity in Azure. Create a service principal in Microsoft Entra and grant it to the required Power BI API permissions. Use your backend server to call the Power BI REST API to authenticate, create or refresh datasets as needed, and generate embed tokens. Securely hand the embed token to the client browser for rendering via Power BI JavaScript software development kit. Rotate secrets and monitor usage and errors. Embedding example, secure internal portal. A company builds an internal vendor portal where each vendor can log in and view their performance dashboards. They choose secure embed with user authentication. Vendors authenticate via SSO and the portal uses an iframe or direct embed to render Power BI reports. RLS ensures each vendor sees only their data. The portal does not store embed tokens for long term. Now let's go through developer and security checklists for embedding. Use TLS and secure cookies. Rotate service principal secrets for every 90 days or use certificates. Log all token requests and embed activity for audit. Use throttling, retry patterns, and circuit breakers for REST API calls. Monitor capacity usage to prevent throttling or excessive cost. Embedding turns analytics into part of workflows and products. Choosing the right embedding model is a balance between user experience, cost, and security. And with that, we dive into part F, which is about permissions, governance, and tenant settings. Security and governance are the core. Power BI tenant settings and workspace roles provide guardrails. Tenant-level governance. Administrators can set tenant-wide policies such as allowing or blocking external sharing, enabling or disabling publish to web, managing who can create workspaces or use premium features, controlling which users can export data or reshare data reports, controlling which users can export data or reshare the reports. Work with the Office 365, Entra AD, and Power BI admin teams to create sensible defaults that align with corporate policy. Data sensitivity and protection is our next point. You can use Microsoft Purview sensitivity labels if available to tag datasets and reports. Labels travel with content and control export, print, or copy behavior. Pair sensitivity labels with tenant export controls to limit data exfiltration. For regulated data, consult data protection officers and legal counsel. Now, let's go through permission best practices. Let's start with least privilege. Only give the permissions that users need. Group-based access is the next one. Use Azure AD groups to manage workspace membership rather than assigning permissions to individuals. Next is service accounts. Use dedicated service accounts for schedule refreshes and APIs, not personal accounts. After that, we have audit and monitoring. Enable audit logs and review sharing patterns. Watch for unusual exports or public links. Now, let's discuss governance example. Finance publishes financial dashboard but restricts export and sharing. The tenant disables publish to web globally, and the finance workspace requires two admins and enforces certified datasets only. This ensures sensitive financial data is controlled and traceable. Now, let's have a quick closing summary and practical action plan. Let's summarize the core takeaways. Publishing moves your .bbix into Power BI service as a report, dataset, and query recipe. Choose the right workspace and connection mode before publishing. Workspaces are the primary collaboration and governance container. So use roles and developer to quality analyst to production patterns to manage content lifecycle. Dataset refreshes is critical for data freshness. Use gateways for on-premise resources, incremental refresh for large tables, and monitor refresh history for failures. Sharing should be intentional. Apps for broad audiences, workspace access for collaborators and team, embedding for everyday workflows, respect RLS and security. Embedding has two main models: user owns data, which is internal, and app owns data, which is external. Choose according to the licensing and business needs, and secure via service principles and embed tokens for app owns data scenarios. So now let's discuss an action plan for learners. Publish a sample.pbix to a developer workspace, inspect the dataset, refresh it manually, and configure scheduled refresh options. Create a small workspace with member and viewer roles, publish an app, and install the app as an user. Now you can add a Power BI tab to the Teams channel and embed the report. Test the filter, add comments. If you have a developer background, you can generate an embed token using a service principal for test app. Work with your tenant admin to understand your organization's tenant settings and refresh quotas. Recommended reading and resources: publishing and uploading Microsoft Docs, Workspace, and role guidance, Power BI Docs on new workspaces, schedule and manage dataset refresh, Power BI refresh docs, embed in Teams documentation and embedding Power BI and Microsoft Teams, embedding APIs and service principal guidance, Power BI REST API docs. That wraps Module 9. In the next module, we will cover report optimization, large model strategy, and best practices for performance tuning in Power BI. Now we enter Module 9, which is about Power BI tips, tricks, and common mistakes. So in this module, we are moving beyond the basics and intermediate skills. We are focusing on the advanced habits that make Power BI users truly efficient, reliable, and professional. If you think of everything we have covered so far: data loading, Power Query transformations, modeling, DAX, visualizations, and publishing, these are the building blocks. Module 10 is where we refine these blocks into a professional analytics system that is fast, scalable, consistent, accurate, easy to maintain, easy to understand. This module is important because most Power BI performance problems, business confusion, or dashboard failures don't come from Power BI itself. They come from avoidable mistakes such as poor modeling, incorrect DAX, unnecessary visuals, or inefficient refresh processes. So in today's session, we will go deep into performance optimization tips, avoiding common DAX pitfalls, best practices for dashboard design, using Q&A visuals, and smart narratives for storytelling. By the end, you will have a complete mental toolkit that will help you build dashboards like an enterprise level BI engineer, not just a casual report creator. So let's begin. The first section will be about performance optimization tips. Performance optimization is one of the most underrated skills in Power BI. Many users think performance issues only come from large datasets, but that's not entirely true. A poorly designed model with even moderate data can cause slow refresh, visual loading delays, memory overflows, frozen interactions, slow DAX measures, and many more. So let's go step by step through the most important optimization techniques. So the first one: reduce the model size. A lighter model loads faster, refreshes faster, and easier to maintain. So here comes the tip one: remove unnecessary columns. Many datasets come with 100 plus columns, but typically only 20 to 30 are actually needed for reporting. So if you want to go through some examples of columns that you can remove, so some of the columns that you can remove are the columns which are only used for intermediate calculations. Audit fields like created by, updated by, columns with extremely high cardinality where you only need aggregates, pre-text comments, descriptions, or log columns that duplicate information like multiple versions of dates. Every unnecessary column increases refresh time. Removing even 10 such unused columns can significantly reduce model weight. Now, the next step: reduce data cardinality. Cardinality means the number of unique values in a column. High cardinality is equal to slow performance. For example, a column with 1 million unique customer IDs, a date time column with timestamps for every second, a text field where every value is unique. All this creates pressure on Vertipack engine. Now, let's go through the optimization techniques. You can convert the date time data type, date minutes, seconds that are not needed. Reduce precision of numerical values. Group or bin data where possible. For example, if you have multiple ages, then you can segregate them into a group from minimum age, that is 18 to 30, 30 to 60, and beyond. So you have three groups here. Avoid using GUIDs in visuals, avoid using unique IDs in slicers. Reducing cardinality improves compression and speeds up calculations. Now, the third tip, disable auto date time. Power BI has a feature called auto date time, which automatically generates hidden date tables. For small projects, it's fine, but professional BI models, it should always be turned off. Why, you ask? Because it silently adds extra tables, which increases model size, relationship overhead, memory usage. Instead, always create your own date table marked as date table. Now, the fourth tip, use star schema for better performance. The most powerful optimization is correct modeling. A star schema ensures cleaner relationships, faster DAX evaluation, smaller models, predictable performance, and a lot more. In star schema, fact tables store numeric transactional data. Dimension tables store categories like product, region, or customer data. Many performance issues occur because users build flat tables or snowflake models with long chain. So, you need to consider one rule of thumb. One fact table connected to multiple dimensions is always faster than multiple flat tables. Now, the fifth tip, limit the number of visuals per page. Every visual is a query. Having too many visuals slows page Having too many visuals slows page load, increases memory usage, reduces responsiveness, increases dataset refresh time for direct query models. Recommended limits. Standard reports 6 to 12 visuals per page, executive dashboards 4 to 8 visuals, highly interactive pages 1 to 3 visuals plus slicers. If you need more, create drill down or drill through pages, bookmarks, or tooltips instead. Now, the sixth tip, avoid using too many slicers. Slicers may look simple, but they're expensive. Each slicer refreshes the entire page every time the selection changes. Replace slicers with drop downs, filter panes, drill through, filter report level, filters, buttons, or bookmark navigations. Only use slicers when user genuinely needs to make frequent selections. Now we have the tip number 7. Use measure tables. Professional Power BI reports separate measures from data tables. A measure table organizes calculations, improves model clarity, reduces accidental misuse of columns, enhances DAX performance because measures are calculated on demand. Never store measures inside fact tables. Now we have our next tip, which is about optimizing DAX. We will cover DAX mistakes in the next section, but performance optimization is deeply tied to DAX efficiency. A poorly written DAX formula can slow the entire model. For example, using SumX on large tables when sum is enough. Second example is using calculate unnecessarily. After that, we have using filter on entire tables instead of just few columns. Overusing all except, and remove filters is also one of the good examples. Great performance comes from minimal efficient formulas. Now, the ninth tip, avoid using many calculated columns. Calculated columns increase the model size, and these are computed at refresh time and are often found to be slow. These are usually replaceable by measures. You can reduce performance for composite models as well. Only choose to use the calculated columns if the logic cannot be handled by measures or a simple Power Query. 90% of calculated columns actually belong to the Power Query, not DAX. Now, the 10th tip, use aggregation tables for large models. For very large datasets, millions to billions of rows, Power BI supports aggregation tables. Aggregated tables pre-calculate high-level summaries, reduce calculations, improve direct query performance, make dashboards more responsive. This is commonly used in finance, manufacturing, and IoT analytics. Now let's have a short recap of the section 1. In summary, performance optimization is not one thing. It's a combination of disciplined habits. Following these practices ensures smooth dashboards, reliable refresh cycles, and scalable models. Now, let's go to the section 2 of module 10, which is about avoiding common DAX pitfalls. This is one of the most important parts of today's module. Knowing DAX is one thing. Knowing how to avoid DAX mistakes is what makes you a true BI professional. So, the DAX issues almost always lead to incorrect numbers, confusing visuals, wrong totals, slow performance, incorrect filters, and a lot more. So, let's walk through the biggest pitfalls and how to avoid them. Now, the first one is misunderstanding row context versus filter context. This is the number one mistakes new users always make. Row context applies to each row in a table. Filter context, on the other hand, comes from slicers, filters, or calculate options. You must always remember a calculated column has row context, a measure does not. This is why formulas behave differently. Now let's go through some examples. Sum of sales of revenue. In a calculated column, this gives the same value on every row. In a measure, it changes based on visuals and filters. Misunderstanding this creates endless confusion. Now the second one, overusing calculated columns instead of measures. Many beginners use calculated columns for everything because they behave more like Excel formulas. This leads to bloated models, slow refresh rates, memory inefficiency, incorrect aggregations, and a lot more. Always ask, can this be done with a measure? If yes, then always prefer a measure. Now, let's go to the third one, using calculate even when not needed. Calculate is powerful, but many people use it unnecessarily. For example, calculate sum of sales of revenue. This is pointless because sum already respects filter context. Only use calculate when you want to change the filter context. Followed by that, we have using filter on the entire table. Example, let's consider a mistake where you added calculate function of sum of sales revenue and then you added a filter for sales region, which is equals to east. Instead of using this, you can simply write calculation method inside sum of sales revenue and sales region is equals to east. Now this filter adds row context, slow, and column filters are faster. Now let's go through the fifth one, misusing all method, removing filters and all except. These functions remove filters, but many users apply them blindly. Now let's consider an example mistake. So here total revenue is equals to calculate sum of sales revenue and all sales. This removes all filters, even date filters. This particular approach removes all filters, even date filters. Always think which filters should remain, which filters should reset. If you want only a specific filter to be removed, be precise. For example, all sales of region, not the whole table. Now, let's go through the sixth mistake. Improper time intelligence calculations. DAX time intelligence requires a continuous date table, no gaps, a mark date table. If your date table is incorrect, functions like same period last year, total year to year, which is total YTD for short, date add, these functions will return incorrect values. Now let's go through the seventh mistake. Using earlier instead of variables. Earlier is an outdated and confusing function. Instead, use variables. An example is VAR current value equals to sales revenue, return current value, previous value, etc. Variables improve readability, improve performance, prevent repeated calculations, reduce mistakes, and a lot more. Now, let's go through the eighth one, not using divide function. Divide handles division by 0 gracefully. Now, let's consider a bad usage. For example, sales of revenue divided by sales of quantity. So, for a better approach, you can use divide method, sales of revenue, comma, sales of quantity, comma, 0. Always use divide method to avoid errors. Now let's go through the ninth one, ignoring DAX query plans. Power BI has tools like DAX Studio, Vertipack Analyzer, Performance Analyzer, and a lot more. These reveal expensive measures, slow queries, heavy tables, and a lot more. Professional BI engineers always test performance before deploying large-scale dashboards. Now, let's have a quick recap of the section 2. DAX mistakes usually come from misunderstanding context. Once you master context, your formulas become faster, cleaner, and more reliable. Now let's dive into the section 3, which is about best practices for dashboard design. In this section, we will shift from performance to design, the user experience portion of the Power BI. A dashboard is only as good as its design. Users should be able to look at your dashboard and instantly understand. The user should be able to understand what's the story, the trend, the insights, the action plan, and a lot more just by looking at your data dashboard. Now, let's look at some of the best practices that professional always follows. Now, the first one, apply the 5-second rule. A well-designed dashboard should make sense within 5 seconds. If the user needs to scroll, zoom, decode, guess, or mentally calculate, then the dashboard has already failed. Dashboards must deliver insights quickly and cleanly. Now, the second one is avoid chart overload. Not all charts are equal. Avoid some charts, for example, 3D charts, donut charts with more than 4 circles, pie charts comparing similar values, clustered bar charts with too many categories, maps with too many points, etc. Instead, you can prefer bar charts, line charts, matrices KPI cards, scatter plots for correlation, decomposition tree for root cause analysis, waterfall for financial analysis, and similarly, we have other options as well. Simplicity always wins. Now, let's go with the third one, maintain visual hierarchy. Visual hierarchy means guiding the viewer's eyes. Use large fonts for key KPIs, bold colors for important numbers, consistent placements, white spaces, grouping and alignment, and these things are to be considered. Use large fonts for key KPIs, bold colors for important numbers, consistent placement, white space, grouping, and alignment. A clean dashboard reduces cognitive load. Now, the fourth one, use consistent formatting. Consistency builds trust. Use the same number formats, colors, decimal points or decimal places, date formats, naming conventions, and etc. For example, if revenue is in millions, keep it in millions everywhere. Now, the fifth point, keep colors meaningful. Avoid random colors. Use consistent meanings. Let's consider green for good, red for bad, blue for neutral, and yellow for a warning. Avoid too many colors. Try to keep it within a limit of 3 to 5. Now, let's go with the sixth point. Use tooltips for depth, not overcrowding. Tooltips help keep dashboards clean. Instead of adding extra visuals, add details to tooltips. Use report page tooltips. Provide drill through options. This keeps the main dashboard. Provide drill through options. This keeps the main dashboard minimal but yet powerful. Now comes the seventh point. Use bookmarks for navigation. Bookmarks can create guided stories, step-by-step narratives, collapsible filter panels, interactive instructions, and a lot more. Bookmarks often elevate dashboards into apps. Now the eighth one, hide the complexity from the user. Always design dashboards so that actions are intuitive, slices are minimal, visuals are self-explanatory, navigation is almost effortless. The goal is to deliver insights, not complexity. Now we dive into the section 4, which is about Q&As, visuals, and smart narratives. This section focuses on Power BI's AI-driven storytelling. This section focuses on Power BI's AI-driven storytelling tools. These tools help users ask questions and generate insights automatically. Now the first one, Q&A visual. The Q&A visual allows users to type natural language questions like what are the total sales by region in 2024? What are the top 10 products by profit, monthly revenue trend for a specified country, etc. Now, Power BI interprets these questions and generates the chart automatically. Now, let's go through the best practices. Use proper field names, create synonyms, build a glossary, train the Q&A engine, and use the suggested questions only. This makes dashboards conversational. Now, let's move into the second one, which is about smart narratives. Smart narratives automatically summarize the trends, outliners, key insights, differences, and anomalies. It generates text that explains what the charts show. For example, revenue is increased by 12% in Q4 and it is driven by strong performance in the electronics segment. This adds storytelling to dashboards. Now let's go to the third point, narrative customization. You can customize smart narratives by adding your own text, highlighting key metrics, creating dynamic summaries, linking measures. This ensures that executives can read insights in plain language. Now, let's go to the next one, which is storytelling with Power BI. A great dashboard isn't just a collection of visuals, it tells a story. A story should answer what happened, why did it happen, why is it important, what should you do next. Smart narratives plus Q&A plus bookmarks plus drill through create powerful storytelling experiences. Now, the conclusion to this particular module. Module 10 wraps up all the advanced principles needed to build enterprise level Power BI dashboards. We covered optimization techniques for high performance, DAX mistakes and how to avoid them, best design practices, AI-driven storytelling, and a lot more. These skills will significantly improve the speed, clarity, and impact of your dashboard. In the next module, we will conclude the course with advanced deployment and governance best practices. So welcome to the final module of this Power BI full course for beginners. In this chapter, we are going to do three major things. Recap everything you have learned across the 11 chapter journey, provide most reliable resources for going advanced, and third one, give you a complete roadmap to crack the PL300 Power BI Data Analyst certification. So by the end of this module, you'll have clarity on how data flows through Power BI, how each module contributed to building your Power BI skill set, what you should practice for next, and exactly how to prepare for the industry recognized certification. So let's begin with the detailed recap. Chapter-wise summary recap starts now. Chapter 1 recap, Introduction to Power BI. In this chapter, we laid the foundation for your entire Power BI journey. We started by understanding what Power BI actually is, not just as a tool, but as a complete ecosystem for business intelligence. We discussed the importance in 2026 and beyond, especially as companies shift from manual reporting to automated data-driven cultures. You learned that Power BI is composed of Power BI Desktop, where you build reports, and Power BI Service, where you publish and share the reports, Power BI Mobile, where the leaders consume the insights on the go. You also explore the real-world use cases of Power BI, marketing team analyzing campaign performance, sales teams forecasting revenue pipelines, finance teams automating MIS and dashboards, HR teams monitoring employee performance and hiring metrics, operation teams optimizing supply chains and logistics. Finally, you installed and set up Power BI Desktop, preparing your environment for the rest of the course. Now we dive into the Chapter 2 recap. You have understood Power BI workflow here. This chapter explains Power BI's end-to-end workflow, which mirrors how organizations actually use the BI. It all starts from data, next to transform, next to model, then visualize, then publish and share, and lastly automate. We broke down each layer. Data sources like Excel, CSV, SQL Server, cloud services, transformations using Power Query, where we did the cleaning operations, modeling, where we established relationships using star schema, visualizations, where we created interactive and insightful charts. Then comes the publishing, where we uploaded the dashboard to Power BI Service, sharing and governance using workspaces, permission, and apps. By understanding this workflow early on, you were better prepared for the practical steps that followed. Now we dive into the Chapter 3's recap, which is about connecting to data sources. Chapter 3 was your introduction to real data ingestion. You learned how to import Excel and CSV files, pull data from the web, connect live to SQL Server, understand the difference between import mode and direct query, understand dual mode and when to use each. We discussed real-life scenarios like import mode for faster dashboards, direct query for real-time analytics, live connections for enterprise semantic models, etc. We also learned how businesses often deal with multiple systems, ERPs, CRMs, marketing systems, and how Power BI acts as a central reporting layer. Now with that, we come into the Chapter 4 recap, which is about data transformation with Power Query. This was the most important modules in the course because 80% of the data issues happen before the modeling stage. In Chapter 4, we explored the following: Power Query interface, applied steps pane, query settings, data types, transformation, and add column ribbons. We also went through cleaning operations such as removing null spaces, null values, handling errors or replacing errors, filtering unnecessary rows, standardizing data formats, and a lot more. We also did some transformations where we merged queries, join operations, appending tables, splitting columns into multiple fields, pivot or unpivot operations for reshaping data, etc. We also covered why Power Query's M language is powerful for automation. Once you build a cleaning process, Power BI can rerun the same steps every time a new data arrives. Now, with that, we dive into Chapter 5's recap, which is about data modeling. Chapter 5 introduced to the heart of Power BI, the data model. You learned relationships, primary keys and foreign keys, one-to-many versus many-to-one cross-filter directions, schemas, and a lot more. We also dealt with schemas such as star schema for the best practice, snowflake schema and when to avoid it, lookup tables, how dimension tables helps you slice data, why fact tables contain measurable values, why hiding unnecessary columns improves the model, and finally, you learn how the model affects performance, DAX calculations, reports interactivity, and long-term scalability. This chapter gave you the structural backbone of your reports. And now we dive into Chapter 6 recap, which is about Introduction to DAX. This chapter was your first deep dive into data analysis expressions, the formula language behind the Power BI. You learned calculated columns versus measures. Columns are row by row measures that are aggregated at query time. Measures are recommended for calculations involving filters. We also went through some common DAX functions such as sum, calculate, filter, all, distinct, count, divide, and a lot more. We also went through time intelligence functions like year to date, month to date, same period last year, date add, etc. We discussed practical business scenarios as well. For example, calculating year-on-year growth, computing conversion rates, creating running totals, generating customer cohorts, and a lot more. This chapter gave you the analytical depth required to turn raw data into insights. Now, we also discussed the recap of Chapter 7, which is about visualizations in Power BI. This was your storytelling chapter. You learned core visuals, bar and column charts, line and area charts, maps, pie charts and donut charts, KPIs and cards, and a lot more. We also learned formatting skills like removing clutter, customizing colors and labels using themes, adding drill throughs and tooltips, and we also implemented filters, slicers, visual level filters, page level filters, report level filters, and a lot more. You also learned how professionals make dashboards intuitive, minimalistic, insight focused. Your dashboard started to look polished and business ready. Now, with that, we dive into the recap of Chapter 8, and this was about Time Sales Dashboard Project. This chapter was the hands-on real-world project for you. You worked with a sample dataset and performed data cleaning, data modeling, measure creation, visualization building, bookmarks, and UI design. You created sales KPIs, trend charts, region-wise sales performance, category-level insights, and a lot more. You designed an executive view, an interactive drill down, a modern UI layout. By the end, you had built a complete industry-grade sales dashboard. Now, this brings us to Chapter 9 recap, which is about Power BI service, publishing, and sharing. This was your introduction to Power BI and the cloud. You learned how to publish reports, how to create and manage workspaces, how to refresh datasets manually or automatically, how to share dashboards securely, how row-level security ensures data protection. You also explored embedding and permissions, which are essential for enterprise rollout. Now, this brings to the Chapter 10 recap, which was majorly about tips, tricks, and common mistakes. In this chapter, you gained production-level experience, performance optimization, avoiding large cardinality columns using star schemas, minimalizing visuals, disabling unnecessary interactions, and a lot more. We also learned about DAX Pitfalls, misunderstanding row context versus filter context, using calculated columns when measures are better,
relying too heavily on iterators, dashboard designs, best practices, consistent colors, proper visual hierarchy, fewer slicers, meaningful titles and tooltips, and a lot more. We also dealt with AI features like Q&A visuals, smart narratives, text-based summaries for executives, etc. This chapter helped you transition from a beginner to a professional level Power BI developer. And now you're ready for Power BI certification and professional growth. So now we will go through the section 2 about this particular model, which is based on the resource guide. So the first resource that you will be going through is the Microsoft Official Learning Resource. The Microsoft Learn Power BI collection from beginner to intermediate to advanced topics. This particular guide covers data modeling, DAX fundamentals, Power Query, Power BI service, row-level security, deployment pipelines, and a lot more. You can search this particular resource online. You can just type Microsoft Learn Power BI and you'll have the resource. The second one is Power BI official documentation, the most updated resource for Power BI visuals, DAX functions, data gateway configuration, Microsoft Fabric, and Enterprise BI. You can search online and you can type Power BI documentation from Microsoft and you'll get the resource. The third resource is Microsoft Power BI blog. This is perfect for staying updated on monthly feature releases, new visuals, performance improvements, and industry announcements. Now comes the resource number 4, which is about Microsoft Fabric plus Power BI integration guides. This helps you understand lakehouses, warehouses, one lake, AI-powered BI workflows, etc. Now, the last one, which is the Simplilearn learning resources. You can go through Simplilearn's Power BI tutorial, which is free. And to get this, you can search online. You can type down Simplilearn Power BI tutorial, and our videos break down complex topics in beginner-friendly formats. You can also go through Simplilearn's Power BI full course, which is available for free on YouTube. This particular resource is useful for revision, especially for tax basics, data modeling, and dashboard building. Apart from this, you have Power BI certification material by Simplilearn. To get this, you can go to a browser and search Simplilearn PL300 and you will have access to structured content mapped to exam topics. Now, let's go through the next section of this particular module. Which is about PL300 certification roadmap, a detailed step-by-step industry-recognized preparation blueprint. So firstly, what exactly is PL300? PL300 or Microsoft Power BI Data Analyst is one of the most in-demand BI certification in 2026. It validates your skills in data preparation, data modeling, data visualization, tax analysis deployment, and sharing. The exam focuses heavily on practical business-oriented BI scenarios. PL300 skills measure the first one, prepare the data 15 to 20%, get data from different sources, clean, profile, and transform data using Power Query. The second one is model the data, 30 to 35% weightage stays here. You need to design star schemas, create relationships, optimize the model, implement row-level security. The third stage is visualize and analyze the data. 25 to 30% weight stays here. So you need to build dashboards, create measures, add advanced analytics visuals, apply filters and interactions. Then comes the fourth stage where you deploy and maintain the assets. 20 to 25% weightage stays here. You need to publish report, set up workspaces, configure refreshes, manage permissions. You've already learned all these topics throughout this course. Now, let's go through the detailed study roadmap for 4 to 6 weeks. Let's start with the week 1. Power Query plus data preparation. Focus areas: import modes, merging, appending, pivot and unpivot, working with data types, removing errors. So you need to practice, and the practice is take 3 to 4 messy datasets from Kaggle. So you need to practice for this. The practice might include taking 3 to 4 messy datasets from Kaggle or public data, clean them entirely using Power Query. The goal is to build muscle memory in transformation logic. Now comes the week 2, data modeling, the most important week. The focus areas: star schema relationships, cardinality lookup tables, model optimization. The practice: build at least 3 models from scratch, identify fact versus dimension tables, create a semantic model report. The goal is you should be able to design a model on paper with confidence. Now comes the week 3, DAX mastery. The focus areas: row context versus filter context, calculate all except iterators, sum x, and time intelligence. You need to practice, write at least 20 to 30 measures, calculate year to date, year on year, month on month, create KPIs, etc. The goal, you must be comfortable with calculate and context transitions. Now comes the big four: visualizations plus Power BI service. The focus areas are building dashboards, drill through, bookmarks, tooltips, publishing reports, and workspace management. You also need to take care of dataset refresh and row level security. For this, you need to practice. You need to practice creating a polished report, publish it, set up schedule refresh, add row level security. The goal, you should be able to present a full report end to end. Now comes the week number 5, revision week. Plus, you can also have some mock tests as well. So, you need to use Microsoft's Learn practice questions, Simplilearn's practice questions, Microsoft practice assessments. The focus areas here are rereading DAX functions, reviewing modeling diagrams, practicing service-related flows. The goal, achieve 80% in mock tests. Now, let's go through some recommended learning approach. You can use Power BI Desktop daily. Try building dashboards from any dataset you see. Practice explaining your report. This helps for interviews. Follow Microsoft blogs monthly for new features. And now the wrap up and motivation you were looking for. You've completed one of the most comprehensive beginner to advanced Power BI journeys. You now understand data ingestion, data transformation, data modeling, data analytics, dashboard storytelling, cloud publishing, performance tuning, and a lot more. And now with the module 11, you know where to go from here. The best official resources, the certification roadmap, and the job-ready skills that you must practice. Whether you're stepping into BI, upgrading your analytics career, or preparing for PL 300, you now have the foundation and clarity to move forward with confidence.
Now, let's get started by how to install Power BI in Windows operating system. To install Power BI, go to Google and search for Power BI Desktop Download. Now, click on the first link and then you will be redirected to the official webpage of Microsoft Power BI. Here, you have to scroll a little towards bottom and select your language, which is English, and then click on Download. This will give you two options. So based on your processor, select one. My system is 64-bit, so I'll be selecting this one. Now download. The file will be 558 MB, so it might take a little time. Now you can see your Microsoft Power BI is getting downloaded. So if we go into the download section, you can clearly see it. So here it is getting downloaded. It might take a little time. Now the file has been downloaded. Just run the file and you can directly go to next, since the default language is English. And in case if you want to select a particular language, you can go to the select language option and select your particular language you're searching for. It might take a while. There you go. So the installation process has been started. Now you can click on next. And now you can read all the terms and agreements and click on accept. You can change the location if you want, but I'll be keeping it as default. Again, if you want to create a shortcut, you can on desktop. I'll keep it as it is. Now install. It might take a while. So Power BI has got successfully installed. You can see the desktop icon there. Double click on it and you can start Power BI. So firstly, it is open source. If you want to have a licensed version of it, just get the license or buy now option. And for now, let's use the open source version. So this is the Power BI window and those are the charts. And these are the data connections if you want to get connected to your data sources. You can also have shortcuts to that.
How to connect different data sources with Power BI. So in this session today, we will see how can you connect different type of data types, data sets like Excel, PDF, CSV, etc. to import in Power BI for your data visualization needs. So what's in it for us today? We will be learning how to connect to data, different data types, data files like Excel, PDF, then what are the different data importing modes, and then I will also show you practically different sets, how to import them in Power BI and use it for your visualization purpose. Now what are the steps to connect to data? So now we will go directly into Power BI and try to import one by one few most commonly and popularly used data sets which are most commonly used in a day-to-day activity. Rest, of course, there are Power BI supports n number of data sources, but we will do something practical on the most popular ones. So let's open our Power BI. Now this is my Power BI, and first I want to show you that how can I import data directly from a web page and import the data. Now it is asking for a URL in order to import data. So what I have done is I have created a Google Excel sheet with simple data with rows and columns, and what I have done is I have shared this sheet as publish to web. Okay, so you just need to say publish to the web, the link as web page, and say done. It's automatically published, and say link. So copy the link which you have published on the web, copy this link, and then go back to your Tableau, paste that link over here and click OK. Now Power BI will try to establish a connection with this Google Doc sheet because it's published on the web. You need to wait for a while it is reading. Okay, now it has read one of the HTML tables, so I'll select this one. Now you can see it is showing me a preview of the table which is there on my Google sheet, right? It has 11 rows, so it has all showed all the 11 rows. So now I can go and transform this data because I can see my headers are there starting from the second row. So there is an opportunity for me to transform the data. So I'll go and transform it so that it looks clean. Okay, so first is I need to remove the first row, which is the null row. Remove the top rows. Okay, and then I need to use the first row now as a header. So you just click this option, use first row as headers. That's it. So now if you see my row ID, order date, ship date, all my data is now ready. So I can say close and apply. Click apply changes. Now this is an example of web data import. You can go and preview your data. Right now, the biggest advantage of this data connection is that it's a live data. So for example, I insert another row. Let me change the order ID. I've changed some basic stuff, and it's auto saved. Control S. Now I'll go to my Tableau and I'll refresh. Now you can see as I refreshed my Power Query Editor, I clicked refresh all and I got my new row which is there in the live data. I got that fetched from my okay, I got that row, the row ID number 12. So I have to say close and apply. Now you can see the new row, the row number 12 is now available in my new data set, in the data set, because it's a live connection. It's a live connection with the web-based Google Sheet. Okay, so this is one important way in which you can import data. Now let's try to import data from a text file. Now I have already prepared a text file called subcategories.txt. Now let me just open it in a notepad. Now it's a very plain simple file, tab separated, file in which you have product subcategory ID, subcategory name, and product category key. So basically to which product category this particular subproduct belongs to, right? So what I'm going to do is I'm going to go back to my get data option and I'm going to select text/CSV option, and I'm going to select option mod product subcategories.txt. Okay, so now Power BI has identified that it's a tab delimited file, it has recognized the headers, etc., right? And I can now directly load this file. Okay, so now once the data is imported in Power BI, it is like irrelevant to me. It's a composite data import I am doing, right? So in my presentation, when I am talking about importing data, there are different importing modes, right? Data import can happen through different ways. Okay, one is direct query mode, in which I create a live connection to the database, which I'll also show you using MySQL and MS SQL Server. And also you can do a composite mode in which you can have data imported from Excel, plus you can have direct query modes. So you can have multiple modes to connect and create a composite data model, and that's what we are doing right now in our practical. So what we are doing over here is, one, we have imported data from the web. Second, we have imported data from a text table. Now, after doing text, now our next task is to import from CSV. Let's try another one. So now I have imported product subcategory. Now I'll import a CSV file. So again, I'll choose the option text/CSV. And now in this CSV file, let me open this CSV file and show you what is it. So this is a list of all my products, product key, product subcategory key, products, stock keeping unit, etc. A simple CSV file, and I'm going to import that. Okay, so now it is identified the delimiter is comma rather than a tab, and it has already recognized the headers correctly, so I'll load it. Okay, so now my products are there, product subcategories are there. For product categories, now what I have done is I have created a Excel mode now. So now Excel I'm using to import my product category. So now I have to click on the option of import data from Excel, and I'll say product categories. Select the sheet, load, and now so my products, product categories, product subcategories, though with different data storage types, but still now the data is imported into Power BI. It is a composite data model. Now another very important data type which you can import is the PDF also, right? So what I have done is I have created a PDF called customers. My customers data is lying in a PDF. So what I have done is I have created a PDF which has data for some columns are there, like, you know, customer key, prefix, first name, last name, birth date, marital status, gender, email address, annual income, total children, etc., etc. So this is the data set which I have created in PDF. So what I'm going to do is I'm going to select PDF now and import customers.pdf, and see, it has recognized my table on page 1, which I'm going to load. Okay, you can rename this as PDF table. So this basically, these are the different type of data types we have imported: PDF, Excel, text, CSV, and web page. Now let's take a look at another interesting data set which we want to import, is the MySQL Server data set. So what I have done is I've already installed MySQL server on my local instance, and there's already a schema of SQLite tutorial over there, and I have certain tables already prepared over there like department, employee, etc. So my goal is now to import this data or create a live connection with this data set. Now in order to import my SQL database connection in Power BI, you need to first download a connector, MySQL Power BI connector. So you need to go to this link and then click on download and install the MySQL connector. Based on the operating system you have, you click on download and install it. After you have done this, go back to Power BI and then give the IP address of the database. In my case, it's there in this local machine, and the schema which I want to import is SQLite tutorial. So I'll give the name, click connect. Okay, now it's connected. So now it is asking me which particular tables you want to create a connection with. I'm choosing department and employee, and I'm just loading them. Okay, so now this is the exact data which is there in the employee and department in MySQL. Okay, so this is one example of how to create connectivity between Power BI and MySQL. Now I want to do the same thing using SQL Server, Microsoft SQL Server. So I have also installed Microsoft SQL Server on my machine, and I have used the SQL Express. So this is the name of my server, so which I'll copy the server name and go to get data, select SQL Server, and for now database is optional. I can say direct query, click OK. Okay, now it is showing me what all tables I can import. So in my SQL Server tutorial, in my SQL Server, I have these three tables: customers, employee attrition, Olympic events. So I can use probably the customers one, which is now you can see this is the data, the customers data, which is lying in my SQL Server. Okay, so I can preview it and load it. So now you can preview the data in Power BI. That this is the data. So I can rename as customers from MS SQL, and this is from MySQL, and okay. So now this is not the only data sets you can import. Now if you take a look at the options which Power BI gave of what different type and variations of data it can it has compatibility to import from. Okay, so we can just take a look at the categorization on the left hand side first. There are file based like Excel, text, XML, JSON is also possible. You can evenly directly import an entire folder, and within the folder whatever data types of files are there, it will detect it. PDF, Parquet, or even SharePoint folder, which is itself a Microsoft technology. Then different kind of databases, SQL Server and MySQL we just saw. but it's not only limited to this. You can connect to Microsoft Access, SSAS, Oracle database, IBM DB2, Postgres, Sybase, Teradata, and then SAP databases, Amazon, Redshift, Impala, Vertica, Snowflake, and n number of databases which are there in the market today, Amazon, etc. Then it also allows you to connect with its own Power Platforms, Power BI platforms, data marts, Power BI data flows, Dataverse, etc. Azure, there are different kind of storage mechanisms in Azure, and Azure itself is a Microsoft technology, so it has a compatibility with a lot of Azure based data storages like Azure SQL database, blob storage, Azure Databricks, right, Azure HD Insight Spark. So if you have those kind of services running on your Azure cloud services, you can even import them over here. Now online services, like you have ERPs running or some data which is shared on the internet. If you want to import it, that is also possible through certain products. Dynamics 365, Microsoft Exchange Online, Salesforce, Google Analytics, Adobe Analytics, GitHub, LinkedIn Sales. If you want to do some analysis of some social networking, feeds, that also you can import. Then other miscellaneous are also there, web-based, Hive, R script, Python script, if there's something to import, get data from. Google Sheets, like we saw one example in our video right now. So there are multiple options available. Now, once you have imported the data which is relevant to you, in our subsequent sessions, we will see how to create relationships, but just giving you a glimpse that whatever data you are importing, Power BI auto detects certain relationships and it will create for you, but then you can go and manually also change. So this is the composite data model which is getting created in the backend while you are importing the data. You can easily go and manage these relationships, either keep them as is, you can delete and create new ones manually. So there is no limitation in that. So this is what we have witnessed. We have imported data from different files types, data types, and then we have tried to, once it is imported into Power BI, then there is no limitation of how you use it. You can create visualizations across different data sets and then create your standard reports. So this is the example of importing data from web, importing data from a database, from a PDF, and then once you have data, you can shape and combine data. You can basically do whatever transformation you want to do. You want to make joins, merge the data. So for example, if we go back to our Power BI, and if I go back to my transform data section, now as I have now different data sets available with me, I can do any kind of operation, transformation on the data, right? So like I showed you, I upgraded the header row because one of the imported data was not showing the header correctly, or this columns, like this exact one column is extra, I can remove the column, right? All those transformations, whatever I do in the backend gets captured in the applied steps section, right? This is the customer data. You can create, you can merge it, you can append it, with other data sets, right? Let's, for example, I want to create a merge data set of my categories and subcategories. So I can say merge, select those two data sets and say merge queries as new, and I can select product categories and product subcategories, select product category key on both the sides, and then they do a left auto join. So whatever product categories are there, I'll get the subcategories associated with it, and I'll create a new table which will have, now I have the table which has the category and the subcategory in one table itself. So I can rename it now to as category subcategory table. It's a merge. Basically, it's a join between category and subcategory, and now I have a common table, right? And I can close and apply. So imagine I have created a new table which is created from one data set which is Excel based, and another data set which is text based. See this category subcategory table. So now I can use it the way I want in my visualization reports. So that's what the presentation says, right? That once you have the imported data, you can shape, you can combine, you can adjust, you can do whatever transformation you want to do and create your visualization.
Now, Power BI can import data in three different modes. The first one is import mode, where you can just directly connect to the source and import the data in batch mode. And another mode is the direct query mode, where the data, the real-time data, is already connected to the Power BI dashboard, and by just refreshing the Power BI or the data source, you can get the real-time insights on the data. And the third one is the mix and match of both import and direct query mode. You can also call it as a dual mode or also as a composite mode. So if you want to know a little bit more detail in these three modes, you can just let us know in the comment section below, and we will have a complete tutorial covered for that. Right now, we will get started with the types of data importing using Power BI. So you can import data in different ways. It may be from files, it may be from an Excel document, it may be from a website, it may be from SQL or any other database, or it can also maybe from cloud, etc. Right? So we will be dealing with all of those here, and let's get started. So here we are on my Power BI window. Now there can be instances where you might have to load data from one or more sources, and you might have to club that data together. Now let's say I have continuous data from 4 to 5 different years, and we have a separate workbook or Excel workbook for different years, right? And in that situation, let's say you have a requirement where you have to completely segregate all those 4-5 years of data into one single file and import all that into your Power BI and create your insights based on year-on-year performance or month-on-month performance, right? So in a few situations, you might have your data in an Excel source and another set of data in maybe your database, maybe in a website, or maybe in a different source, correct? So in those situations, you might have to collect all your data, dump it into Power BI, and use data transformation and data modeling in Power BI and create one clean data set for you to perform your analysis and extract some valuable insights. So that's a different tutorial for a different day, but to help you with the fundamentals of data transformation and data modeling, we already have in detail data transformation and data modeling tutorials on Power BI. But if you want that all to be segregated into one single tutorial, you can let us know in the comment section below, and we will have that done as well. Now let's proceed with our data loading into Power BI. The first type, we will go with importing data from file, right? So you can just go to the get data option over here, and you already have a lot of varieties, but in case if you are not getting the one you're looking for, you can just click on more and you will have a set of options readily available on your screen like this one. Now here you can see some more options. So here I have a file option over here. You can just click on file or a folder over here, and now it will directly navigate you to the file system of your computer. Just double click on that, and here you will have the browse option. Just click on browse, and remember where you have your file. So I have it in my downloads, and here I have Excel, and just press OK. And now your data has been successfully loaded onto your Power BI window. Now here you can just click on load data, or in case you find it. So here we have 4 different years, just as we discussed in the beginning, the data of sales from the last 4 years, 2020, 2021, 2022, and 2023. So in such situations, you can just click on transform data and transform your data and model your data into one single Excel workbook and start your analysis. So if you just click on load, you can directly load the data onto your Power BI window, and this is one way of doing it. And see your data. Yes, there you go. The data has got successfully loaded. You can just directly select the data that you want, that you are working with, and you can have it here. And now let's proceed with the second way of loading data. So I'll name this file as I need this workbook as file load data from file, right? And now let's create a new page or new workbook where we will load data from an Excel file, right? So here you can just click on Excel workbook option directly over here, or you can also go with the same get data option. We'll go with Excel workbook. You can see it has directly redirected me to the place where I have my Excel files. So you can just click on Excel data that you're working on and press open, and shortly you can see the Excel files getting loaded over here. And now you can have the option of choosing what table you want to load, right? There are possibilities where one Excel workbook might have multiple sheets, but for now our Excel data has only one sheet, which is named as data. You can just click on it and have a brilliant preview of your data. You can check for any of the errors. Let me remind you, if you have some data cleaning to be done on your data, Power BI will automatically open Power Query window for you, where you can run all your data cleaning operations, and each and every step you are investing or you are making while creating the data cleaning process, or while you're going through the data cleaning process. And you can eliminate the manual task, and you can save all the steps, and you can automate your data cleaning process, and Power BI will automate that process and clean every single cell of your data set, and your data will be ready for extracting insights. Now this is another way of importing or loading data into a Power BI window from Excel files. You can just directly load, or in case if you want to transform, you can just click on transform data, and the Power BI window will get redirected to a Power Query window where you can clean your data and load it. So this is the second way of doing or loading your data. Is a problem, you can just view and clear those errors manually. That's one way of doing it, and I'll just close it for now, and let's focus on loading data from a different source. So now we have so far loaded data from a file, loaded data from an Excel file. Now another way is load data from a website. So before we move ahead, let's have a look on the website that we are selecting for today. So we are selecting the world population website. You can see this particular website is running real time. So it's giving us the calculations in real time, right? So you can also load the real time streaming data onto Power BI. So all you have to do is just select the, or copy the URL over here. This is present right here, and just go back to Power BI window. And here you have the options. So take the option of web, and now it will ask for the URL. You can just paste the URL and just select the basic, or if you have some advanced settings, you can also have the advanced parameters mentioned for Power BI. So I'll go with the basic ones here. And in case if you want to also explore the advanced settings, please do let us know, so that we can create an exclusive tutorial for loading the data from website using advanced settings. So it's a longer tutorial, so do let us know so that we can create an exclusive tutorial for that. Now just press OK, and your data should be loaded. You can just connect. Now a preview of the data will be loaded onto your screen. You can just select the table that you want, right? So we have multiple. If we just go back to the website, So you have multiple tables here. So the first table, it will recognize this particular part of data as a table, and apart from that, here it has top 20 largest countries by population live as a table, and any other tabular data present on the website. See this one, it will also be considered as a table. So you can select any one of the tables you want and load that data onto Power BI. Now let's select anyone. I think you might have a preview here. It's still loading. So there you go. So we have multiple tables here. So you can just select the table and have a preview and see if that's the table that you wanted to import. And if you find the table that you're looking for, you can just click on the load or transform data. In case if you want to do any data cleaning, you can just click the option of data transform and do that. And if you are happy with the data that you have on your preview, then you can just select the option of load the data. So I think this is the table I'm looking for. You can just click on load data and that will be directly loaded onto your Power BI platform, and it will be ready for analysis and extraction of insights. It might take a little while, but that's okay. There was some error, it was not found. Let's discard and try to get that once again. Now we have the preview of the data. Now let's directly load it. There you go. There we have our table number 12 directly loaded. So here you can see, correct? This is how you can load data from a website. And now let's explore another one where we can load data from either a cloud or a database, correct? Now here we have as load data from database. So there are multiple databases available. You can load data from a SQL server, you can load data from a MySQL workbench, you can load data from PHPMyAdmin, which is for PostgreSQL. You can load the data from Microsoft SQL Server and Dataverse, and also from the cloud sources. All you have to do is just add the server ID and any credentials like the username, password, etc., and the data will be loaded. Now let's try to load data from a MySQL workbench or MySQL database. So you can just click on more, and here you can type MySQL database. There you go, and just connect. If you are connecting for the first time, it will ask for the server ID and database. So we will go with the local host over here. So the address for local host is 127.0.0. Okay, let's quickly check our port number from the MySQL workbench. So my port number is 3308 and 3306. Let's work with 3308. 13308. Don't forget the double colon over here. This one, it's very important. And if we just dive deep into this particular database, we have different databases. SLP system. Well, if we just click on SLP, we have so many tables. So let's go with SLP. I type in SLP and press on OK. So it might also ask for user ID and password. So my user ID and password are root and just Power BI @123. So everyone could have their own passwords, correct? So you might have a username, dedicated username and dedicated password. Just use that. So I've already logged in here, so it just gave me direct approval to navigate. In case if you're using this for the first time, you will just have username and password request on your screen. You can just type it down and press OK. So here we have book collection table and a few other things: book owner, order, employee details, employee register. So I'll just go with employee details. This is the one. Just load or transform data. If you are happy with the data preview you have, just load the data directly. And yeah, it should be loaded shortly. There you go. So Simplilearn employee details. This is just a simple small data set that I have personally created, and you can load it onto the Power BI and start your analysis. So in case if you're working with cloud, the same, you just have to enter the details from cloud, and that's how you can do it. And in case if you're looking for an exclusive tutorial on how to load data from cloud to Power BI, please do let us know and we'll have it done for you. Today we will learn how to use Power BI with AI. For that, let's consider a small problem statement, or in other words, a simple use case. So here it goes. A business chain's data analysts use Power BI to generate sales performance dashboards across multiple stores. Due to manual data cleaning, report structuring, and repetitive DAX calculations, the process takes several days, delaying the important decision making. Analysts struggle with errors and inconsistencies due to high data complexity. By integrating Power BI's AI features like Smart Narrative and AI Insights, they automate trend identification and anomaly detection. Now, analysts quickly generate visualizations by simply typing questions, reducing manual effort. AI-assisted data modeling ensures cleaner datasets and accurate relationships, enhancing efficiency. As a result, report generation time drops by 50%. Dashboards are more insightful and stakeholders receive actionable insights faster. Now, as discussed in the use case, let's imagine a similar performance analysis dashboard. Now, what exactly is AI in Power BI? So, AI and business intelligence are two technological spheres that, when combined, offer a powerful toolset of transforming raw data into actionable insights and making data accessible to everyone. Similarly, AI features in Power BI can analyze user behavior to customize reports and dashboards to meet individual data needs using the raw data. Now, let's imagine this. Suppose there is a significant growth in business and you wanted to identify the reason behind it and replicate the same idea across all categories. Or maybe reward the team which is responsible for that. Or let's say there is a significant drop in business and you wanted to understand the reasons behind it and pinpoint on the one which is responsible so that you can resolve and improve the overall business growth and pull out some revenue out of it, right? Now, if you are doing it manually using Excel datasets, or even if you're doing it with Power BI datasets, you might end up creating a lot of Power Queries, DAX expressions, and also if you're working on Excel, then you end up creating a lot of pivot tables, and it might be a manual task and will consume a lot of time, right? Or in case if you're in help with AI, then the matter of days could turn into the matter of minutes, and you will have the exact data or information you're looking at, and you can resolve it in a matter of minutes or hours, maybe after a business decision has been made. Now, let's go through a practical demonstration on Power BI for this. So before that, let's have a quick look on the dataset that we will be using today. So this particular one, which is the auto sales data for 2024, is the one we will be using today. So we have all the columns: order ID, order date, and delivery date, state, dealership, pin code, region, and the names of the products, and the fuel type, leads, revenue, profit, and cost to company, everything, right? So this is the cleaned data that we have today for our data analysis. Now we will be identifying the key areas that led to the quarter-on-quarter growth, or if you drill down a little bit more, then we can also identify the month-on-month growth, or in case if there is a drop in month-on-month or drop in quarter-on-quarter, we can also identify what is the reason behind it, where is the loss coming from, which car product or which dealership, or what might be the reason. Is it about the season or the customer or the dealership? We can drill down a lot of information from it, right? So this is the overall idea of how to utilize AI in Power BI. Now let's quickly switch to Power BI. Now we are on Microsoft Power BI and we have already loaded the data, which is here. This is the preview of the data that we are going to work on. Now let's go back to the report view and pull out a visualization. Now I'll be trying to proceed with the bar graph. Now let's pull some data. So I'll go with the order date and drag and drop it to the x-axis. Now let's go with the orders, and that will be in our y-axis. Here you go. Now if you drill down a little bit, this year will be turned into quarters of the year. Now if you kind of drill down again, now you have month on month. Now let's try to do some modifications to this data set called the data visualization and add some improvements. Go to the view tab here, go to the customize current theme and go to text. And now here you can increase the font size, maybe 18 to have a better visual. And after that, if you go to the format icon here, you can also add data labels if you want. What is the total number of sales that we made? Now we have a perfectly functional chart here. Let's eliminate this. Now let's begin with the AI for identifying the drop trends or the growth trends. Now here you can see the month of August in 2024 has gave us the highest sales, which is 2,618 orders. And you can see there is quite a good growth here. Now, if you wanted to find out what is the reason behind this growth, then just click that bar and right click or double click and go to the option called Analyze. So this is similar to the Excel's what if analysis, but with a little change. Now here you can see that Power BI will automatically give you a lot of charts and visualizations like this one here, which is a waterfall model, and this will indicate you what was the reason of the growth. And here you can see we have received 11 orders from Andhra Pradesh. This is a state-wise analysis. And also you have decrease. So there is a decrease in Mizoram and a few more regions like Karnataka and everything. So this is something behind the reason for growth or drop. And here you can see the product-wise analysis where we have some growth from cars like 8 Series, Wellfire and others. And after that you have some dealership data as well. So there is a good orders that is received by Prime Auto, Elite Auto and a few others. And there's a drop in Asian dealerships, etc. And here you have the status on delivery. So this is also good. And now let's say now you wanted to identify what's the reason for drop. Now what you can do is you can just click on the month which showed you the maximum loss or the least orders received. And you can go to that. So the least orders is practically from March. And here you can see there is a sudden drop from August. Let's say you wanted to compare with these 2 months. And then what you can do is you can just same procedure. You can just analyze and now explain the decrease. Now you have the reasons behind the decrease here. So we have a couple of cars which are not receiving good amount of sales. And after that, you can also see state-wise a drop in orders. And after that, you can also see the type of car which has stopped receiving orders. You can see sedan class has drastically stopped receiving orders. That's the reason behind it. And after that, most of the orders are in transit. So you can filter out the in transit ones because this will be delivered to the customer. So the overall, sales will be or the overall orders number will be increased once this transit becomes to delivered, right? And here you have delivered as well, right? So it might be a drop in delivery numbers as well. And compared to the previous month, the number of orders delivered will be low. Or if you had to talk about the in-transit, I think this is about the in-transit one as well. So previous month had a lot of cars in transit, and this month compared to that number, it is a bit low. So that can be the reason. And after you drill down a little bit more, you have region-wise analysis. Now, this is also another way to find out the drop analysis. And let's say you wanted to compare 2 different months of a quarter, right? So here you have quarter 1. The highest performing month of quarter 1 happens to be the February one. No, the January one. And you wanted to compare that with the highest performing month of quarter 3, which is August. In that case, you can just hold control and select the first month from first quarter, which is the highest performing one. And you can compare month on month going to the Analyze button, explain the reason between the increase here. Now you have the entire report. Now, let's say you have a brilliant looking chart over here and you wanted to present that to your stakeholders. Now, all you can do is you can just select this particular chart and select the option which says plus, which will automatically get added to your dashboard, which is somewhere here. And you can set it in the way you want. Now you almost have a semi-functional or mini dashboard for you, which explains you the decrease or the gain in orders and also the month-on-month performance. So you have a fully functional report in front of you, which is explaining the comparison between the highest 2 performing ones. So this is how you can make use of AI in Power BI for data analytics. Power BI data modeling is crucial for effectively analyzing and visualizing complex datasets. When data resides in multiple tables or sources, it can create challenges such as inconsistent relationships, redundant data, and slower query performance. Data modeling resolves this by uniting disparate datasets into coherent structure, enabling efficient data retrieval and streamlined analysis. A well-designed model often employs the star schema, which is a relational database structure that organizes data into a central fact table surrounded by dimension tables. The fact table contains numerical metrics like sales or profits, while dimension tables hold descriptive attributes like product categories or customer names. The star schema simplifies querying and enhances performance by minimizing redundancy and maintaining clear relationships between all the datasets. This structure is particularly advantageous for reporting and business intelligence, as it ensures faster processing and more intuitive navigation for users. By implementing a robust data model, Power BI users can overcome fragmented data and unlock actionable insights with ease. Now we will understand what exactly is a star schema in Power BI. So in other terms, people also prefer to call this as a snowflake schema in Power BI because the shape of the schema represents a star shape or a snowflake shape. So basically, there will be one fact table which stores the major part of the data set, and there will be some sub tables or the subordinate tables which store the relevant data to that particular fact table. So the fact table maintains many to one relationship with these dimension tables, right? So basically, it will be interconnected with each and every table in the particular schema, and you can extract information in the way you like. This might be a little confusing theoretically, but let me navigate you through this session through a practical demonstration. Let's actually create a dataset using generative AI, and moving ahead, we will extract or we will pull the same data onto the Power BI platform, and then let's look at the star schema practically. Now, let's go to the ChatGPT or any of the generative AI platforms to create the dataset that we are looking at. So this will be my prompt for creating a star schema. So we will be trying to generate 5 different data tables with 2000 rows each. So we will be creating one fact table, which is the sales data. Followed by that, we have 4 dimension tables, which are customer data, product data, orders data, and shipping data. So this is the prompt that we will be using today. Now, let's select the entire prompt, copy that, and get back to ChatGPT. And here, you'll just paste that prompt and then hit the go. I've already created one such data table. It would take a little time to generate the dataset. While a ChatGPT is working on creating it, let's look at the data that I already have in my inventory. This is the data that we have in inventory. So as for the inventory, the sales data, which happens to be our fact table, has order ID, price, discount, cost to company. Let me expand this. Profit and rate, right? And then the fact table is then connected to the dimension tables, which is about the customer information, customer data, customer name, state, city, etc., and the product details to which category or which product is being bought by the customer. And then we have the orders data and shipping data, right? So shipping data includes the type of shipment mode chosen by the customer and also the order date and the ship date. Let's save this. Now, let's have a look at the generative AI prompt that we just wrote. So there you go. So ChatGPT has successfully created us the dataset, and here the link is. You can just click on this link and you'll get the downloaded dataset, which looks something similar to this one, right? Now, how exactly star schema or snowflake schema works? Now, let's say I have this order details here, the sales data here. I have order 0, 0, 0, 1, 2, 3, 4, and 5. Let's say I wanted to track this particular order with ORD 0005. So I want to find out the customer who bought that. Now I can get connected with customer data having the order key, order number as the key in between, which is common in between both the tables.
And based on that, I can extract the customer details, the customer name, the customer city, the customer state, country, and region. And now let's say I wanted also to extract the product details of what the customer 005 has been buying, or on the order number 005 is at, right? Now, if I trace down the order details further, I can identify the product ID, product name, and product category along with the subcategory of the product name, which happens to be tables, right? And now if I drill down a little more bit, then I have these many number of traffic, leads, and orders received to buy 13 quantities of that particular item called table. And they preferred, kind of same day delivery. So this is how the star schema works. All tables are interlinked to each other. Now, let's quickly switch to the Power BI platform and try to extract or pull the same data set onto the Power BI platform, and then let's wait for Power BI to generate us a schema. There you go. Now we are on the Power BI platform, and now the data that we are working with is in the form of Excel. So let's prefer the Excel workbook as our source. Now this is the data, the demo data that we just created. You can just open it and the data will be pulled for you onto the platform. It might take a little while. Let's wait. So here we have the data ready, and we have 5 tables according to the discussion. 1 fact table, and remaining else are the dimension table. So the customer data, orders data, product data, shipping data are the dimension tables, and the fact table is sales data. And then you can just load or transform. As far as I'm concerned, my data is clean and I don't have to proceed with the transformation. But just in case if you want to perform some data cleaning, then you can go ahead with transformation of data. And if you have to look at an exclusive tutorial on data transformation using Power Query, then we have linked it in the description box below, and you can have a clean reference to it. So far, so good. I'll continue with loading the data since I'm confident with my data set. Just load it, and it might take a couple of moments. The data is slowly loading. Let's give it some time. There you go. The data has been successfully loaded, and here you have the view of your data set. So here we have leads, order ID, quantity, etc., product details, and the sales details, all of them that you needed. And if you proceed with this particular table view, you can see the tabular version of the data set. And here lies the most important part of today's discussion, the model view. And if you go here, the Power BI platform has already created the relationships between your data sets. And if you just rearrange a couple of those schemas, you can literally make a star pattern out of it. And also, if you look at this particular position here, you can see that we can establish some new relationships, or you can try to edit some existing relationships with the Manage Relationships option. Now, you just have to drag and drop a few of these tables over here so that you can exactly maintain a star type of pattern. There you go. So that's how you can generally create a star type schema, or also known as the snowflake type of schema in Power BI. So what exactly you mean by data transformation in Power BI? So data transformation can be a little similar to data cleaning. So before any kind of data analytics, you might be receiving raw data from a website source, a SQL database, or an Excel file, or multiple sources, right? Once after you receive the data, whether it is batch mode data or streaming data, you are supposed to clean it, right? You might have to clean up the discrepancies like the blank rows or the blank cells or any irregularities in data, such as wrong data type, right? Such discrepancies from the data should be eliminated in the first stage of data analytics. So that's exactly where data cleaning and data transformation comes into the picture. So you have various tools for data cleaning and data transformation like Excel, SQL, but if you are a Power BI user, then good news for you. Power Query in Power BI can assist you in terms of data transformations. So in this tutorial, we will be discussing the fundamental, the most important day-to-day data transformations which a data analyst takes care of in the process of data analysis is what we are going to discuss today. So let's quickly switch to Power BI. But before that,
let's have an overview of what kind of data we are exactly dealing with today. So we are dealing with Superstore dataset, and that's in Excel format. So this is our Superstore dataset, and we have 4 tabs here. The first one is Orders tab, where we have Customer ID, Order ID, Date, Ship Mode, and Customer Name. And in the second tab, we have Stores dataset, which has the details about the customer, from where he or she is, the state, city, postal code, and which category or subcategory did they purchase, and order, sales, discount, profit, everything, right? And here we have some information about any of the orders which were returned and some people over here. So these are the 4 tabs that we are dealing with today. Now that we have an overview on the data that we're dealing with, let's quickly now switch to Power BI. So now we are on the Power BI window. You can just discuss changes. There you go. Let's quickly import the data from our downloads. This is the data set that we want to deal with today. Now, it might take a little while to connect to that particular data set and load the data onto Power BI. Just a couple of minutes, since the data set is a little too heavy. It's about 10,000 rows. So let's wait. Shouldn't take long. There you go. The data got successfully loaded. So you have the option of loading what kind of data you want. You have 4 tabs as we just discussed. You can load the Orders tab, and you can load the Stores tab. And in case if you want the Returns tab, you can also load that. And if you want all of those, just load all of those, right? Now, I just want the 2 tabs, Orders and Stores. Now here I can just directly load to get started working on this. But in case I don't want any kind of discrepancies, in case if I have a doubt that this data might not be cleaned, I shall go with data transformation. So ideally you should go with data transformation. Check your data first before any kind of analytical processes. So let's go with that. Transform data. And shortly we should be having the Power Query window open on our desktop screens. So there you go. You can see the complete dataset has been successfully uploaded, both the Stores and Orders datasets. Now let's quickly check the data from our dataset. So here you can see we have orders date, right? But I can see 42682 and 42533. This is not in the form of date, correct? So this is the simple step that we discussed, changing the wrong data type. So you can just click on the lower arrow button over here, and or you can right click, and here you have an option to change the type, correct? So it is considering it as a whole number, which is wrong. So you can change it to date. Replace current. So now we are trying to change the order date from a data type of whole number to date data type. So there is some error. If you click on error, or if you just navigate onto it, Power BI should be able to show you what error was it. And just in case if it's not working, okay, we are unable to parse the value provided. So you can just remove that and try it in a different way. Change type to date and time zone. Date. I think this should be helpful. Or if it's not working here, let's quickly check what could be the error. Date time. And now let's try to refresh the data. It is taking a little while. We also have another information that to deal with. We have the first row as row headers. So we should be declaring Power BI that we also have a row header over here. It's taking a little while to refresh. Meanwhile, let's quickly check into the stores data, and here we have customer name. So let's try to apply second type of data transformation, which will be like, let's say, split column. We have the complete name of the customer. Let's try to split it into first name and second name. So by delimiter, and we can give multiple options over here. Leftmost delimiter, let's say a person has three parts of his name: first name, middle name, and second name, or the last name. So but we just wanted to split it into first and second name, so we would go with the first leftmost delimiter and split the data set. Press OK, and it should help us to split the data first name and second name, and we can also name the columns separately as first name and second name instead of customer name. It's taking a little while than the ideal time, but it's completely alright, since considering the 10,000 rows of stores data and 10,000 rows of orders data, it is alright, not a problem. Now let's try to take a look at the orders data set if it has successfully changed it. No, it is still showing us an error. I don't know what's wrong here. It's maybe incomplete. Let's quickly refresh all instead of preview and check if it can help us. So there you go. After refreshing, the first order date is changed to date data type. So what we missed is when you change the type, you're supposed to add a step. So what exactly I mean by that? Now we are trying to change the second one as well. So just wait for a while and it will give us a choice if we want to add a new step or not. That's when we select the option yes, please add a new step. So what do I mean by steps? So applied steps, you can see something over here, right? So every alteration, every change, or every modification that you're doing, every transformation you're including onto your data will be recorded as a macro. So that can be implemented if you are loading a similar data set for the next batch. Let's say this is 2022 data, and if you're trying to analyze the 2023 data, and every column is similar, and you can just follow these applied steps and the same implementation will be automated. You don't have to spend time in doing the same process once again. There you go. So this time it has recorded this step and it automatically has taken a new step over here. Change type step 1, change type step 2. If you don't want the step to be added, you can just select the red X mark over here. It will remove it. And similarly, when you go back to the stores data set, here you have the first name and second name split successfully. And now let's say you want to have unique customer data, right? In that scenario, you can just even remove duplicates from this particular column. Just remove duplicates and you'll just have unique data. It's possible that one customer might have come here to buy the same product, buy the same product from different dates, or one customer might have done a repeated purchase. So it's possible, but again, if you just wanted to know if there is a way to eliminate duplicate entries, then you can do that. So for now, let's not delete the customer IDs here, because one customer might have visited the same store for multiple times and might have purchased a different product, or might have made the same order with multiple products, right? So there is a possibility for that. Let's not disturb the data set. So I just wanted you to know if there is a way to eliminate the duplicates from the data set. Yes, it is. Now let's also check another possibility of data transformation. So let's say you wanted to add a new column and identify or include some mathematical operations. For now, let's say I have sales, quantity, discount, and profit, but I don't know what's the rate, right? So here the sale is for $261 and quantity is 2, but I don't know what's the rate of one product. So I can include that. You can just select the last column, or where you want a new column, just go to the add new column here, and here you can just choose the custom column. Should be somewhere over here. Yeah, this is the custom column. And now if you click on the custom column, you can rename the custom column to rate of product, and here you can choose the mathematical operations to be applied on the columns. So sales column, insert or double click, divided by quantity. Okay, now it should give you the rate of each product, individual product. It is taking some sizable time. It shouldn't take so long. So there you go, you have the rate of product. And now let's say you want to combine multiple data sets. For example, here I have stores data set, but my stores data set doesn't have any data related to orders, and orders does not have any data related to customers. Now I want to combine these two. Is there a way? Yes, you can do that. Now let's get back to stores, and here go to home option, and here you have something called merge queries. So now the stores dataset has been selected in the first dataset. Here just select the drop down and select the second data type, which is orders. So here you can see stores with the current one, which is in the first place. Now select based on which primary key you want to combine both. So I want to go with customer ID because both of my datasets do have customer IDs. So I'll go with customer ID, and both datasets will be combined. At the end, at the last column, Power BI will show me a new table, not a new column. It will give me a table combined with all the columns in one column. You just have to expand the column and select which columns from the second dataset you want to include in your overall dataset. So let's do that practically. So here you can see I just have tables. If I select the expand column option over here, you can see I have a lot of columns here. So just deselect everything. I do have row ID, I do have a customer ID. What I need is order ID, order date, ship date, shipment mode, and customer name. I do have it. So that's all I need. So just press on OK, and I should have them included in my new dataset altogether. It might take a little while. So there you go, we have the new orders ID, order date, ship date, and ship mode added to our dataset. Now just click on close and apply, and your dataset is all ready for data analysis. Apply changes, but it is taking a little time. So at the end, you just have to click on the apply changes and your data will be ready for analysis. So that's exactly how you can perform data transformation in Power BI desktop version. So there you go, the dataset got successfully loaded all over here, and you can just drag and drop them onto the visualizations part and you can work on your data. Now, what exactly is data modeling? So most of the times your data might be from different sources. Let's say one of your team member prefers to use Microsoft Excel, and another one prefers to use a relational database. And sometimes you might have to take care about the real-time streaming data from your company's websites, like maybe the traffic for today, current traffic, current number of leads, current number of applications submitted, revenue, cost per lead, etc. Right? So this data comes from different sources, and you being a data analyst should be able to segregate all the data, collect all the data, filter it, and create one single module to perform your analysis, right? So the process of collecting data from different sources, segregating it, and trying to relate them to one another is a process called as data modeling in Power BI. Now, data modeling is done with the help of Power Pivot. It's also available in Microsoft Excel, maybe since at least more than a decade, right? So the same Power Pivot is also used in Power BI. Now, to understand more on that, let's go ahead. Before we get into Power Pivot and understand all the technicalities, let's understand some theoretical answers. Now, modeling can be done in two ways. First one is the dimensional modeling, which is currently used in most of the business intelligence tools, and another one is the relationship model, which we have seen since ages, where we use in normal relational database, where we create some foreign keys, some primary keys, and try to relate one table to another based on the foreign key and primary. Now let's go ahead with the dimensional module first. So what exactly is a dimensional table, you ask? So dimensional table is one of the set of companion tables to a fact table. So let's say the center table which you have here, sales, is the fact table. So sales data will basically have the product ID, order ID, profit gained, price of the product, quantity, etc. Right? So this particular table, which is in the central place, which is called as the fact table, is connected to the store, which will have the details of the store, region, location, and another table which has details about product, another table which has the details about dates, shipment date, order date, delivery date, and another table, customer. So all these dimensional tables are connected to the fact table, right? So so the fact table is something which will not change over time. Let's say on today's date, on current date, you made a sale of $100, you sold 5 to 6 products, right? It will be the same even after you open the database after an year. It is not going to change. It is a fact. It is a real data, right? And when it comes to product, there might be changes in product ID. There might be changes in, minor changes, not if not 100% change. There might be negligible changes. There might be negligible updates, something like that. Maybe you are collecting customer first name, second name, phone number, and address. Maybe tomorrow you might also want to have an email ID added to it. Maybe tomorrow you want to add some specific, customer IDs or custom something, some additional things to your data set. So that's the difference between the regular table and the fact table. So this is how the dimensional modeling is done. When it comes to the next type of modeling, that is the relationship model, right? So you will be having one table and you will try to connect to a different table, right? Both these tables are connected based on a primary key and a foreign key. So the primary key in product table can be the product ID, right? And when you go into the next table, which is product type, there you will be having maybe category, subcategory, product name, and the category or the subcategory can act as a primary key for product type table. Additionally, there will be another column on the name of product ID, which will become the foreign key for product type table and a primary key for product table. And you can connect product table and product type table together using these primary key and foreign key. So the people who know SQL might have a better idea on this. In case if you don't have idea on that, we have a dedicated set of tutorials in SQL and data loading. So you can have a look at that in the same Power BI series. Now that we have a detailed understanding of the types of modeling in Power BI or data modeling, let's proceed with the relationships, right? Cardinality, or the types of relationships which you can establish using the previous model which we discussed, which is this one, dimensional model, right? So the cardinality or the types of relationship, what you can expect is one to many, many to many, one to one, and many to one. Let's say we will deal with the same sales data and customer data, right? So in customer data, let's say we have 10 customers, and in the sales data, we have the same 10 customers, but 100 entries, right? So customer number one, maybe let's say Harry Potter. Harry Potter is your customer, and Harry Potter bought 10 wands today, and after a couple of weeks, he came back again and he bought 10 more wands, right? So there is a multiple entry here. So many entries are related to one entry, which is in customer table, right? Such relationship is called as one to many. And when it comes to many, then you might have another table, sales table, and products table, right? Where you have the product, the wands, right? So wands to customers, that is many to many. And there is a specific wand, let's say elder wand, and the user, you guessed it, right? It can be the last one who holded the one. So 1-to-1, that kind of a relationship is 1-to-1. So remember, we are using some movie analogy so that it is easier for you to understand. And the last type one is, let's consider it as a slight assessment to you. So you tell me in the comment section about what could be many to one. So these are the types of data modeling and cardinalities which you can perform while data modeling. Now we will understand this in a much better way using a practical demonstration. Before we move ahead using this directly on Power BI, let's understand Power Pivot, how exactly it works in Excel. Then you can understand how it functions in Power BI. Remember, so Power Pivot, Power Query, one and the same for both Power BI and Microsoft Excel. So Power BI is an advanced version of Microsoft Excel, which has, you can consider this way, okay, which has some additional functionalities of creating some vibrant charts and ability to get connected to a bigger, higher, advanced versions of data storage like cloud, etc. Right? So that's how you can simplify the difference between a Microsoft Excel spreadsheet and the Microsoft Power BI product or the business intelligence tool. Okay, pretty much so far so good. Now let's quickly switch to Microsoft Excel. So this is my local storage, and here we have some Excel files. So remember, Microsoft Excel or Microsoft Power Query or Microsoft Power BI can load data from an Excel worksheet, a comma separated file, the same Excel file which is saved in form of CSV. It can take data from a PDF, it can take data from a website, it can take data from cloud. So we have also covered an exclusive tutorial on how to load data onto a Power BI from various sources. The link can be found in the description box below, or let us know and we will have it sent to you. So we have the same tutorial in our Power BI series, right? So here we are dealing with the Microsoft Excel files. So as discussed before in the dimensional model, we have the fact table, which is the sales data, and other or all the dependent measures of data where we have customers, store locations, product data, region, sales, etc. So we will also have this data set or the file linked in the description box below. Should you want to follow us in this demo, you can download the data and follow us in the explanation process. Now let's go ahead. Let me open sales data, and let me also open another data set which will have customers data maybe. Let's try to open a few more files. So this is the customers data, and here we have sales, here we have a product, could be store locations. So we have opened store location, sales team, product data, customers data, sales data, and lastly the regions data, right? So we have about 6 files in it. So we can, load all these 6 files onto Power BI, and so here we have already created a data model over here. So before we directly jump onto this, we will understand how exactly the Power Query and Power Pivot works in Excel so that you can apply the same knowledge on Power BI for a better understanding, right? Now let's close this. We don't have anything to do with this right now. Let's understand. We deal with Microsoft Excel, right? So we have the sales data right over here, and the next, let's say we go with, right, so here we have different regions, south, west, north, right? So we don't have the region data in sales table, but what we have is sales channels and order dates, shipment dates, etc., customer ID, correct? Now let's say I have a query. I want to find out how many number of sales happened through this particular sales channel in all the regions. Let's say I have east, west, north, south, and I wanted to find out how many number of wholesale sales happened in east region, how many number of in-store sales happened in west region, right? So when you want to do this, you might want to run some formulas or run some tools like building a pivot table or maybe a VLOOKUP function, which is a little complicated to understand, right? You might have to create an entirely new table. You might want to pull the data from both the tables using the lookup key, the range, the exact match, right? The number, the column number, and the exact match or approximate match. It's a hectic task, right? But when you know how a Power Pivot or a pivot table, Power Query works, then it's just like a breeze. So let's quickly maybe create a new workbook. And here we have Power Pivot option. Should you have a doubt how to activate Power Pivot, it's really simple. So you just need to go to the File option over here. Just click on File and go to Options, enter. And here you have an option called Add-ins. Click on Add-ins, and here just go to Excel Add-ins COM. So you need to select the second one, COM Add-ins, and go. I have already included the option, so I have it over here. In case if it's not added, just click on Microsoft Power Pivot for Excel and just OK. You will find it in the ribbon right next to it, right? So here you have it. Now, before we just directly dive into Power Pivot, let's go to Home and try to load data. So go to Data and Get Data from File. So we are working on Excel workbook, so we'll take Excel. So we wanted to find out the region-wise sales, correct? So go to Downloads, and here we have Data Modeling in Power BI Data Sets. And expand this a little. Go to Sales Data and Import. Now the Power Query will be firing in the background and it will show you the various tables it just had a look at, and select the table you want. And now instead of directly loading it, go to the option called Load To. Now it will give you a new option where you don't have to import the entire table but just create a connection only and add this to the data model. Check on that, correct? So these are the two steps: only create connection and add this data to the data model. Press OK, and so far so good. The sales data is getting loaded. Now let's try to do that step once again, and now we will import a different table, which is regions data. Import, and there you go. Select state regions, load to, and the new box or new window where you will be selecting only create a connection and add this data to the data model. Okay. Now the magic starts. Go to the Power Pivot and select Manage, and here you have some tables, Sales Table and State Regions, correct? Now you are not using any VLOOKUP, XLOOKUP, HLOOKUP functions. You are not using any pivot tables. You are just clicking on the option called Pivot Table. That's all, and a new pivot table will be created. Right now you have sales and regions. Select maybe the region and go to the first table where we had sales, and maybe you can count the order numbers. That will also help you, or you can unit price unit. So I'll go with the number of sales. Initially we wanted to find the number of sales, right? So you can just add the order number. Okay, remove this from here and from the rows, we don't want. And count, so it has automatically taken the count over here. So you have the count. So you totally have, okay, Midwest. So we have Midwest, Northeast, and Southwest. So you might have found that the previous number was a little same, right? So that's due to, due to this, if you try to detect the connection, we can't detect any relationships on selected pivot data, right? So why did that happen? If you go into the Power Pivot window, so here you can see the data on all these things, right? And when you go to the state regions, you don't find the state code, which should have been common in both these, right? So if you go to the diagram view, so when you look at both the tables, you don't have a common key in between these two. But when you go to another table in Excel, we have something called state code, these two, so that we can establish a connection between sales, state regions, and store regions. So let's do that. Let's go to data view. And now go to one which we created. We don't need these. Go to home, data, and get data from stores. Store locations data, locations, load to create connection only, add this data to the data model. Now everything is fine. Now we have three regions or sheets: regions, locations, and sales. Now create the pivot table. You can actually add in the existing worksheet, select the location, here it is. So now we have loaded all the three tables: locations table and sales table, which is right over here, and also the state regions. Now let's go back to the Power Pivot, which is right over here, and go to diagram view, and here we have it. Now we have the state code here. Drag it to attach it to this state code region over here, correct? That's one relationship. And the store ID, which is here, hold and drag it to the store ID in sales region. Now we have established a connection between all these three tables. You can just simply save it if you want. And now, okay, let's cancel. And now if you try to identify the region-wise sales, now you can do it. Let's add locations, region to rows. Drag it and add it here. And from sales, select order number and add it to values. So it's automatically to count. So we are counting the total number of sales happened in Midwest, Northeast, and South. And in case if you wanted to add more about, let's say, store details, you can also add that from region, state code, or state. So let's select state and drag and drop to rows. And now if you can expand or contract this, so here you have a consolidated table altogether with state-wise and region-wise sales and their numbers, right? So that's exactly how the Power Pivot works. So you don't have to use any lookup formulas. You don't have to add some mathematical calculations. It is just creating a relationship which looks something like this. You're creating a relationship and it is extracting the data and, creating a consolidated data table just like you wanted. So this exact same method is implemented in Power BI as well. So let's quickly go to Power BI window and start Power BI and try to experiment the data modeling in Power BI as well. It should take a little while. So there you go. You have the Power BI window. Close this and just get the Excel data. So we added the first one. There you go. Select the sales team. Load the data. Since it's already processed, no need of data transformations and data cleaning. This data is already clean and neat, right? Now let's also add the other data sets we have. It'll take a little while, but it's all right. So the sales team has been successfully added. Now we will add region data. Select the state regions. Load it. It takes a little time, but it's all right. Now we have the state regions as well. Product data. Select the product data table. Preview is fine. Press OK. So we have products and scroll down, 2 more to go. Select locations data. Load data. Customers data. 5 down and 1 last one to go. Sales data. There you go. Select the sales data. And now we have loaded all the 6 tables to Power BI. Now, unlike Excel, so if you remember this, if you remember this. So we have, manually created the relationships between the tables. But one good reason why we should prefer Power BI is it can help you automatically, establish relationship with other tables. So if you go to manage relationships over here, you have an option called auto detect. So it will automatically detect the relationships between the tables and it will create the relationships. So you can find it in here in options. Options and settings, go to options here. So not that modeling one. So it will give a new window on the screen, and here you have an option called data load relationships. So import relationships from data sources on first load, or to detect new relationships after data is loaded. In case if this is not checked, then you can just check and press OK, and your data model will be ready for creation. Now here, let's create a table data, a matrix data. Double click on this so that you have one here, just like the one we created previously. Just load the locations. So we had region in region. Yeah, here we have it. Right, just load region to rows, and maybe you can also add state to rows, and you can count the number of orders we received. So it should be available in the sales data. So number of store ID, discount, order quantity, order date, order number. So every order is unique, so I think order number should be fine. You can add order numbers and values, and it can be, you can count it, and you have, okay, let me expand this if possible. Okay, let me close all this. Mode, so this should help us. So just like the pivot table what we created there, we have the same pivot table here. So that's how you can create the relationship between all the tables in your data set, and you can create a perfect data model to create the visualization of your choice. So with that, back to report, and here you have the report view, table view, and model view. So if you check the tables, you have customers table view, location table view, products table view. So if you're attending an interview, then there are chances where you might be tested about your skill set, like if you really know Power BI or not. So they might ask you what's table view, what is model view, what is report view. So the view where we create the reports or visualizations is the report view, and the view where you can just have a look at the data how it is called as the table view, and this is the model view where your data is loaded and Power BI has automatically established the relationships between all the tables. Remember, in Power Pivot, we manually created these relationships. But here, you can see in Excel, Power Pivot, we had to manually create the relationships. But here in Power BI, you can see Power BI has automatically created the relationships. So here it has a one-way relationship. So if you double click it, you can make it two-way. So it's not single way anymore. You can make it both the ways. And it has a one-to-one cardinality relationship here, right? So it has locations and state regions. So you can find out what type of relationship is built and what type of cardinality has been established between any two tables or any number of tables which are involved in this Power BI data model, right? And that brings us to the end on this topic of data modeling in Power BI. So this was the previous model which we created, and that's the new model which we just created right now. So DAX is basically the data analytics expressions. And in DAX, we have a lot of DAX functions, namely aggregate, date and time, filter. So this is a filter one, financial functions, information, math, logic, and many more. So we are covering one after the other DAX functionalities in our Power BI playlist. We have already covered aggregation and date and time functions. Now we are going to start with filter functions. Now, what exactly is a filter? This is a straightforward question and you will be expecting a straightforward answer, right? You will be applying some filters or conditions based on which you will try to filter out and extract the data. Let's say we have 4 years of data, 2021, 2, 3, and 4, and you wanted to take a look at the latest data from 2023 to 2024, what you do is just apply a filter, change the dates, and apply the condition that I want the date from 2023 to 2024, and rest everything you can leave, and the data will be extracted. So as simple as that. So we're not just covering that basic filter here. So we will be covering some most frequently used and latest updated filters in Power BI, like the calculator filter. So there are types of filters for one dedicated page and all filters, and after that some lookup values, match by and match functions, fuzzy match, offset, order by, partition by, range, right? So, and window. So these are the newly updated filter functions. And apart from that, everything is as the same old Power BI. So a few of them are recently updated in the recent times. Now, let's get back to the functions which we will be discussing today. So this is the first one, which is the filter function. Apart from that, we will take a look at the lookup value. So when it comes to lookup value, if you are someone who knows Excel, then you might be wondering, lookup is the best, maybe one of the best features to look out for a value and extract the details. So we have multiple lookup functions, which is XLOOKUP, we have VLOOKUP, we have HLOOKUP, and if you're not a big fan of lookup, we also have index match, which is also an alternative, the best alternative to lookup functions. But when it comes to Excel, it's 100% reliable. But when it comes to Power BI, of course we can say it is reliable, but as far as your data doesn't have any discrepancies. Let's say I'll give you a simple use case. So let's assume that in this use case you are dealing with school data. So roll number 1, roll number 2, and roll number 3. So roll number 1 has someone named as Jack, and roll number 2 has someone named Jackie, right? So if you are using a fuzzy match, let's say you don't want to, okay, when it comes to fuzzy match, I'll let you know what a fuzzy match does. So what fuzzy match does is, let's say JACK are the first 4 letters, JAKIE. Okay, let me open up a simple spreadsheet so that I can tell you in a much better way. So FC1, and let me also open up FC2. So here we have 2 different files, right? So here you can have some customers data, LS, ballot, and here we are missing a D. And in Benfetta, here we are having some case sensitivity. So the second name F is capital, and here the second name F is small. So what is happening here is there is a slight discrepancy, maybe a spelling mistake, maybe a case sensitivity, right? So Power BI assumes both Benfetta and the second Benfetta are 2 different entities, right? In such scenarios, and in a few other situations where you are dealing with data duplications, maybe the username for a dedicated ID, username Jack for user ID 1 and user ID 2 is also having a name as Jack, right? They might be 2 different Jacks, right? So Jack 1 is different and Jack 2 may be different, correct? 2 people can have same names. So in such scenarios, the lookup might not work properly. So in such situations, we will be using some alternate functions there. So it's like the calculate function. So we will also have a demo on that. After that, we have the match by. So that's where we'll be discussing about the fuzzy match. And we have offset. So you will be having a deep understanding of offset if you are someone who deals with databases on a daily basis. And that is something new which has been covered in Power BI. And along that, you have order by, partition by. So these are the few different functions we will be learning today. So that is the brief introduction of today's session. Now let's quickly switch to Power BI and try some practical demonstrations. So there you go. We are in the report view right now. Let's quickly shift to table view. So here we are dealing with 4 different tables. This is our orders table, customers table, and sales table, right? So in our previous session, we dealt with data modeling where we had multiple tables and we kind of established a connection, right? So if I want to try to establish a connection, I'll just drag and drop this matching customer IDs with the other tables and basically get the connection between them. I can model the data table, right? And if you are not a fan of doing this manually, you can also get that done from Power BI itself from the options which is mentioned in the previous session. So so far so good. So here we will start off with lookup values. Now we have customers data, correct? So when you look at the customers data, we have kind of 1, 2, 3, 4, 5, 6 columns: customer ID, customer name, where does he or she belong to, where is the state, country, region, is it central, north, right? And this is the basic information we have. And when it comes to orders, we have order ID, customer ID, order name, order date. And when it comes to sales, this is what we have here. And shipment is about the order date and shipment mode, right? Now, what happens is you're about to present this data to your client or your manager, and he or she wants a little more detail. Let's say he doesn't know to build a chart, build a visualization. He just anything, right? So he just wanted to add one more detail to this particular table. He wants to know which product did Toby order, right? So he wanted to have the product name right in front of customer's name. So how would you do that? So it's a simple lookup function, right? Now here we have the lookup function. So let me erase that. So it's simple. You just select okay, let me also remove this from the model. Just right click and you will be getting the option of delete this from the model. Okay, let's create it from the scratch. Now I just have 6 tables. Let us assume that we wanted to add a new column here, right? So it's simple. You just select the table, right? And after you select the table, it will be basically in the home tab. Now after you select the table, you get the table tools, right? And here select the option of new column, correct? So a new column will be generated. Now you can maybe name the column. So I'll name it as product order equals to, so lookup. So it's not a VLOOKUP, it's not a HLOOKUP, it's there's no dedicated name for that. It's just named as lookup value. So I presume it's a XLOOKUP anyways. So that's how you access the lookup function. Now what you are looking for, what are you looking for? Basically, if you're dealing with Excel, you write the lookup function, not the result, right? You actually give the address or reference of the cell where you have the value which you are looking for. But here you are focusing on the result, what you want it to have there. So we want the product name here, right? We're not giving a cell reference where you have a lookup value. It's not that way. What you're expecting to have in your column, we're expecting to have the product name, right? So the product name, various product name. So the product name is inside sales table. You can see product name over here, right? So go back to your lookup function. Here you will have the name. So the table name is sales. So you have sales and you're looking for product name. Press tab to select. There you go. Now search column. So search column is, let's say in a sales table you have customer ID and product name, and in customer table you have customer ID and customer name, correct? So there is a primary key in customer table, that is customer ID, and here you can reference customer ID as a foreign key from sales table, right? So what you're going to do is you have the product name, so you now are looking for the customer ID, right? In sales table, in customer ID column, what customer ID is there in front of a product name, correct? So okay, let's not complicate this. Let me open the sales table. So here you have the product name, right? So now you have given the first lookup value. You have given the okay, let me open the function. Okay, so you've given the required result. You've given the name. Now you are pointing to this customer ID, right? So you are pointing to this customer ID. So for the respective customer ID, you're trying to extract the product name. So that's the basic approach. Now, so we have given the first value. Now the second parameter is search value, that is sales customer ID. Press tab to select, and the last one, search value. So what you're looking for? So you're looking for the customer ID from the customers table. So what you have to do is customers table, customer ID, press tab to select. Now close the bracket, and if you enter, you will get an error. That was expected, as we discussed before. So the problem is one customer ID might have purchased different products, correct? So TS21340 might have purchased some product from technical category and some product from furniture category, correct? So what lookup is thinking is, it is thinking it is a duplication of the entry. So it is understanding it in this way. So I can't extract. So basically lookup will extract one value, right? Now here what's happening is this lookup function is trying to extract multiple values, right? So that's what it is saying. A table of multiple values was supplied where a single value was expected, correct? So there is a look around for this. Now basically I just wanted to help you understand how a lookup function works in this particular scenario. So to get the answer for this question, we might have to, make things a little different and to try to look around for the value. So we will use calculate function for this particular one. So calculate, and first non-blank, press select, and okay. So what we're doing is we are implementing a calculate function. So let's say TS21340 has 3 entries. So what we are doing is the first non-blank entry. So the first row, we are selecting that particular one from the sales product name, and we're going to filter all sales, and wherever the customer ID from customers table is equals to the customer ID from sales table, we will pick those entries. And after picking those multiple entries, we will just pick the topmost value and we will fill the product order. Just now enter, and okay, I thought we should refresh, but automatically it got refreshed and we have the names of the product being ordered. So that's how we use the lookup function in Power BI, and there is a turnaround of case in case if your Power BI is unable to detect the lookup value. That's what you can do. But there is another way, might be a difficult one. You might have to check your data set and make sure that each and every entry is unique. So that's not something which you can do overnight. So this is a quick workaround for your lookup formula. Now if we go back to the report stage and page 1, here we have filters, correct? So the basic filters, and you don't have filter by visual. There are a few more options. If you just switch back to the introduction of this course, so we had new functions, which is filter by visualization, filter by a few more operations. You can apply filter to a dedicated sheet. You can apply filter to the entire sheets. Right here you can see the option add filters to this page alone. So we have page 1 and page 2. So if you want to add a specific filter to overall all pages, you can add such filters over here. So these are the 2 filters that we already know and how they work. Now let's try a new filter, which is the filter by visualization. Let me try to build a donut chart and drag region into legends and sales into values, right? Now what we have here is a visualization. So whenever you try to build a visualization onto your page, you will find a new filter over here, which is named as filter on this visual, right? So what you can do is you can just drop down, and here you have specific filters that you can apply. And maybe if I want to apply filters for central region, I just add it and I get a central region filter. Now if I want to add category sales, I can also do that. And let's say if I want to dedicatedly find the sales that happened in both central and east, I can do that. So that's a new addition to Power BI. Not so great or not so outstanding out of the box, but this is how it basically works. Just an additional tool in the arsenal. And filters by page. So basically that's the filter what you are adding and want to work on this particular dedicated page. You can do that. If you want to add a filter that works for all the pages, you can do that over here, right? So this was filter by visual and a few more new filters that got additioned to the Power BI. And if we get back to page 1, page 2, and page 3, page 1, and data view. Okay, this is the data view. So far we covered calculate, lookup, filters. Now let's try to look around a few more additions. So if you go back to this particular documentation from Microsoft, so here we have match by. Okay, let's discuss the fuzzy match. So here, as we discussed before, so these are the data sets. Now let me open a new Power BI window and try to load that data. There you go. Let us import the spreadsheets. So we are importing the first FZ1, fuzzy match 1. Just select the sheet and load data. So we're not transforming the data, it's really small, and it's something which we created just for a demo purpose. So there are no problems with the data set as far as I know. So there is no need for transforming, you can just directly load the data. So we have the sheet 1 right here, and sheet 2 should be shortly loaded. Yeah. So the first data set is loaded. Now let's try the second one. There you go. Now we have both the sheets. Let's quickly go to the table view so that we have the table view. There you go. Now we are trying the fuzzy match function, right? For that, we should be going back to the report view, and here we should transform the data. As you can see, the column header, the first row of the column header was supposed to be considered as, the first row of the table was supposed to be considered as the column header, but it's not. So that is something which can be fixed in transformation, right? So apart from that, let's go to the transform data that we have here. And here you have the merge queries options. So you can merge it as new, and in this particular dialog box you can use this particular option which says fuzzy match to perform the merge. So what does fuzzy match does? So fuzzy match is something which gives you a threshold. Let's say that there is at least maybe some match, okay? So here we have Ben Ferner and Ben Ferner, right? So there is something which makes it different from the other. That is the capital F, right? So the case sensitivity is something which makes it different. And if you check the other ones like Ellis, so a D is missing at the end in the second name, right? So we can give Power BI some threshold. Maybe if you find a 90% match, you can consider it as one and the same, right? That's what this fuzzy match does and match does, right? So if you are looking for an exclusive tutorial on match function in Excel and match function in Power BI, we do have those tutorials. We will have them linked in the description box below. You can have a look. Now we have loaded the sheet 1 and this is the sheet 2. So here you can add the fuzzy match, and you can also choose what type of merge you want to deal with it. I'll go with the full auto one, and that's done, right? And here you have the fuzzy matching options where you can give the threshold. Maybe you can give ignore case, match by combining text bars, and you can give the threshold maybe as 90%, and maximum number of matches optional, and transformation table optional. Yeah, that should be good enough. And you can establish a fuzzy match. So this is the next part of the tutorial, and so far so good. Now what's left is maybe we can deal with okay, let's go with visual documentation. So far we have done with a lookup, filter, visual, and match, and so we are left out with offset, order by, partition by, and range. So let's continue with that. So let's quickly close this window and restart our Power BI with the file. So our data set is loaded and we have a simple table over here. So it will explain us about the city-wise sales or orders that we have received. Now using this particular table, we will try to ingest offset, window, and index into this particular data table. Now what exactly do you mean by index, offset, and window, right? So offset is something, okay, let's go to the official documentation and have a clearer understanding of offset. So offset is something which returns a single row that is positioned either before or after the current row within the same table. By given offset, if the current row cannot be reduced to a single row, multiple rows may be returned. So what exactly this means? So offset is something which gives you the value of the previous element present in the previous row to the current row. So let's say you tracked the value present in row number 2, which is the number of orders received in Chennai. Then you will, okay, let's consider offset works. If you're a user in SQL, then you know that it works in a different way, right? Whenever you give offset as 0, it will point to the first row, right? In our case, in our use case, we wanted to extract the values from the second row. So the offset will be 1. So what we are basically trying to do is trying to define some formula where the Power BI will understand how the offset operations work in a data table, right? And index is something you already know. It will just index the values you have in your data set. So basically, index will return a row, an absolute position specified by a position parameter within a specified partition, sorted by specified order. If the current partition can't be reduced to a single partition, multiple rows may be returned. So keeping it simple, not too complicated, index acts like the address to a specific row, right? Let's say you wanted to access the row number 3. If you provide a specific index, it's like the primary key. It's something which does not change. It's something which cannot be duplicated, right? So you provide an index and it'll identify the row and pull up, right? So basically what you're trying to do here is just make Power BI understand what an offset is, what an index is, and what a partition or order by, and what exactly is a window, right? So we will now get started with defining these things, starting with index. Then we will understand the next one, which is offset. Followed by that, we will dive into the window function, where we'll also use some partitions and order by functions. Having that said, let's get started with Power BI. So there you go. Just select the table or go to table tools, and let's use this drop down, and here you have the new column. And now we will get started with defining the index. So new column, it should start. Yes, there you go. So this is our index. We are trying to calculate the number of orders and we are indexing the value, and we are giving a -2, which will dedicate to the next upcoming second one, right? So here, let's say you wanted to find out the last second row, this entry, you can find it out. And in case if you wanted to find out the last but one, you can do it. And if you wanted to find out the first, then one, right? So that's how it works. And yeah, so just enter, and here you're giving the data set table name and column name, enter, and you have the index, right? Now let's go ahead with the next one, which is about the offset. Add a new column, go to column tools. So we should be creating a new column, and this is my offset. Calculate number of orders, all selected from the table and the category. So we are specifying the offset. So we want to point out to the first row, so we should be provided as 0, and enter. We will now have our offsets. There you go. There is a slight error that should be fixed shortly. Maybe some error with the data modeling or data connections. Anyways, let's continue. I think the last function is window. So there's a circular dependency identified. We should resolve that. So basically what we're trying to do is we are trying to find out the difference between the offset and the number of orders we receive. Now let's proceed and create a new measure. Sorry, new column. So here we will be trying to create a window. So there you go. So there was a small circular dependency issue that we just fixed, and here we have the window formula. And basically what we're trying to do here is identifying the number of orders we received and what's the difference between what's the offset and what's the window, right? It's giving the entries present in the current row. So this is how you can implement the index offset window.
Let's also learn about DAX expressions, and that's basically your data analysis expressions. So it's basically collection of functions operators and constants which can be used in formulas or expressions to calculate or return one or more values. Now we can basically add a new column, so we can do that, or we can also create new measures. Now usually there is a shorter way of doing it. You can go into modeling, and here as of now nothing is highlighted because there is no data uploaded. We see just a new table. What I can do is I can go to home and I can, let's get our data, but this time I'll take the simpler data, although we can work on the same earlier data set which relates to IP addresses and all that, so that also can be done. And to learn, we can take up this particular data, which is global superstore, which we have used earlier. Now here I can select orders, I can select people, and I can also select returns. Now what we can do is, before loading, we can just do some quick transformation on this particular data. So that opens up my Power Query editor. So here, if you remember, we have worked on this. This is returns. So what I can do is I can basically go in here. I can say use first row as headers. Now that's one transformation which I would want to do. Let's go into people, and it basically has person and region. We will still do the same thing, use first row as headers, so that gives me the name of the person and the person belongs to which particular region. You have then your orders data set, and here things look fine. So we can select different countries, we can select different product categories, we can basically work on your different use cases here, like we have seen earlier, picking up a category as technology, picking up a subcategory, and we can also create models based on these three data sets. So this looks perfectly fine to me. So let's go ahead and just do a close and apply, and let's have our data quickly loaded. Now, as I have explained earlier, it is good to do transformation, enough data wrangling, so that your data is not huge when you're loading it, because then that will slow down your queries, slow down your visuals, slow down your reports, and so on. Now, this is the data we have. And say, for example, I would want to work on a visual. So we know how we can do that. So I can basically click on my orders. I can look at the aggregated columns such as discount, might be postal code, might be profit. And it depends if you have basically not change the data types. Now if you see here, postal code and summation really does not go well. Probably this has been loaded as a data type which is integer, but profit and quantity looks good, row ID sales look good. So we can work on DAX expressions. Now here, if you go into the modeling, it says, do you want to create a new measure? You can create a new column that will get added to your visual. And here, when you are looking into the table, you can click on this, and this also gives you an option of creating a new measure or a new column, new quick measure, and you can work on DAX. So when I said DAX, let's quickly look at what or how DAX looks like. Talk about DAX, the simplest way to understand is knowing the basic syntax. So usually you first have some kind of measure name. So for example, we can say average about something. We can say, okay, let's say average sales. So that becomes one of my measure which I'm interested in calculating. Now, how do I calculate that? So for that, I use an operator, so which shows here. So that's your operator which you are going to use. And then you use a DAX function. So DAX has, or Power BI has a lot of functions which we can use. So for example, I would use a function like average, which we can choose from the drop down as we start typing in. Now this one as a function then needs a referred data table. So basically, let's say I would be interested in orders. So I can select my table or my data set, as you say, and then you can choose a particular column. So from orders, I would want to do an average on, say, sales, and I can key in the column name here. and that basically is my simplest DAX expression. So we can have a complicated way of looking at it, or we can basically say, okay, I would want to find out average sales, and I would want to might be look into a particular city, or where I would say it is per city. So might be I could say average sales, and then I could say by city or by year, or I would want to look into a particular year if we have the order date. So we can say greater than a particular order date. So we would want how our sales have got affected after a particular date, and that depends on the situation. So I can do that, and here I can say greater than order date. Now for that, obviously we have to use the operator, and then I would want to calculate. So I can basically say calculate. Now this is what I would want to find out. So I can say calculate, and then in calculate I can say let's take the column which we are interested in. So we can pass in something like a measure here. So for example, I can just say average sales. This is what I want, but I will give a separator here to filter out the data, and then I am going to use my order date. For example, I can basically say let's take orders, and in that I am taking order date, and then basically this order date has to be greater than or lesser than something. So here you are specifying your data set, your table, and the column. You are giving a filter here, and that's basically your DAX expression. So your DAX has different functions. So when we talk about these functions, like as I said, you are going for an average, or you're going to calculate something. So you have what we usually mean, or we use, is your predefined formulas. Now that can perform calculations by using specific values called arguments, so which are in particular order and structure. So always remember that when you talk about DAX, this always refers a complete column or a table. Now there are different categories of functions which we can work on. So you have date and time, such as date difference, or finding out now, or finding out a later time. You can use something like time intelligence, which is dates between first date and last date. You can go for information functions, which contains custom data. You can have logical functions, mathematical functions, statistical functions, text functions. You have basically working on parent-child relationships. So there are different function categories which can be used. And as I said, we can go for creating a new column or a new measure, and we can use this DAX for our data analysis. Now let's see how we do that. So say for example, I have my order date. Now I would want to work on this. So let's select, say for example, go to your data set, and you have a lot of data here. So you can basically go for all this data here, which shows me complete information of the different columns, and you can choose which columns you are interested in, which columns might be you would want to cut short. So for example, I have order ID, I have row ID, might be I don't want a row ID. So I can choose if I want to delete this, and you can say, okay, I would want to delete this. Now these are some changes which you are applying, and now if you see, there is no row ID. What we see here as a field, you start with your order ID, you have your category, you have your order date, shipment, and here you have your segment. And for example, we have country, region, market, category, subcategory, product name, sales, and then you have your quantity, discount, profit, and all of this. Now what we can do is I can basically add something here. So this is the data which we have, and what we can do is we can continue working on this. So let's click on home, and here you have ways to transform the data. You have a new measure, you have quick measure, you have new column, and you can try out these. So for example, I can go into new column, and that basically says, okay, what is your column called? Now I can say, for example, as I was explaining, let's go for average sales. So let's call it average sales. Now that's what I'm interested in. Now I need to use an internal function. So let's type in AV, and that shows me, okay, so there is an inbuilt function called average. We can use this one. So you can just hit on enter, and now it says, okay, which is the data set you're interested in. Now based on the reports, based on the data sets I've used earlier, it shows me options of different tables what we have, or different data sets what we have. So let's choose orders. So this is what I'm interested in. You can go for double click, and that gets selected, and now it says, okay, you want average on sales, but which is the column which you would want to use? So we can go for category, we can go for country, we can go for customer ID. All of these are your different columns. So for example, I can go for something like country, and that basically gets selected. Now I can complete this by just closing the parenthesis, and that's basically my DAX function. So my DAX function is ready, and if you want, you can add details to it. So if you would want to continue your function, you can always do a shift enter, that takes you to the next line. If you do not want it, you can go back. You can add a comment by saying alt shift and letter A, and then you can say my first DAX function, and you can give in some information depending on what kind of function you are creating, and that basically allows you to create the function. So this is done. Now let's hit on enter, and basically it will say the function average cannot work with values of type string, and that's right. I mean, we basically chose the wrong country. I mean, you cannot have an average on country. So that's not right. I should use something where I have to take a numeric value. So for example, I will replace this. So I will say I want average sales, and here I can choose what should I take. So for example, let's go for sales, and that's what I would want. So it says order sales, and then hit on enter, and it basically has populated my new column, but then it is basically taking average sales, and it has taken average sales overall. Now we have just selected a column, we have not given any filter, so it just gives me average, and it populates every row with this one. Now, this is fine that we have added a column. It has the same average value, and that basically gives me sales on average. So as I said, your DAX function always references a complete column or a complete table, and then basically it adds the value. Now let's see how we can use this. If you notice, the field or the column has got added here. Let's get into visualization, and what I can do is I can basically choose one of the type of visualizations. So for example, if I choose this, and say for example I would be adding this average sales, and that is the data I would want to look into. So what we can do is we can just say, okay, I'm interested in this average sales. It shows me the function, and we can add it here. Now this is just giving me the average sales overall. Now that really doesn't make sense. Let's look at this one, or plot a graph. So it gives me what is the average sales and it gives me some visualization. So we can create visualization like this based on our column. Now what we can also do is we can go back to our data and we can go for different functions. So as I said, you can create a function that adds a column. Now let's go for something else. So I will say average sales, and I would be interested in, say, a particular product. Now we have average sales, and that is the measure which we can use. So for example, I would want to find out wherein the year, or let's look at the date field here. So for example, we have country as France. It is telling me city, it is giving me customer name, it gives me a segment. So let's choose a different field and we can filter by that. So for example, I'll say average sales by, or whatever name you want to give, let's say segment. Now what I will do here is, instead of using this average, so I will go for something like calculate. Now I can go for calculate, I can go for concatenate. So let's go for calculate, and we know that we have a particular column. So let's go for this one, which is, let's open up a bracket here. So let's go here, let's give our column name. So that could be your average sales. So let's look at what was the column name, and we have average sales with A and SS capital. So let's go for average, and then let's go for sales. Now this is what I want to do, but on what? So let's choose this, and here I'm going to now choose orders. So, and then we have to basically look at the column which has the segment value. So segment, now this is what I would want to use, and then we can try giving a value to this. So you have segment as corporate. So for example, let's say, let's go for, so it says calculate, give an expression which we have already given, that's your average sales. Or we can basically give the expression what we did earlier, and then you go for a filtering value. So I'm saying order segment, and let's go for something like corporate. Now that's going to be my segment. Let's close this one. So here's the example. What you do is you give your measure name. So that says average sales by segment. You can do a calculate. Now here you have to pass in a measure. So for example, I'm saying average, and I'm saying take an average for sales. That is, give me an average value of sales. But what I'm interested in is when the order segment is corporate. So I'm giving a filter here, and then it gives me average sales by segment. So that's the column value here, and it is basically filtering out based on the segment being corporate. So segment is our particular column here, which is showing up somewhere. Let me see, where is my segment column? So we have your product. Now I have, let's search for country, city, postal code, customer ID. And since we have chosen order sales, it is giving me this average value, and you can choose a different column, or you can say profit is greater than something else. So I would be only interested in those values, and you can continue adding things to your DAX expression. And this is how you can do here. So basically what I did was, we were using a measure which is average order sales. I said my segment has to be corporate, or basically you can just say segment has to exist. So you can say a Boolean value like equals true. Now I'm saying orders profit has to be greater than 100, and I'm only looking for my average sales by segment, where profit is greater than 100, segment is corporate, and now this has calculated the value. So you basically see here, so it tells me 286. If you look at the profit value, so it is greater than 100. What I can do is I can even add a filter here. So for example, I can say greater than, and let's give some value here. So for example, let's go for 100, and let's see if it has done the work. So you see all the average values where it is greater than 100, and then we have to also look at our other values. We can filter it. So segment has to be corporate, and let's apply the filter here. So I will uncheck, I'll say corporate. Now this is what I'm interested in. So it tells me the corporate is sector. Now you see the sales value, which is already showing up here, which we have average sales by segment, which is telling me that you have corporate segment, and it gives you where the profit values are greater than 100. Now we have this DAX here, we have applied, we have the filter, and what we can do is we can go to quickly visualization, and what I can do is I can choose this, I can add it here, and then that says me average sales by segment. However, we can go for different kind of visualization which can give us more meaning here and look at the data. So this is how you can simply use your DAX expressions. Now this is a simple quick session where you are looking at the DAX expression. So when you look at this symbol, it means it is a DAX expression. So you can obviously double click on this one, and that shows you what is your DAX expression. Now, as I said, I have given two filters here. So always remember, once you have given a measure, you give your first filter, and then you can give any number of filters. You can just order it in a different line. That should be fine. Let's say average sales by segment. Okay, so let's say average sales by segment. Okay, profit greater than 100. So I can give some kind of name which basically identifies my column, and that gives me the value. Now if you see here, we have applied these filters, and that's why we are only seeing the relevant data, which is profit, which is a particular segment, and you can create any number of DAX expressions like this using some inbuilt functions. So anytime if you would want to see if your DAX expression is working fine, what you can do is, for example, I can say test function. Okay, now I would want to create a function, and then I can basically choose the available functions. As I said, you have logical functions, you have statistical functions, you have mathematical functions, you have information functions. So you have all of these options here, and you can choose one of these. So for example, we were going for average. You have and or. For example, I can directly go for and, but that would not make sense in the beginning. You can go for absolute value of something. So for example, let's choose absolute, and now I want to work on orders. So I go for orders, and here I can say, okay, I'm looking at orders, but I would be looking at sales value. I would want the exact value, so I can choose this one, right? And here, now once I am creating a function, so I can be selecting a different column. So this is basically one column. Now you can add calculation you want to do, but this basically says unexpected expression because this is a new DAG for a new column. So what I can do is I can take this out from here. I can go ahead and create a new column and then, or a new measure. So I can do that, and it works perfectly fine. Now I can save this, and we can call it whatever report you would want to call. So let's say Superstore with new DAX, and you can share it, you can publish it, you can continue using it in your reports. So you can create any number of functions as such and then just save it. So for example, I have set of DAX functions and I can upload it on a GitHub link. So here, for example, if I go in here and if I click on DAX, so that tells me the different kind of visualizations I have based on the standard data. So it depends on my file, which should be existing here. So I can go in here and this should actually work, but the location has changed, and I just click on open report. I can do a browse report. I can go into Power BI content, and here let's look into this one and just say open. So that will not only load the report, it has different visuals and different visuals with the standard data set which comes with Microsoft, and it basically has different kind of visuals, and each of those visuals again have different DAX functions, so you can use these also. So what we have learned is working on a store data set, working on some threat hunting data sets, working on our own created tables, and these are some of the pages what you see here. So this is based on the data which comes in with AWS, and you can always look into one of these and you can search. If you see here, look at this icon and it tells me, okay, this looks like a DAG function, and let's double click on this one and that shows me the function what you're doing. So you're creating a function called age. It uses date difference. It works on dim customer table on the birthday date, and you would want to basically find out the date difference between now and the birthday, and you would want the year. So this is the data what you have. You can obviously choose this, you can look at the result of this, and you can see the visuals. So these are some simple DAX expressions. You can create a lot of data expressions like this. Now this is here, you have date function, so I can choose which are the DAX functions which are existing here. I can just load them. So for example, this one is one of my other data sets, and then you can play around with the data here. So this is how you create your DAX expressions, and this was just a quick demo on going for some simple DAX expressions. You can create different kind of visuals and you can then save those reports. You can publish it to Power BI service, and you can then gather insights based on this. So this is how you work with Power BI.
Yes. So now the Power BI visuals are on the screen. You can see we have file, home, and add data to your report, visualizations, filters, data, etc. Right? For now, I think we don't have any data. We can quickly import the data onto this particular platform and start our analysis. But before we get started with that, everybody knows there are simple tricks to create all the type of visualizations, right? If I could expand my screen, here you can have all these visuals. And let's say if I just double click here and if I want any type of visual, it will just show me the visual, right? Let's say I want a bar graph for the sales happening in all the regions. So I'll just double click, I'll tap it down, give me a bar graph for sales, right? It will give you. And just in case we wanted the pie chart for the country wise, you can just give country wise sales pie chart, right? But now let me tell you a few things, correct? So if you are using a pie chart and if you are dealing with, let's say, a lot of companies, or countries, a lot of countries, like 20 countries or 25 countries, right? In that scenario, pie chart look a little cluttered, right? And let's say you wanted to find out the sales that are happening in the region wise and you asked Power BI to create a line graph for that. That would not give you the proper visual. That will not give you the proper visualization, to be honest, right? So as a beginner, if you are learning Power BI, the most fundamental thing is not just understanding how the tools in the Power BI work, what kind of visualizations you have. The most critical thing that you will need to know after understanding the basics is what type of chart is to be used for what kind of visualization, right? So that's exactly we are going to discuss today. What kind of data requires what kind of visualization. Let's say I'm working with date data type. Let's say I'm working with sales data type. Let's say there is a requirement where I need to present the data in form of table or a card. Then what are those scenarios? And if I want to use the pie chart or bar graph, then what kind of data types that I need to deal with? What are the situations where I need to use the bar graph and where I shouldn't, right? A few basic fundamentals that we will be dealing with today. So we have a wide variety of bar graphs in the first row and a wide variety of line graphs in the second row, which deal with the line graph, area graph, ribbons, etc. And in the third row, we have waterfall, funnel, scatter plot, pie chart, donut chart, tree map, and next we have map and filled map, and we have the gauge, cards, and everything, right? And here we also have a KPI, right? So we'll also go through a KPI type of chart. And if you want to learn about the KPIs exclusively, then we have the KPI tutorial in Power BI lined up in this particular series. So you can also go through that. And after that, we have some slicers and we have tables and we have matrix, right? So a wide variety of charts available, correct? So we will try to understand the major ones. The first row, bar graph, which are the scenarios where you need to use the bar graphs. Next row, we have the line, right? Line area. So all these come under one kind of set. They are similar to one another. So which is a scenario where you can use a line graph? Which is a scenario where you can use a waterfall or a funnel chart? Which is a scenario where you can use a scatter plot? Which is a scenario where you can use a pie chart, right? A wide variety of probabilities, a wide variety of permutations and combinations. So what are the exact needs? What are the exact visualizations that carry a value, that carry a meaning to the stakeholder? Which are those particular charts which explain the numbers in the right way possible? So that's the point of today's discussion. So to begin with, let's import the data first from the Excel document. So we will be using the Excel data over here. Just click OK. Now you have a wide variety of tables which are present in that particular workbook. We are dealing with the data tab. So just click on it, select and load. If there are any mistakes or if there are any discrepancies, Power BI will let you know, and it has the caliber to also fix those particular data rows, right? So there is 1 or 7 errors right now. You can choose to close, but the overall tutorial is about learning the type of visualization, right? So 7 rows out of 10,000 will not make a huge difference for us right now, because we are trying to just understand the basic understanding of what type of charts to use. So I'll just quickly close this, but in case if you want to fix, you can just click on this view errors and the Power Query will open up in the background. You can just switch to the Power Query tab and fix the data rows where they really need to be fixed, right? So let me close it for now. And now in a short notice, you can see we have the data loaded here. Now we have 2 types, but if you let us imagine that you're on Tableau, and on Tableau you have 2 things, dimensions and measures, right? So measures is self-explanatory. Anything that deals with numbers is called as measure, and anything that deals with characters or names or anything such which is not a number is considered as a dimension, right? So here we have category, city, country, customer ID. So these are the ones which can be considered as dimensions, and where you have a summation logo or a mathematical symbol right in front of it can be considered as a measure, right? Now let's say we wanted to create the month-on-month sales report, correct? Which deals with the data type. So just data type, right? Just remember, whenever date is included in your parameters, either you're adding it to the rows or columns, just make sure that you are using the line chart, which is over here. So let's quickly rename our page to line charts or graphs, correct? Now we have named it. Now you can either choose to double click and add that, and then here you have x-axis and y-axis, or you can just drag the order date, expand this order date, and the hierarchies over here. So if you want to go with the month on month, you can simply add this to x-axis, and you can have your sales data somewhere over here. Drag this to y-axis. This is one way of creating it, but in case if you don't want to waste time in this particular huge process, you can just choose to simply double click on the canvas and write it over here. Line chart sales month. Just click and there you go. Right, brilliant. Now if you choose to spotlight, or you can just expand this, right, and if you choose the spotlight, you can see a vertical line showing you the numbers. Correct, we start from January and all the way to December, right? And here you have the month on month sales. So remember, whenever the data type is included in one of your parameters, then the best way to represent, the best way to visualize the reports will be the line graph, right? With that, let's switch to the next one. Now, since we were supposed to discuss the bar graphs first, but it's okay, not a problem. So let's discuss the bar charts now. Let us know the data set first. So we have sales, profit, discount, numbers, etc., right? And we have region-wise, city-wise, category-wise, country-wise. So let us go with category. Now, let us go with category and try to build a bar graph. Just double-click anywhere and category. Okay, bar graph. Okay, if not category, you can also choose to have subcategory. Okay, GRAPH. Just take care of your spellings. I think I missed an R over here. Bar graph, subcategory, enter sales. There you go. So you have your chart right here. If you just expand it, you can see we have a wide variety of subcategories, and Power BI was kind enough for us to, sort the data in form of highest ticket price or highest selling product in the first place and the lowest selling product in the last place. So this is how the bar graphs work. But just in case, if you can tell me, why couldn't we go with a, let's say, pie chart, right? Let us also check that. If I just click on this, what happens? You can see a lot of cluttered data, right? You have a lot of subcategories here, more than maybe 10, right? So in this scenario, the visuals are a little displeasing and you don't have the accurate value over here. Just undo it and you have the bar graph, which is a little clearer to look at, a little more, decent to understand what's happening. You can just focus on the top 5 over here and you can understand what's going on, right? Now you can just rename them as, and you can choose to go with any kind of bar graph, vertical or horizontal, or in case if you have a few more, let's say we go with the category first, and under the category you have subcategory, then you can also go with that, and you have an overlapping type of graphs over here, stacked bar graphs, which can show you in that particular category which was the product which was highest selling, right? Now you can also add that, whereas the category, right, you can just choose that. Okay, so I think we can open a new tab, and okay, so we have the bar graph. Next we have waterfall. So let's open and let's name it as waterfall. So waterfall is something which period performance of that particular property or that particular entity. Let's say I wanted to find out the year on year or date wise performance of that particular subcategory. In those scenarios, I can go with waterfall. So just simply double click and ask Power BI to create a waterfall model, waterfall chart, enter space sale. There you go. So it's giving you the period over period sales report of subcategories, and the green line indicates that it is slowly growing in terms of sales, and the red one shows the decline in sales, which is not happening anywhere. And this is the total, the overall the overall subcategories. So it will give you a waterfall model, and the overall total of that particular segment is this much. And now we have dealt with subcategory waterfall model, and let's try to create a ribbon chart. So ribbon chart and the area chart, those are similar to one another, stacked area and ribbon chart. So ribbon chart will give you the performance of that particular product in the timely, if you want to see the performance of that particular product in measured in terms of time, let's say month on month, quarter on quarter, year on year, day by day, that can be done using the ribbon chart, similar to the line chart. But anyways, let's take a look. I'll name it as ribbon, and just double click the Power BI canvas, ribbon chart, or just ribbon, subcategory, enter, sale. There you go. If you write order month, you can also track the monthly performance of those products, right? You can see a steady decline, you can see a steady upline, and so here you can see the months, and here you can see the different colors of months. Different colors represent the months. So here are the products, and based on the products, how's the monthly performance, right? Is it declining or is it increasing? You can find it out. You can basically find out that. And moving ahead, we will deal with scatter plot, right? So first we dealt with the bar graphs, next we dealt with the line graphs, and now we also dealt with waterfall, funnel, which is something similar. Next we have stacked chart, scatter plot chart, right? Now scatter plot is a little different. Let's say you're dealing with numbers, only numbers, nothing different. Usually what we do is we carry out a dimension and a measure, right? But in this scenario, you want to deal with only numbers. Let's say you are providing some discount on all your products, and you wanted to know the profit against the discount offered. Here you are dealing with two numbers, profit and discount, right? So in those scenarios, what do? So that's when you find out by using the scatter plot. Just double click on the canvas, write it down as build me a scatter plot. Just check the spelling, SCATTER, scatter, discount, enter, and profit. Now it will create a scatter plot based on discount and against the profit. Now you can give some dimension. You can go with subcategory. There you go. Now you have the profit obtained against the discount offered based on different subcategories. Just expand it, and you can see in which subcategory what kind of discount was offered and what kind of profits did you make. So 25% discount was being offered on accessories, and you made a profit. Still you made a profit of $33,000. And here you can see almost 200 discount was offered, and still I think that is 1+1 offer, or maybe end of the season sale, but still they made a profit based on some parameters. And here you can see the least discount and highest profit. Okay, the least profit and the highest discount is in terms of tables, which is 33%, the maximum out of everything, and they still did not manage to earn some good profits out there. So this is how you create a scatter plot. Just quickly name it as scatter. And next we can deal with the pie chart. Now just double click on the canvas, pie chart, region, sale. So you have 4 to 5 regions here, and using a pie chart would make a good impact on this particular visual, as everything seems clear and you can easily make out which particular region made the highest sale by just looking at the size of these pieces, right? Now let's quickly name this as pie, and now let's move to the, you can just you can use the same data for creating a donut graph. You can use the same data used to create a tree map, and yeah, those are similar to one another. And let's quickly jump, and now let's create some maps. Right now When do you need to use map type charts? Let's say your data set has some geographical data, something like city, something like country, something like continent, right? Or longitudes, latitudes, anything which gets in touch or gets in line with the geographical data, then you can proceed and build the map data types. I mean the maps, correct? So something which is related to the map data type, you can build a map. Now, let me double click on the canvas and ask Power BI to create a map, country, sales. There you go. You have, as simple as that, you have the country-wise sales on Power BI right here. You can also choose to have filled map, which will show you how much sale is happening. The darkest color will indicate the highest sale and the lightest color will indicate the lowest sale. Now, moving ahead, we have the cards and gauge. So cards and gauge are completely similar to each other. Just click on the Power BI, double click. You can write card, country. Okay, let's go with region because we don't want to go with, or we don't want to have multiple cards. We just want to have 3 to 4 cards on our dashboard. So we'll go with category, sale. So I'll just have a card here, right? You can just keep it anywhere on the corner. In terms of real-time dashboard, you can just keep it anywhere. And let's name it as card. Now let's proceed and create a KPI. So multi-row card, you can also create a multi-row card. Let's say you have, let's go back to card and check it once. So if you create a multi-row card, we have 3 categories. And you can also add the subcategories of each category. So that's similar to a multi-row card, correct? Now let's go back to the last type, or we have KPIs and table. So KPIs and table are completely similar to each other. Let's try to go with the KPI. Now we have discount, profit, sale, and quantity, correct? So KPI is something which gives you the direct real-time number of what's happening with your real-time dashboard, correct? Now, how many number of products are sold? What's the overall sale that we performed? What's the overall profit that we received? What's the overall discount that we offer? In terms of one single dashboard, you can create a KPI for that. Now, let me create a KPI discount first. That's as easy as that. Now KPI for the profit, enter. There you go. Now double click. KPI for sale, enter. There you go. And lastly, KPI for quantity. There you go. Now that's how you create the different types of charts. So basically, if you integrate all these charts into one page or one dashboard or one canvas, that's what you call as a real-time interactive dashboard in Power BI. And again, coming back to the slicers, if you were using Excel, you might have to interconnect each and every single chart using the report connection option. But in Power BI, you don't have to create that particular report connection process. You can just click on the slices any of the chart, and you can click on any of the options. Let's say you wanted to find out country-wise sales. You can just click on the country provided, right? So here somewhere you had, you have Jan, Feb, and everything, right? So if you just click on Jan, every chart available on the Power BI dashboard will connect to it. Connect to the different dependent charts and give you a real-time information without having to create or report connections to each other, right? So basically, if you just add all these charts onto one particular canvas, that's when you get the real-time interactive dashboard in Power BI. And so I hope you have understood what kind of chart you need to use based on what kind of data you have. So here we can see we have already loaded the data, we have the filters, visualizations, etc. And we have the canvas over here, right? So in the visuals section, if you closely observe, you have the KPI over here, right? So you can either select and drag it onto the canvas, or you can just simply double click and create a KPI. But before that, what exactly is a KPI, right? It's the key performance indicator, right? It's a full form of KPI. So what exactly is key performance indicator? Let's say we have the sales dashboard over here, sales data set over here, right? Now we have region-wise sales, we have country-wise sales, we have region-wise profits, we have region-wise discounts, we have quantity, right? So it's like a visual, it's like a number, clear, literal, readable number right on top of your dashboard, right? So if you just want to have a quick glance of how many number of sales you made, how's the profit happening, how's the sale happening, how's the discount that you're getting, right? And how many number of quantity of certain product is being sold in a segment, right? So those are the key performance numbers which will be available right on top of your dashboard. So that's exactly what you call as a KPI. Now how do you create a KPI? So one way is you can just hold the KPI and drag it onto the canvas, or so this is one way of creating the KPI. Let's remove this. Now another simplistic way of creating a KPI is just double click anywhere on the dashboard or the canvas and you will have this. So just write what kind of KPI you want to create. So I want to create KPI for sales. Just create that and you have your KPI there. Now another one, KPI discount. Just click on that, you have the KPI for discount. Double click once again, KPI for profits. You have the KPI for profits. Now KPI for quantity. There you go. That's how you create KPIs in Power BI. Should you need to arrange the KPI sizes or color or background, you can also do that by just simply playing around the sections over here, right? The background or the outline section over here, you can just play with it.
Now, let's understand what Power BI Dashboard is. Power BI Dashboard is a single page visualization to tell a story. Here on the screen, you can see there's a dashboard which has been published on Power BI service. There are multiple charts and graphs that you can see. The visualizations on a dashboard are generated from reports, and each report is based on one dataset. A single page dashboard is known as a canvas. The visualizations you see on the dashboard are called tiles, and each of these tiles are pinned to the dashboard by report designers. Today, we'll be covering the following dashboard that you see on the screen. It will be a 3-page report where we will be analyzing the Superstore sample data. As you can see, there are 3 tabs. Now let me move over to our data set. So our Superstore sample data set is in the form of an Excel file. You can see there are multiple columns. You can see there's order date, shipment date, the mode of shipment, customer's first name and last name, the segment to which the customer belonged to, country of the customer, the city, state, and if you go towards the end, you can see there are the different product names, the sales, quantity sold, discount, and the profit. So the report that you see here and the one which we are going to create might vary a little in terms of the color formatting and the spacing, so you need not worry about that. Now let me go ahead and bring up a new workspace. So I'll go to File, click on New. This will take some time to bring up our new workspace. Now it will ask you for trying the free version, or if you want you can go ahead and sign in. I'll just close this. So here is our new workspace. Before creating the dashboard, we need to make some changes to our Superstore dataset. Using the features of Power BI Desktop, first we'll extract the year, month and quarter values from the order date column. I'll go to Get Data tab, click on Excel as my source. I'll locate my file, it's on desktop, click on Open. This might take some time to load the dataset. I'll select the orders sheet. You can see the preview of our data here. I'll go ahead and click on Load. This will take some time to load the dataset onto Power BI Desktop. I think we have successfully loaded our dataset. You can check that by going to the Data tab. So here is our dataset. First, let's make some changes in the format of the order date and the shipment date. I'll click on the order date. Under the Modeling tab, we have this data type and the format. I'll click on the drill down option. Under date and time, now let's choose the first one, which is in the format of DDMMYYYY. I'll click on it. As you can see, our order date column has been changed to that particular format. Similarly, I'll select the ship date column, go to the format option. Under date and time, I'll click on the first one. Here you can see even the ship date column has been changed to that particular format. Now let's extract the month values from the order date column. To do that, right click on the order date column, select new column. So this will create a new column if you go to the end. So there's a new column. rename this column as month, and since we want the month value from the order date column, I'll search for order date. Dot, since I want the month, I'll select month. Now if I hit enter, it will give me the month values from the order date column. Similarly, if you want to get the quarter values from the order date, right click, select new column, rename the column as quarter, then choose the order date column followed by the quarter name. Hit enter. So you can see you have a quarter column and it has all the values of the quarter to which the date belongs to. Now let me go ahead and create one more column. This time we'll create a new column for the order year. This time we'll extract the order year values. So let me rename it as year. We'll continue with the same procedure. I'll look for the order date and then select the year. Hit enter. So it gives you only the year values on which the order was placed. Now let's find which day of the week was the order placed. So we need to use the weekday function and give the order date as parameter, followed by which day you want the week to start with. I'll show you how to do that. So I'll click on order date, then select new column. Let's rename this column as day of week. I'll use the weekday function of Power BI. You can hit tab to finish. I'll look for my order date column, comma. I'll choose 2 here since I want my week to start with Monday and end on a Sunday. Hit enter. So you can see we have the day of the week column. So the idea to create this day of week column is to find out if the order was placed on a weekday or a weekend. Now let me go ahead and create one more new column. Let's name this column as weekday or a weekend. I'll use an if clause and pass in my parameters. For logical test, I'll use the day of the week column. So I'll search for orders and then look for day of week. If this day of the week is equal to 6, which means if it's a Saturday, or I'm using the or operator, if the day of week is a Sunday, that is 7, then it's a weekend, else it's a weekday. I'll close the bracket, hit enter. So you can see we have our weekday and weekend column. So moving ahead, another thing we can do is we can find the total number of days it took for the shipment of the product. This can be done using the dative function of Power BI. So let me show you how you can do that. I'll click on any column, right click, go to new column. Let's rename the column as days for shipment. Then I'll use the datediff function. I'll give my starting date, which is the order date. So I'll search for order date, followed by the second date will be our shipment date, which is ship date, and the day. I'll hit enter. So you can see here it gives us the total number of days it took for the shipment of the product. Now let's create a full name column where we will concatenate the first name and the last name of the customer. Let me go ahead and do that. I'll create a new column. Let me rename the column as full name. Then I'll take the first name from the orders table, use the ampersand, followed by a space using inverted commas, followed by another ampersand and the last name. I hit enter. You can see we have a full name column. If you go back, so there were 2 columns in the name of first name and last name. Now we have merged both the columns into a single column named full name, and you can see the first name, space and a last name. Now let me give the sales column a currency value. So I'll select the sales column. Here under general, if I go to currency, I can see there are multiple currency symbols. Choose whatever you want. For this video, I'll take $English United States. you can see our sales column is now represented by a dollar value. Similarly, let me make some changes to the profit column. As you can see, there are multiple decimal values for each profit. So let's standardize it. So I'll select the profit column, and this is where you can standardize it. Now it's auto. So let me make it 2 decimal places. So our data is ready now. Let's go to the report view and start building our reports. Before that, under the model view, you can see the new columns that we had created. You can see there's weekday, weekend, there's year, there's quarter column, month column. The same you can see under the report view as well. Under fields, you can see these are the columns that we created: days of shipment, day of week, quarter, month, weekday or weekend, and year. Now we are under the report view. First, let me go ahead and create a text box. So under the home tab, you have the text box. I'll select that. Let me stretch it a bit. We'll give a title, Sales Dashboard. I'll select this and increase the size to, let's say, 28. We make it bold and center align it. Also, under the Visualizations tab, under Background, we'll add a background color to this text box. Let me select this blue color and let me make the font as white. So now we have our title ready. So under General, you can decrease the height of the text box. Let me make it as 70. First, let us create a new card from the Visualizations panel. So under Visualizations, there is an option to create new card. I'll click on it. Let me resize. I'll move it to the top. We'll see the total amount of sales or the total revenue that was generated from the sales. After selecting the card, I'll choose Sales onto Fields. So here you can see it gives you the total sales that were made, so which is nearly $2.3 million. If I go to the Format tab under Data Label, let me switch on the border. Under Title, you can give a new title, for example, Total Revenue. Hit enter. Now you can increase the text size to say 15 and center line it. You can also change the color of the sales value. So under Data Label, under Colors, you can choose whichever color you want. Similarly, let's create one more card to find the total number of units that were sold. I'll copy the same card, Ctrl C, Ctrl V. I'll move it a little below. Now I'll remove the sales column from the fields and add the quantity column onto fields. Again, under title, I'll edit this title as Total Quantity Sold. Let me create one more card where we will see the total amount of profit that were made. I'll select this. I'll remove the quantity column and add profit. Under the Format tab, under Title, I'll make this as Total Profit. Hit enter. Stretch it a bit so that you can see the total amount of profit that were made. Now, let me add a slicer wherein we'll have the order date column. So I'll add the order date column onto fields. So you can see here we have the order date column, and under slicer header, let me increase the text size to 15 and let's switch on the border. You can also give a title to the slicer. So under the Format tab, go to Title, switch it on, and we'll give a title text as slicer by order date. Scroll down, I'll center align it and increase the text size to 15. Now if you want, you can also change the date colors to blue. So under date inputs, you can go to font color and select any blue color. Now let's create a line and stacked column chart to visualize sales and profit by each year, each month and each quarter. So from the Visualizations tab, let me select line and stacked column chart. I'll resize this. After that, let me add the order date column onto the shared axis. We'll drag the sales onto column values, and under line values, I'll take the profit column. So here you can see we have the sales and profit by each year. The bars represent the sales and this line represents the profit it made for each year. Let me go to the Format tab and make some changes to the data colors. Let the color of the profit remain the same, but the bars, I'll choose a custom color, give a hexadecimal value like 196273, hit enter. So we have successfully changed the color of the bars. Power BI has an interesting feature where you can drill down the sales by each year, each month, each quarter, or by days. So let me show you. So on the top, it shows you go to the next level in the hierarchy. So if I click on this, here you can see the sales and the profit that were made for each quarter in every year. Quarter 4 for every year made the highest amount of sales and the profit. Similarly, if I drill down further, you can see, let me expand it, you can see by month. This is for each month over all the years how much sales were made. You can check November month gave us the highest amount of sales and December month gave us the highest amount of profit. Similarly, you can still go to the next hierarchy. Here you can see the sales and the profit made for each day over all the years. So day 17 made the highest amount of sales and day 23 gave us the highest amount of profit. If you see the lowest sales and the profit, you can see order date 25 gave us the lowest amount of profit, and similarly you can see day 29 gave us the lowest amount of sales. Now you can also go to the Format tab and switch on the data labels. So you can see here in 2014 we got nearly 49.5k profit and nearly $0.48 million sales. Similarly, in 2015 we had nearly 61.6k profit and 0.47 million sales, and so on. Now let me go ahead to the Format tab and switch on the border. Let me now create a clustered column chart for sales by year and quarter. So from the visualizations, let's select clustered column chart. Let me resize this a bit. And under axis, we'll add the year column. So I'll drag year onto axis. Under legend, I'll take the quarter column. And under values, I'll choose sales. So you can see here the sales that were made under each quarter for each year. This picture clearly says quarter 4 for every year made the highest amount of sales and quarter 1 made the lowest. Let me go to the Format tab and I'll go to the data colors. Let's change the colors for each of these quarters. We'll be using hexadecimal values. So under custom colors for quarter 1, let me select hexadecimal value as follows. So for example, PF D6 D9. Similarly for quarter 2, I'll select 6D9 BA6. For quarter 3, and finally for quarter 4, I'll choose a little darker color So here is how our clustered column chart looks like, and we can see the sales by year and quarter. Now let me go ahead and let's add a border. Now we'll analyze the sales by each state. So for that, we'll use field map. So I'll click on field map. Let me resize it. Now let me add the state column onto location. Under tooltips, I'll add the sales column. Let me expand it. So you can see here we have the map which shows the sales by each state. Now let's do some color formatting to this. I'll go to the Format tab, click on Add Colors, and blue is the default color. There's an additional option where you can use conditional formatting. So I'll use that. So it gives you the option to choose your color between maximum value and the minimum value. You can also choose this diverging option where you get a center value or a mid value as well. Now for the minimum value, I'll choose a color. Again, I'll use a custom color. It will be similar to a green color. I'll hit OK. Then let's use some orange color for the mid value range. For example, EB. And similarly, for the maximum value, we'll use a little darker color which looks similar to red. Click enter. So now we have defined our color scheme. Let's click on OK. Let's zoom out. So you can see the states which are in green color made the lowest amount of sales, while those which are in orange or in red made the highest amount of sales. So in this example, you can see California had the highest amount of sales. Similarly, New York is next, is just below California with the amount of sales, followed by Texas. We'll go back. Let me also add a border to this. Similarly, you can also select the profit column or the units sold column to see the units or the profit that were sold by each state. So let me now go ahead and create a donut chart. In that donut chart, we'll analyze the sales and profit by each segment. So under visualizations, I'll click on donut chart. So under legend, I'll add the segment column. Under values, I'll take the sales column, and we also want the profit, so I'll take the profit column onto tooltips. So you can see we have our donut chart prepared, and you can see the sales and profit by each segment. Let me expand this. The donut chart indicates consumer segment made the highest amount of sales and profit, while home office segment made the lowest. I'll go back. Let me go to the Format tab, and we'll make some formatting to our data. Let's change the color of all the segments. Choose custom color. Let's give a color coding as 1558C. Similarly, we'll change the color for corporate segment as well. Let's take a gray color. And finally, we'll change the color for home office as well. I'll also switch on the border. So we have our donut chart prepared. Now let's move ahead and create a pie chart to analyze the profit and sales by each category of products. So under visualizations, I'll select pie chart. I'll drag the category column onto legend. Under values, I'll take the profit column, and under tooltips, I'll take the sales column. So you can see we have a simple pie chart that tells you the profit and the sales that were made by each category. As it's evident, category technology made the highest amount of sales and profit, while furniture category made the lowest amount of profit and sales. I'll go back. Under format, I'll change the data colors. Let's go ahead and do that. I'll use custom colors and give a hexadecimal color value. Similarly, for office supplies, I'll take another hexadecimal value. And finally, we'll change the color of the furniture category. Also, let's give a border. So we have a pie chart prepared that tells you the profit and sales by each category of products. Now we are done with our first sales dashboard. So I can go ahead and rename this tab as overall sales. Next, we are going to analyze the sales, profit, quantity sold and all of these by taking region and the state as filters. So we'll continue with the same drill. First, I'll create a text box. So under home menu, I'll go to text box. I'll stretch this. I'll give a title to this page, for example, region and state level analysis. Let me make it bold and I'll increase the size to 28, make it center aligned. We'll make the text as white and under visualizations, let's give a background color. I'll choose this blue color. So let me go ahead and create 3 slicers, a region slicer, a state slicer and a year slicer. So under visualizations, I'll click on slicer. Let me resize, move it on top. And for region slicer, I need to add region onto fields. So you can see we have a region filter now. Let's do some formatting to this. Under slicer header, let me make the font color white and let's give a background, let's say blue, and let me increase the text size to say 15. You can also choose a font family. Let's go for Calibri and you can increase the size of the items. Let's increase the text size to say 15 and let's give a border. So now you have the region slicer ready. Let me copy paste this. Next, we'll create the state slicer. So I'll remove region from here and add state onto the field. So you can see we have the state slicer ready. Similarly, you can also go ahead and create a year slicer where you can analyze the sales and profit or quantity by year. I'll remove state from here and I'll drag the year column onto field. You can see we have all the 4 years from 2014 to 2017. Now sometimes it might be difficult for you to scroll through all the values present in a slicer. For example, in the state slicer, you can see there are multiple states. And if you want to filter your report by a particular state, you have to always scroll down or scroll up and check manually where the state is. So Power BI gives you this feature where you can use the search option. So if I click on this, you can see there's a search option. Select that. So now in the search bar, you can search for any state you are looking for. For example, if you want to search for California state, you can just type on California. So I have just typed CAL and it shows me California. That's an important feature that Power BI gives you. So let me now go ahead and create a simple table where we will see the quantity and the profit made in each city. So under visualizations, I'll select tables. Let me resize this. So under values, first I'll add the city column, followed by the quantity column and the profit column. Let's do some formatting. So under column headers, let me change the font color to white and let's add a background. Let me increase the text size also. Let's make it 15. Similarly, if you scroll down under values, let's increase the text size to 15 as well. And let's choose the font family. Let's take Consolas. So here you can see all the cities, the quantity sold in each city and the profit that was made in each of these cities. Now let me add a border to this. So now you can filter each of these cities by region or by state. For example, if I choose Central as my region, it will give you all the cities that lie in the central region. Similarly, you can also search for any state. For example, I am taking Minnesota. So under Minnesota, you can see all the cities and the quantity as well as the profit they made. Let me now uncheck the filters. Now let me go ahead and filter this table in terms of profit. So I'll sort by profit. You can see we have our cities sorted in terms of profit. So New York City made the highest amount of profit, followed by Los Angeles and Seattle. Below you can see the total units that were sold and the total profit that was made from all the cities. So you can also filter down the quantity sold and the profit made by each year as well as by region and state. So let's see. Suppose I am choosing East as the region. So under East, it tells you the states that are present. Let's go for Delaware and let's select 2016 as my year. So you can see the cities that lie under Delaware state and the quantity as well as the profit they made in 2016. Similarly, let's select Massachusetts as the state and let's go for another year, for example 2017. You can see all the cities that are present under Massachusetts, the quantity sold and the profit that was made. Below you can see the total quantity and the profit. Let me uncheck all these. Now moving ahead, let's analyze the sales by each state and the category of product. For this, we'll create a clustered bar chart. So under visualizations, I'll select clustered bar chart. Let me resize a bit. Under axis, I'll take the state column. I'll take category onto legend, and under values, I'll put the sales column. So you can see here, we have the sales for each category under each state. For example, California state made the highest amount of sales under technology category and it made the lowest amount of sales under office supplies. If I scroll down, you can see all the states and the sales they made for each category. I'll go back to the report. Now let's use some filters. You can filter here. For example, if I want to check the sales by each state and category for 2015, I can just click on 2015 and it will tell you the sales that were made. Now let's do some formatting to this bar chart. We'll change the colors for each of the categories. Similarly, we'll change the color for office supplies. And finally, for the technology. So now we have our bar chart ready. Moving on, Now let me add a border to this bar chart. Okay. So now that we have seen our sales by state and category, let's now check the profit by year and category. For that, we'll create an area chart. I'll resize this chart. Now, under axis, I'll take the year column. Under legend, I'll take the category column. And under values, I'll take profit. And so we have our area chart that depicts the profit by each year and the category to which the product belongs to. I'll go to the Format tab, and under Data Colors, I'll choose some colors. Let's change furniture to this blue color. I'll take office supplies a red color, and technology I'll use a green color. So now you can use the filters. For example, you can check the profit that was made by each year and category under East region. So you can see here, in 2017, technology made the highest amount of profit, while furniture had the lowest. Similarly, let's check for South region. So you can see in South region in 2016, technology made the highest amount of profit and furniture made the lowest. In 2017, office supplies made the highest amount of profit and furniture was the lowest. I'll uncheck this South region filter. Similarly, you can also see the sales by each state. So under state slicer, you can choose whichever state you want and check the profit it made by that year or category. For example, I'll choose Connecticut. So you can see the profit Connecticut state made in each of these years. I'll uncheck it. Let us move ahead, and now let's see profit that was made and the quantity that was sold by each category and subcategory of the product. So for this, I'll choose the line and clustered column chart. So I'll select from the visualizations. Now, under shared axis, I'll select the category column. Under column series, I'll take the subcategory column. Under column values, I'll choose profit, and I'll choose quantity under the tooltips. So now you can see the profit that was made under each category and the subcategory. For technology category, copiers subcategory made the highest amount of profit. The quantity sold was 234. Similarly, if you check for furniture category, we didn't make any profit for tables subcategory and as well as for bookcases. Under office supplies, paper subcategory made the highest amount of profit. Now let me go ahead and add a border to this. Fine. Moving ahead, now we will see the sales by each segment. For that, let's create a funnel. So from visualizations, I'll take the funnel and I'll drag segment onto group and the sales column onto values. So you can see here the sales that were made by each segment. This picture clearly depicts that consumer segment made the highest amount of sales. Next was corporate and then home office. Now let's do some color formatting. So the default color is this blue. I'll click on show all. Now we'll give individual colors to each of the segments. Using custom color, let's give a hexadecimal value. Similarly, we'll change the color for the corporate segment. And finally, for the home office segment. Now let me go ahead and give a border to it. So if you want to analyze the sales by segment and for a particular region or state or any particular year, you can do that. So let's select for East region and let's take New Jersey as the state for year 2014 suppose. So you can see here corporate segment made the highest amount of sales, followed by consumer and home office. Let me uncheck these filters. So our second report is ready, where we analyzed the sales, quantity, profit at region level, state level and by year. So I can rename this as region and state. Next, we will analyze the sales, quantity, profit in terms of categories and subcategory of products. So let me first copy this text box and create a new tab. I'll paste that text box here and change the title to say category and subcategory level analysis. First, we'll create a slicer where we'll take the category as filter. So if I want, I can directly copy it from my previous tab and change the fields. So let me copy this and paste it here. I'll sync it and let me remove the region field and add category onto the field. So you can see we have the three categories here. Let me copy paste this again and let me take the subcategory now. So I'll select this and I'll drag subcategory onto the field. So here you can see we have all the subcategories and above we have the categories. Let me resize this a bit. With that, now let's analyze the sales and profit by region and segment. To do this, we'll use a tree map. So let's see how you can build a tree map. Under visualizations, I have tree map. Let me select it. I'll move it to the top and expand it a bit. Now, under group, I'll select a region column. Under details, I'll take segment. I'll take the sales column under values and let's take profit onto tooltips. So if I expand this, you can see the sales and profit by each region and segment. For example, in the West region, you have consumer, corporate and home office as the segments, and you can see consumer segment made the highest amount of sales and profit, while home office made the lowest amount of sales and profit. Similarly, you can check for the other regions as well. Now, let's give a border to this tree map, and under data colors, let me change the color of the regions. Scroll down, custom color. Let me choose my own color. Let's take this as a gray color. And finally, for the West region. So now you can select individual categories and subcategories to check the sales and profit by region and segment. For example, if I select furniture as my category, you can see the changes that were made to the tree map. You can also select office supplies and see how the sales and profit changes. Similarly, you can also go ahead and select whatever subcategories you want and then check the sales and profit by region and segment. With that, let me now create a pie chart to see the quantity and the sales by each segment. So I'll go and select a pie chart. Let me resize this. If you want, you can increase the size of this tree map also. So let me go ahead and select segment onto the legend. Under values, I'll take quantity and sales under tooltips. So this pie chart depicts the quantity and the sales that were made by each segment. As you can see, consumer segment made the highest amount of sales and had the highest quantity sold, while home office had the least number of quantity sold and the least number of sales. Let's add a border and change the data colors. Similarly, I'll change the color for the corporate segment. Let's make this gray, and home office, I'll take the following color. Move this a little to the right. Now, let's build a scatter plot to analyze the sales, quantity and profit by each subcategory. So under visualizations, I'll select scatter plot. I'll resize this. So I'll add subcategory onto legend. Then I'll add sales onto the x-axis, quantity sold onto the y-axis, and under size, we'll take the profit column. If I expand this, you can see the sales, quantity and the profit that was made for each subcategory of products. You can see here, subcategory phone has given us a significant amount of sales with less number of quantities sold, and it has given us a good amount of profit also. Similarly, subcategory chairs has also given us good amount of sales with close to 2356 quantities sold and a good amount of profit. If you see this one, which is subcategory paper, it gave us less amount of sales with more quantities sold, while it gave us good amount of profit though. So you may promote phones or for example chairs to sell more, since it gives you more amount of profit with less quantity sold. Let's add a border to this. You can use the category filter. Suppose if I choose for furniture and expand this, you can see under furniture, subcategory furnishings gave us the lowest amount of sales with the highest number of quantities sold, but it gave us a decent amount of profit. Subcategory tables gave us a decent amount of sales with lesser number of quantities sold, but didn't give us any profit. Subcategory chairs gave us the highest amount of sales and also the profit. I'll uncheck this. Let's now create a line chart where we can see the profit by each year and quarter. So under visualizations, I'll select line chart. Let me resize this. So under axis, I'll take year. Under legend, I'll take the quarter column, and under values, I'll take the profit column. So now you can see the profit that was made each year and the lines depict each quarter. So if you check for 2014, quarter 4 made the highest amount of profit, while quarter 2 made the lowest amount of profit, while quarter 1 made the lowest amount of profit. Similarly, if you see for 2016, you can see quarter 4 made the highest amount of profit, while quarter 1 made the lowest. If you check for 2017, you see quarter 3 and quarter 4 almost made the same amount of profit, while quarter 2 made the lowest amount of profit. I go back. Now you can filter these by categories also. Suppose if I see for technology, you can check the amount of profit that was made in each year and in each quarter for technology category. Let's add a border to this. Likewise, we'll now create another line chart that will depict the sales by each year and quarter. So let me copy paste this. I'll drag this to the right. Now I'll remove profit from values and add sales. Let me uncheck this also. So here you can see we have the sales by each year and quarter. Now if you see for 2014, again quarter 4 made the highest amount of sales and quarter 1 in 2014 made the lowest. If you see for 2016, you can see 2016 also quarter 4 made the highest amount of sales and quarter 1 made the lowest. We'll go back. So our final report is ready where we analyzed the sales, quantity sold, the profit at category and subcategory level. I can go ahead and rename this as category and subcategory. Let me save this. Now if you want, you can also filter it by subcategories. For example, if I select chairs as my subcategory, so for chairs you can see the sales that was made by each year and quarter. So in 2017, quarter 4 made the highest amount of sales while quarter 1 made the lowest amount of sales for chairs. Similarly, you can select other subcategories also. For example, let me take some other category like machines. Let's see the profit now. So for machines subcategory, you can see in 2014, quarter 4 made the highest amount of profit while quarter 3 made the lowest amount of profit. Now if you check for 2015, you can see quarter 3 made the highest amount of profit in chairs while quarter 1 made the lowest amount of profit. Let's uncheck this. So now we are almost done building our report using the Superstore sample dataset. So we have our 3 reports ready. You can see the first one was overall sales. The second report we created by taking region, state and the year as filters. So we had a region and state level analysis. And finally, we analyzed the sales, quantity and the profit sold by category and subcategory. So I have arranged all these graphs and charts so that it looks a little better. Now let me go to this publish option on the top so that we can publish this report onto the Power BI dashboard. So I'll click on publish. I'll save it. You can select the destination. Here I have only one destination, which is my workspace. So I'll choose it and select. So there you go. Publishing to Power BI, it was successful. I'll close it and let me move to my Power BI service. I'll refresh it for once. So under my workspace, you can see we have the dashboard report. So below you can see there are 3 tabs that we created. The first one is overall sales. The second one is sales by region. And the third one is by category and subcategory. Now, to put these reports onto the dashboard, I need to pin each one of these visualizations. So let me pin one by one. So it asks where would you want to pin it to. I'll select the existing dashboard. Or better, let's create a new dashboard. Let's say Power BI dashboard, spin it. I'll close this. Similarly, let's spin the remaining ones. I'll select Power BI dashboard again, pin it. Let's spin everything. So this slicer, you can't pin it. Let's do the remaining ones. Same will do for the donut chart as well as for the pie chart. Now if I go to my dashboards and select Power BI dashboard, you can see we have a one-page dashboard here. You can resize all the charts and graphs. Let me resize it and move it to the top. So we have our first canvas here, which tells you the overall sales, the profit, and the units that were sold over different states, different segments, and by categories. So one of the important features that Power BI service gives you is that you can ask questions about your data and it will tell you what the exact solution is. For example, you can see here you have a field where you can ask questions. So for example, if I type total sales and hit enter, so it tells you the total amount of sales that were made, which is $2.3 million. Similarly, if I want to find out the total profit, I can search for it here, hit enter. It will give you the exact amount of profit that was made. Let's do something else. For example, if you want total profit by, say, year, I'll hit enter. It gives you a nice line chart where you can see the total profit that was made over all the 4 years. Next, suppose I search for total quantity sold by segment. See, it gives me a bar chart where you can see the total quantity that was sold, and it gives you a list of options where you can find out the total quantity that was sold by city, state, order ID, first name, last name, and many others. So consumer segment had the highest quantity sold. Let's see for something else. For example, if you want the total sales by, say, subcategory, I'll choose the first one. See, you have all the subcategories and the total sales that they made. So it's a very interesting feature that Power BI gives you. Go back. Now, if you want, you can go to the report menu, and if you want, you can pin the other visualizations as well. So another important feature about Power BI dashboard is that you can derive insights from the visualization. For example, if I click on these dots, there's an option you find, View Insights. I'll select it. So on the right, you can see Power BI has itself given us some insights from the data and the visualizations we have made. You can see sales by year and quarter, the sales by day of week and quarter, sales by shipment mode, where you can see the standard class ship mode made the highest amount of sales. You can also see the sales and count of city by year, and many more.
Now without further delay, let's get started with what is row-level security in Power BI. Now imagine that you're working in an organization and you have different subordinates. Let's say you are the creator of this entire data dashboard, or if you are the manager and you have some subordinates. So they might be of a different designation, which is lower to yours, and they might have subordinates in the leaf node level or the lowest level, right? So they might not have complete access to your dataset. Let's say you are dealing with 6 or 7 dashboards, so you'll have access to everything, and your subordinates might have to deal with only 2 of those dashboards. Let's say the sales which are happening in West region and East region. So their subordinates might have only access to few stores. Let's say if the person working with the West zone has 2 subordinates, then he might have access to 2 or 3 different stores which are available in the West zone, right? You're getting my point, correct? So you might have access to all the 5 zones. Your subordinates might have to deal with individual zones, and their subordinates might have to deal with individual stores. That is, the level of hierarchy divides the accessibility to the data you have. So you're giving this accessibility because you don't want to mess up the whole data set. Your subordinates might not have an idea how a dashboard of the data set is working, or they might, some reasons. Due to some reasons, there is this row-level security implemented on Power BI. Now, let's have a check on this row-level security or RLS in Power BI in a practical demonstration. Now, we will be dealing with the same Superstore data set. So, we will be trying to create individual row-level securities for different zones of sales that we have in our data set, and we can have a view how it really works. Now let's quickly switch back to Power BI so that you have a better understanding on what exactly I mean about row-level security. Yeah, we are on our sales dashboard on the data set that we were dealing with, the sales data set. Now, this particular dashboard has all the 5 regions. So here you can see central, north, south, east, west. So this is the overall sales dashboard. This deals with the sales order, month on month, and sales based on country, sales based on category, sales based on subcategory. And here we also have the KPIs, the total quantity of products sold, the total sales, total discount being offered, and the total profit that we have earned, right? Now this is an overall dashboard. This is the dashboard that you have access to as a manager. Let's say now you want to distribute or divide or segregate the accessibility based on zones so that your subordinates work on those only zones, or focus on the zones which are provided to them, so that they don't have to deal with the entire dashboard that you're dealing with. Now that can be done by using the row-level security. Go to modeling option here, and here you have manage roles. So click on manage roles, and you have access to provide the row-level security. Now you can create a new role here. Let's create a new role. Now name the role as Adam for North, and let's create another one, Jennifer for South, John for West, Ramsey for East, Kumar for Central. Correct. Now we have created 5 rows. Now let's provide Adam with the North data. So here you can just double click on data, add a filter, and go to region, and in region you can provide the value as North. There you go. So your DAX expression is perfect, no errors. You can just click on save, and a new region for North has been created. Just go back to manage roles and try to apply this to everyone. Add new filter, go to region, and we're giving Jennifer the South region, and for John we are giving West region, and for Kumar we are giving the Central region, and Ramsey, the last one, will be dealing with East region. You can save. There you go. Now you have applied the row level securities to individual employees working on individual zones. Now just to quickly check if they are working or not, you can quickly save the current dashboard, and it is done. Here you have a view option. You can just click on view, and here you have all the views that you created right now. You can just click on Adam for North region, and your dashboard will change, and it will give you the sales happening for North region. Similarly, if you go on checking for different roles, you have different regions. So that's how you can create the row level security. And when it comes to the end user, if you want to give this particular row level security or access to that particular zone to your end user, you can just publish your dashboard and all your row level securities to your Microsoft Power BI service, and you can provide the access. So that's how basically the row level security works in Power BI.
Now the first question, what exactly is Power Automate? So Power Automate is a cloud-based service that automates repetitive tasks across apps and services. It's designated to help users optimize business processes and focus on more strategic tasks. Now, it is not just confined to Microsoft products. It can also be attached to Google or any other applications as well. If you want to roll out some emails via Gmail, or if you download some files and store it onto Google Drive, Power Automate will always support it. Now, let's proceed to take an overview of how to use this Microsoft tool. So, some of the mundane tasks like sending out an email, scheduling some roosters or meetings, or some points of the meeting, it'll always be a lengthy task that consumes a lot of your time. Now, for a sample task like sending out daily emails, we will try to automate this task. Now, we have logged into the Microsoft 365. So here, you can have some apps over here and you can check out the app for Power Automate. Now, we can just go to all apps and here you can just scroll down. And here you can see the option that says Power Automate. There are other ways as well. You can just search for the Power Automate app and find it out in apps here. Or now you can just find it here. You can just log into the Power Automate app. So Power Automate already has some templates for it, right? So you can just navigate to templates and there are many uses of Automate. So if you want to do with some email attachments, or if you want to trigger a Power BI data-driven alert, or if you want to, set up something in your Microsoft Office, or you want to put a notification, or if you want to download all the attachments from your email directly to your Google Drive and connect your, X or Twitter, you can do that. So there are multiple people who have already used Microsoft Power Automate and they've already delivered some templates for the ready for use purposes. And if you want to go with some topics, you can also go with this. Or if you're working with remote work kind of style and you wanted some applications or some automation things you are looking for, you can also look at the templates which are remote work related. You can just go through all these templates and go ahead with that. Apart from that, if you're looking for some data collection type of automation, you can also do that. And if you're looking for an email automation, you can also do that. And if you already have created some flows, you can just go through this and find the flows that you have worked on. So I've got one flow already ready here. I've set up an email, that you can be sending out to your reportees, or you can send out this email to your fellow developers or fellow colleagues. And if you have some approvals, you can also do that. So there are a lot of things. So as we discussed before, we will go with the automation of sending out daily reminders. So I'll just type down get daily reminders and I get this type of automation here where you'll just send out an email reminder to the outlook.com email, which can be about an email to check the numbers, check the reports, and hand it over to your fellow team members, right? So or it may be about a scrum meeting or a roster meeting or roster setup. So I'll go with this one. And here you have the recurrence and Office 365 Outlook. So this is my email and I'll just continue. And here is the flow. So here you can just click and you can give out an interval. Maybe if you want to give it every day, or if you want to give it weekly or bi-weekly, you can set it up. So I'm going to go with every day, and here you can set up any prescribed or if you have any type of time zone that you want to select, you can go ahead with that. So I'll go ahead with anything here. I'll go with Alaska maybe. And you can also provide some time. It's not a mandatory one. And apart from that, here you have some hours you want to select. Maybe I'll go with 10 a.m. in the morning. And also I want another setup at 6 p.m. which might be the logout time. And yeah, this is the one. And apart from that, just go back to the flow once again. And here you have to set up few parameters. So let me give out an email here as well, the recipient email. You can add multiple, but I'll go with one. So I'll add one email recipient address here. That's the one. And apart from that, subject could be about Scrum call. With report updates or with numbers, with number updates. You can give anything according to the business needs. And you have a reminder. And I think I'll add the same subject here. There you go. And you can also provide the importance. So I'll go with high importance one so that the recipient will understand. So far you have set up the flow. I think it's fine. So you have no more notifications here. This says the flow is completely fine. Now you want to save this flow. And once the flow is saved, you can proceed and test it. Just click on this. It's saved, and if you want to try and test it, you can also do it. Just test it, and It can happen in both the ways, automatically or manually. I'll now go with the manual one so that I can just cross-verify if this is happening or not at the current time. Right? We set a timing 10 a.m. in the morning and 6 p.m. in the evening, right? So it only happens twice. But now if you want to run it at this particular instance, you can also do that by just testing it, right? I've tested it and I have sent out the, yeah, it finds good. And now if I select run flow, then it will run the flow. Now it has already done. No, it's successful. No problems here, and done. And you can now just, kind of log into your Outlook email, and then check the email, right? Just a second while I log into my inbox. There you go. Now we have this particular email that we sent right now. You have a reminder, Scrum call with numbers of date, and you can just reply or forward it. So this is how you can just automate the emails with your Power Automate, and you can just send out email reminders to your fellow developers or teammates on a regular routine. And that's how you automate a lot of simple things as your daily tasks. And I've already created 2 here. And if you go to templates, you have a lot of other templates here, most are picked. Or if you're looking for a dedicated one like data collection, email, calendar, mobile, etc., you've also found them there. And if you're still in confusion, maybe you can just type down and find the templates which are in match with your requirements. Firstly, the first question is, what are the different types of filters in Power BI reports? So if you are an experienced candidate or a beginner, these type of interview questions are the ones which you're definitely going to face. So coming to the answer, what are the types of filters you'll be facing in Power BI reports? So there are 3 main filters available in Power BI, which are visual level filters, page level filters, and report level filters, which are almost self-explanatory. So if you want to be someone who stands out of the group, just to mention a couple of more like slicers, which can also act some type of filters there, right? So visual filters, page filters, and report level filters are the 3 main types. And if you want to add onto it, you can also add in some slicers. Right now, let's proceed to the next question. Explain DAX in Power BI. So what exactly is the meaning of DAX? And to improvise your question or to improvise your answer, or if you want to outperform, you can also explain with some of the explanations or implementation of DAX in your nearest examples. Like if you're a beginner or if you're a fresher, if you're working on a portfolio, then you can give the example of your DAX implementation on that portfolio. Or if you're an experienced candidate, just explain your latest implementation of DAX in your previous projects. So the answer for this question is, DAX is basically the full form for data analysis expressions and is a formula language used in Power BI, Power Pivot, and SQL. DAX includes functions, operations, and constants that can be used as a formula expression to calculate and return one or more values. So DAX, just understand it in this way, right? So if you are about to perform an analysis, or if you're about to extract some insights, for example, you own a superstore, right? And you wanted, okay, let's assume that you own a superstore and you have 5 regions, north, south, east, west, and central, and you are providing products from a few categories, let's say IT, mobile phones, desktops, everything. And now you wanted to identify one zone which is giving you highest sales in mobile phones, and you wanted to identify one zone which is giving you least sales in mobile phones. In such scenarios, you can just write up a formula equals to mobile phones product and products minus products which are less than a specific number. You actually wanted to identify products less than 100 mobile phones, right? You just want to know if there is any region which is selling less than 100 mobile phones. Then you can extract that. So the expression what you're writing there is nothing but a DAX expression. So apart from this example, you can also put up some complex examples if you're an experienced candidate, or if you're a fresher,
then you can come up with some DAX expressions that you build on your portfolio projects. Moving ahead, we'll discuss the third question. How does Power BI integrate with other tools and services? So there might be a situation where you might have to get connected to different sources of data, right? So let's say you wanted to import Excel data as well as some service like a cloud service. You want to extract data from a cloud service as well. So how can you do that? And if you want to do that, can you do it, right? So that's the question. So basically this is a kind of question which comes up from two different zones. Can you integrate or can you connect to two different sources of data? Or in case if you can connect, how to connect, right? So it's like, is it possible to connect? There's also a question to beginners to test your knowledge on the fundamental knowledge on Power BI. They want to know if you can connect data from two different zones. It's not like two Excel sheets. They want to know from two different platforms altogether. Let's say I have data in Azure. Let's say I have data in SQL. So can I connect them both? Yes, you can do that. So the answer for this question is Power BI offers extensive integration capabilities with various Microsoft products like Azure, Excel, SQL, and some third-party services as well, like a website, any application, or a database, SQL databases, Excel spreadsheets, and other cloud services like GCP, AWS, etc. So that's possible. So you just have to, let's go for a demonstration on this. Not a complete demonstration. Let's cancel this. So here, if you just, it's just like a overview how to connect. So here, if you see, we have Excel workbook, semantic models, data flows, Dataverse, SQL Server, web, OData, feed, blank query, and if your source is falling different from these available ones, you can just click on more and select any one of these options right here, correct? So with that, let's get back to the next question. What are the differences between Power BI Desktop and Power BI Service? So the terms are self-explanatory. If you're an experienced candidate, then you can define the answer right away. But if you're a beginner, especially if you're a fresher, then you must be a little cautious here. So if you are building your portfolio, if you are learning the fundamentals of Power BI, then you are doing it using Power BI Desktop, right? But if you are a professional or an experienced candidate, then you are developing the interactive dashboards, you are developing the interactive charts and graphs and everything, and you are providing that visual, only the dashboard to your end user, who's your client. So in that scenario, your client will be given the Power BI service module, right? So they will be having a service access only just to watch the visuals. So the answer for this question is Power BI Desktop is a free application. So it's not completely free. So there are situations where you might have to deal with some huge data, or you have to deal with some parameters like security, everything. In those scenarios, you might have to go with the licensed version. So for a learning purpose, it is a free application installed on a local system that lets you connect to transform, visualize, modularize your data, and few more implications that you can do. And on the other hand, Power BI Service is a cloud-based service that allows you to share, as discussed, only to share and collaborate on and distribute your Power BI reports and dashboards with others within your organization. So client is partially a part of your organization because he has some business to do with your organization. So basically, understand it in this way, Power BI Desktop is something which allows you to build. It will give you the blocks, you build the visualization, and then you give a screenshot or you give a picture of that particular build to the end user. He can have a visual on it, how it is performing. He doesn't have to worry about how it is working in the background. He doesn't have to worry about how big or how large is your data set, how it is extracting, what API is it using, what's the... He doesn't care about it. All he cares about is the visual. How is his business doing? So in that scenario, if you just want to give a picture, that's when you use the Power BI service. Now, let's go with the next question. How do you handle security in Power BI? So this is a question given to the experienced candidates. So you can think about it about the access, row-wise access. Let's say you are the leadership team, and next is the manager, next is the individual contributor, correct? So here the full access, the full visuals of your business, how your business is going on, how are the leads, how are the revenue, how is the RPL, how's the traffic, everything is visible to the leadership or the manager, correct? But when it comes to the IC or individual contributor who is just working on traffic, he will have access only to traffic, not the leads, not the revenue generated, not the RPL and everything, because he has nothing to do with it, and that is something which you can't reveal to an IC for data security purposes. So you can also consider this in the way of inheritance, right? So you can divide it based on the level of the employee, right? So level wise, you can provide the access to your employee, to your manager. If you're a developer, let's say, so based on the employee level, based on the manager level, based on the leadership team, you can give separate access to separate candidate. So the answer for this question is Power BI provides row-level security RLS, which allows you to control access. So you're basically controlling the access to the data for different users within your organization. You can define rules on the dataset that filter the data based on the user rule. Additionally, Power BI integrates with Microsoft Azure Active Directory to provide authentication and authorization. Now, the sixth question. What is a content pack in Power BI? Content packs are a type of package that includes a related set of dashboard, report, and data elements they use to share insights, reports, and datasets with colleagues and organization within a broader audience. Power BI also offers organizational content packs, which allows users to quickly connect and analyze data from popular business applications. So basically, content pack, you can imagine content pack as a set of charts, graphs, or a complete dashboard or dataset elements. So when you integrate all those inside a bubble, that particular bubble can be considered as a content pack. Now moving ahead, we have the seventh question. Describe a scenario where you improvised performance of a Power BI report. So let's say this is, so basically before we answer this question is for an experienced candidate, not for an intermediate or not for a beginner level, right? So if you are someone who has 3 to 4 years of experience, that is when this kind of questions are suited. So explain a scenario where you improved the performance of a Power BI report. So there are certain scenarios where, let's say you're working with business data, Amazon sales data. So you have Amazon sales data or any other data for a beginner purpose. Okay, let's say some XYZ company. So you're working with XYZ company and you have sales data from a past couple of years. And your client asked you, last year this particular dashboard was working fine, but down the line when we entered the new quarter or new annual year, I can see there is some discrepancy or I can see there is some delay for the Power BI dashboard to load. Now there can be multiple reasons for this. The first reason could be the hardware setup, or maybe the data is increasing day by day, so the hardware is not supporting. So that could be one reason. And provided if there are some visuals which are already created, visualizations or graphs or dashboards, and we are not mostly using them, so those can be one of the reasons. So in these scenarios, you can just give some explanations which you already faced in your current organization. For example, like you can say the client is not willing to scale up the hardware, like the hardware which stores the data or something like that, is not ready to scale up the hardware, but he wants to use the same hardware, but he wants you to increase the speed. In this scenarios, you can eliminate the data which is not currently in use. Let's say you're using 2020, 21, 22, 23 and 24 data. Now all you focus on is the year-on-year growth. So You just need 2022, 2023 and 2024, not 21 and 20, right? You can erase that data from your existing hardware or servers. This will ease up the load on Power BI and automatically there should be an increase in speed. Another one, if you have already created some visualizations which you're not currently using, let's say you already created 2 to 3 dashboards and you rely on one dashboard alone, not the rest of those two, you can delete those visualizations. So something like that which can help you. But to consider this question as an assignment, I would like the viewers who are an experienced data analyst to answer the question in your way possible so that the viewers can benefit from multiple answers. So you can write down few scenarios where you face this problem and how you solved it. It can be a one-line answer, it can be a points which you can mention, right? A set of points which you can mention that helped you to improve the performance of your Power BI end report. So the answer for this question which I have is, in one scenario, I improved the performance by optimizing data model, reducing the number of unnecessary columns and rows in data sets, and utilizing summary tables to decrease the data volume that needed to be processed. I also replaced complex calculations in the report with simpler ones, which were possible, and used direct query mode for real-time data requirements to speed up a report loading times. So this can be a good answer. You can also add up some answers from your end as well to benefit the viewers. Now let's go with question number 8. Explain the difference between a measure and a calculated field. So this can be an important question for freshers especially, right? So me personally, I've asked this question to the candidates many times. So the answer could be a little tricky, right? So most oftenly the question can be asked as what's the difference between measure and a calculated column, or measure and a calculated field, or measure and dimension, right? So the answer should be like this. Just pay attention to what the answer, interviewer is asking you and answer wisely. If he's asking you the difference between measure and dimension, it's clear, self-explanatory. So something like measure is something which can be measured. The number is a measure. Let's say the salary is a measure. The average of marks obtained is a measure. Marks obtained in a specific subject is a measure. Rate of interest is a measure. Traffic is a measure, right? So when it comes to dimensions, something like a character data type, maybe, and name of the store, and let's say we had various regions in the previous question, north, south, east, west, central. This particular data which cannot be measured is called as a dimension. Now for this question here, what's the difference between measure and a calculated column? So calculated column is something which you generate out of a calculated field, right? Whenever you try to, let's say you have the quantity and you have the price, but you don't know rate of each product, correct? In such scenarios, you can write up a calculated field and build a new column called rate of product. That particular column is a calculated column, which is newly generated after writing a calculated field. So the answer for this question is, calculated column creates a new column based on existing data using formula. It adds to your new, it's added to your existing table as a new column, as we discussed. Measure creates a dynamic calculation that summarizes your data. Measures are used in visualizations to analyze trends or answer specific questions. Now with this, let's move on to the next question. Describe the process of publishing a Power BI report to service. Now this can be an answer for both, this can be a question for both freshers as well as experienced. So now you can give it a try. You can give me the answer for this. You can write down your answers in the comment section below. And everybody has their own way of answering this question. But as simple as that, let's keep it normal. Now in Power BI Desktop, go to Publish and choose Power BI Service. Select the Workspace to publish and configure settings like sharing access. Click Publish to upload your report to Power BI Cloud Service. So this is the answer given by most of the experienced candidates. But when it comes to freshers, it's okay if you answer in this way. Create multiple charts, create multiple graphs, understand the requirement of the end user, build the required charts and graphs, integrate all those charts and graphs to the dashboard. It's also a good way to tell it, but if you're an experienced candidate or if you're a beginner, just try to include these points as well just take a step ahead and go a step further and answer. Include these points in your answer. Go to publish, select Power BI service, select workspace, right? So these will enhance your answer and make you stand out from the other crowd. Now, let's continue with the 10th question. How would you handle missing data in Power BI? So this can be answered for both, this can be asked for both the beginners as well as experienced candidates. So it's obvious, if you're a data analyst, it's obvious that your data will not have completely filled rows and completely filled columns, right? There is a possibility that you might have blank rows. There is a possibility that you might have blank cells. There is a possibility that you might have irrelevant data. There is a possibility where it can be a typing mistake and you might insert special symbols in place of numbers and special operators in place of alphabets. Everything is possible. So in such scenarios, how could you handle, right? So there are multiple approaches. So let's say if you are going through some column which you feel is not mandatory to create your report, you can ignore those cells and you can just delete it. And in case of there is a discrepancy in your existing data and you find that is important, then you can always have a way to go back to the source who provided you the report or who provided you the data, as to complete them, as to give them the right number. Or in few scenarios, you can also, if you don't want to eliminate any kind of rows and columns, you can also have an option of taking an aggregate value in it. Maybe the minimum value, maybe the maximum value, may be an average value in that particular missing cell. So there are multiple possibilities, and if you feel like adding those answers, you can also feel free to add them so that everyone is benefited. So my kind of answer is, there are several ways to handle missing data. Filtering, where you can exclude, simply that's the first one. You can just ignore those and exclude those missing values. Replace missing values with some aggregate values. Custom logic, create a DAX formula to address missing values based on specific scenarios. Now let's move ahead with the next question. How do you connect multiple data sources to a Power BI report? So the answer is, Power BI allows connecting various data sources. You can directly import, directly use live connections, or create composite model to improve and combine data from different sources. So this is not just the Power BI dashboard. You're here, it's not just the Power BI desktop. You're not just importing data. It's related to the real-time dashboard report. So if you have a report and you ought to connect some external source, some real-time streaming data, you can do that using some live connections and APIs. Now let's move with the next question. What are data flows in Power BI? So the answer for this question is, data flows in Power BI are cloud-based preparation and management tools that allows users to ingest, transform, integrate, and enrich big data from various sources. They are designed to simplify data preparation and enable scalable data integration and storage across multiple Power BI projects. Now the 13th question. How can you handle data updates in Power BI? So this is also one of the simplest but also the trickiest question. Let's say you already connect. Let's say we are dealing with Excel data, and your client provided you the Excel data, and you already created a dashboard out of it. And out of your knowledge, you don't know, right? You might not know what happened after they shared you the data, and the client gets to know there is some discrepancy here, there is some irrelevant data, or there is some missing value in the data provided to you, and they added and you missed it, correct? In those scenarios, how can you handle data updates, right? You can either refresh. So there are multiple answers for that. So let's go with the answer. So data updates in Power BI can be handled through scheduled refreshes or real-time streaming datasets. Scheduled refreshes. So let's say you provide some 6-day or 1 week or 1 day based on requirement. You provide a scheduled refresh, and it will act upon it, and it will refresh its source every single time. It basically refreshes the dashboard you created. It will extract the data from the source, and it will create a new report out of it. So scheduled refreshes can be configured in Power BI service, allowing data to be updated at specified intervals. Real-time streaming datasets can be used for dashboard tiles that require continuous updates. Now, the 14th question on our list. Can you explain the concept of a slicer in Power BI, right? So those who already are comfortable with the Excel, they might know the answer for this. So it's completely similar, right? So let's discuss the answer. A slicer is a Power BI visualization used to filter the data. Basically, it's nothing different from filter, right? It's just an option like a drop down that you create in Excel using the data validation. That's the same in Power BI as well as Excel. You just have a slicer option where you can provide your selection and it will give you an end report. So basically, it's a filter. So it provides a way for users to filter the data that is displayed in other visualization on a report page. Slicers offer a more interactive and intuitive way to make selections and see the data that changes dynamically as selections are made. Let's say you have class 10, class 9, class 8, and you wanted to just check the results of class 8. You just select the option of class 8 on the slicer and you have the report. So that's how it basically works. Now, the last question for today's session. What is direct query in Power BI? So the answer for this question is direct query is a connection type in Power BI that allows you to directly connect to a supported data source, enabling real-time reporting capabilities without importing or copying data into Power BI while it offers up-to-date data. It also limits certain functionalities and might impact performance based on the query load on the source system. So with that, we have finished the top 15 Power BI interview questions and answers that are frequently asked in a data analyst interview provided for both freshers as well as experienced. Should you feel that we missed out on any of the important questions that you might have already faced in your previous interviews, please feel free to let us know in the comment section below, and so we can have them answered, or you can also provide us the answers so that it can benefit both of us and also the viewers.
And with that, we have reached to the end of this session on Power BI full course for beginners. Should you need any assistance or any other resources used in the session, like PowerPoint presentation, dataset, or any others, then please do let us know in the comment section below, and our team of experts will be happy to assist you as soon as possible. Until next time, thank you for watching and keep learning. Stay tuned for more from Simplilearn.